So good morning, everybody, and a very warm welcome back to day 2 of this international forum, Connecting the World from the Skies. So we had a fantastic day yesterday, and I really think it's full of a huge amount of new content, of discussion, the format of having the varied sessions, the technology demonstrations, the keynote presentations, the thoughtful discussions, the panel discussions, I think really broke things up nicely, and for me, it was a fantastic day. And we're looking forward to what I'm sure is going to be much more of that today. So just before we start, I wanted to remind everybody that we don't just want to be hearing from our speakers up here, we want to make sure we're hearing from all of you out there in the audience here, and of course, all of you watching us online as well. So there's going to be a QR code, which hopefully can come up on the screen in a second, which you'll be able to see here in the room. And we also have the opportunity for everybody who's watching at home to put any questions, any comments that you have in the chat on the right-hand side of your screen. So you can see there the QR code. For those of you in the room, if you do have any questions, any comments, please scan that QR code. You can add your questions, and those will be passed on to the moderators for the various sessions today. Reminder as well that all of the proceedings from yesterday were recorded and are available to download. So you'll receive an email with the links on how to download those, and you'll be able to view all those again. And also all of the slides that were made yesterday are available to download as well. And again, for today and tomorrow, again, everything is being recorded so you can watch back everything that you missed. So just to let everybody know, we have been streaming the event out live on YouTube and also on the CST Twitter account, and we had an amazing 700,000 people across the Twitter account, CST account, in the Arabic and the English version who tuned in at some point yesterday. So it's absolutely fantastic to have a huge number like that watching some of the live feed that we had of the event. So, on to today. So, as I said, we have another packed day ahead of us. So today, we're going to be having 6 keynote presentations, including one, which I'm delighted to say, we're going to be having His Excellency, Professor Isa Ali Pantami, Minister of Digital Communications and Economy of Nigeria, who's going to be joining us later today. We also have 2 more panel discussions. We have 4 technology demonstrations that we're going to be running today, and including one which is going to be a live demonstration. So later on today, at around about 6:40, we're actually going to be linking up live to a location on the east coast of the US, and we're going to be having a demo that involves the live launch of an aerostat. So that's something to really look forward to there. And we also have one more thoughtful discussion today. So lots going on. And you'll all be pleased to hear that at the end of all that, we do have the opportunity for us all to relax a little bit. We're going to be having a networking reception, which will be taking place out on the mezzanine area, just at the back of the auditorium. And that's going to be hosted by Altairos and World Mobile. So lots going on, so I think we better get started. So to kick things off today, I'm delighted to welcome to the stage the first of our keynote speakers, and giving a presentation that's going to be looking at towers in the sky. I'd like you all to help me welcome to the stage Greg Ewart, Vice President of Intelsat and Vice President of the HAPS Alliance. Greg, welcome. Over to you.
Well, good morning, everyone. Day 2. As Dan just said, I thought day 1 was absolutely fabulous as we're starting to talk about collaboration through the sky, the initiatives that we're seeing with NTN, some of the technologies that are around that. Today I'm going to be wearing my hat from the Treasurer and Vice President of the HAPS Alliance. As you heard, I'm also Vice President of Strategy and Business Development at Intelsat. But today, I'd like to walk you through a couple slides, and then we're going to do some Q&A. What I'm trying to bring forth and impress upon you is a word I heard a lot yesterday, and that was collaboration. We all know that to unleash the power of technologies that we see in front of us, we're going to need to work together. There's no one network, no one technology that can meet the needs of the insatiable appetite of data. So I'm going to talk a little bit about why we put the HAPS Alliance together, some of the foundation memberships that went along with that, what the mission around it is, and how we want to bring more people into this organization so that we can make sure that we make HAPS a success that we believe it can be, as well as in the stack of NTN. So we'll start with a little video. I noticed everyone had videos yesterday, so I had to race home last night and put a video in here. So I think you'll understand some of this here in a minute. Perfect. That gives me a little backdrop to talk to you today about the foundation of why we decided to put the HAPS Alliance together. I have to pass credit to fundamentally the two foundation members. One was Google while they were working on their Loon project, as well as the other one was the Airbus Consortium and SoftBank. Intelsat came in toward the latter part of this foundation, but the goal was everyone understood the power of what HAPS could be. But we also knew that to make it a success, we had to make sure that there were 3 or 4 pillars of a stool that we thought were important. One was the commercial adoption. You know, there's got to be a marketplace for this. We need to go out and listen to what the customers want in various different aspects of this business, and I could talk a little bit about that more later. Safety and regulatory. Coming out of the traditional telecom environment, we are now talking with a whole new category of organizations from a regulatory front that are quite frankly unique to us. As we start thinking about the ConOps of sending HAPS from ground to the stratosphere, we have to now deal with regulators from the FAA, ICOA, different organizations. So again, when we took a step back and said, well, as a telecom infrastructure company, we're not good at doing that. Who is good at doing that? Airbus is great at that. They build platforms for aircrafts. They know the regulators. So again, that was a key pillar of why Airbus is so important to the HAPS Alliance that we have. Collaboration cross-industry. Again, as I said, you're going to see some different platforms. There are balloon platforms, there are fixed-wing platforms. Some are powered by solar, some are powered by hydrogen, some will be powered by a technology that maybe we haven't heard of right now in the next few years. So bringing together that eco-structure was important to us as well. Lastly, and this is working with academia, publications, coming to events like this, quite frankly, thought leadership is also important. Explaining where the value comes in some of the different key verticals that we see HAPS can play a role in. So all around that comes the coalition of the HAPS Alliance and where we're taking this through. I really wanted to get a logo slide up here, but I was informed by my marketing people that it's too big. The one thing you'll see here and that this slide I think demonstrates is the power of the partnerships that we have out there. If we're looking at the MNOs that are out there, the Deutsche Telekoms and the Docomos, some of our satellite friends at JSAT, SoftBank, who I just talked about, KDDI Corporation, all these people are coming together, bringing not only their knowledge from the industry, but also the experience that they have within their key areas of expertise. Bringing that all together, I think, is very powerful from the standpoint that we have put together. Ericsson, you see Nokia, they're really helping us understand where we're going with respect to Open RAN technology, where we're going with respect to some of the communications of laser links that go between here. So I can't say enough about this slide and the power. At the end, I'd also like my little sales pitch to ask more of you to be involved in this because I really do believe it's a powerful organization. One that's missing off here is Stratospheric Platforms. So I want to announce today that they've just become a member of the HAPS Alliance as well, and I appreciate that. So from a regulatory standpoint, there are 3 areas that we're looking at right now. I talked a little bit about the aviation regulation and standards. Again, it's very important for us to lean into this organization and help them understand what success means. What we don't want to have is regulators coming back to us not being educated and forcing bad decisions on us. So it's very important for us to be out in front of this process. Same thing with 3GPP and standardization. I think we heard a lot about standardization last year as well, and again, we are big proponents of Release 17, what it's actually doing for the industry, not only in HAPS specifically, but when we look across the entire NTN spectrum of different applications and product bases. Frequency band spectrum is another issue that we're working with. From the very beginning, we've been involved with the WRC all the way from 19, looking into 23 next year as well as looking and talking to MNOs and specific regulators in their countries. I think yesterday, too, we heard one of the regulators that talked a little bit about how we can share and utilize spectrum differently in the future. Again, I think some of the technology that we're starting to see with regard to MIMO technology, being able to more efficiently split your spectrum and utilize it and share it on a non-interference basis, I think that also is going to open up a lot of opportunities for HAPS. This more goes back and talks a little bit about collaboration with not only the people in our industry, but reaching outside. One I want to spend a little time here on is, and I thought this was a major coup for a satellite industry, and also an emerging HAPS industry, to be able to break into the world of MNOs. The M&O industry is, more than $1 trillion of an industry. When you look at a satellite industry, you're talking about a wholesale business model that's maybe $23 billion. So we're actually moving into this much larger pie of opportunity, revenue, productivity, et cetera. We put together a white paper, and you can find it on the GSMA website, and it basically, from the perspective of customers working back to the technology, what is it that you need to be commercially successful in HAPS? It was well thought out, got a lot of great reviews from the industry. The HAPS Alliance is pleased to also state that they are picking up the second phase of that, and that's going to involve more of our platform partners to start really thinking about what does the business model look like? What are the cost elements that get put into this to make sure, again, that it's commercially viable? I continue to come back to commercially viable because, again, if this doesn't make sense to our investors and the customers out there, then it's something that we probably shouldn't be chasing, and I'm a big proponent of shareholder value. I think we saw this yesterday. I think this is the prize, and this is one of the big things that we're trying to overcome. 2.9 billion people still around the world, they're unconnected. That's a pretty amazing number, and I think we jumped on that yesterday quite a bit and talked about that. When I look at HAPS, I truly believe that the power that it can bring to unleashing this potential of 2.9 billion people is very high. Someone asked yesterday about where that number can go in the next few years. I think as you start to see HAPS unleash the unconnected, the less connected, I think you're going to see that number dramatically decrease and a rate quicker than most of us would think. And I'll throw on the inflation numbers of more people coming online and to come online with respect to that. But that's the prize, and that's what we have to fix. And I believe HAPS is a major component of helping fix that. So again, when we think about each layer of NTN, we start at the far right-hand side here, geostationary, traditionally where my business comes out of at Intelsat. But it's this complete stack. No one of these technologies anywhere in here, and I will also go and talk about the terrestrial components, none of these are going to fix the problem that was on that last slide. All of these are going to fix the problem that was on that last slide. And there again, it's the combination of coming together as industry, as ecostructures, as partners to do that, I think is what makes this so exciting. Right now, when we look specifically in the stratospheric platforms, there are various different platforms. Again, I talked about some of the power components. Some are fixed wing, some are balloons, some are large airships. From the standpoint of the HAPS Alliance, we love them all. They're all going to be needed in applications. We envision a world where not only will you see across there a combination of geostationary and MEO and LEO, and then your HAPS, and even sitting below HAPS, tethered assets possibly for temporary relief systems and things along that nature. They're all going to come together. The one challenge that I will put out there that we as in the industry need to think about, though, is the orchestration that sits behind this. It's one thing to look at the technology that goes into every one of these things, but it's another thing to really think about an end user on their Apple phone and thinking about a laser, shooting a signal from possibly a HAPS to a low Earth orbiting satellite moving at 17,000 miles an hour. And then it going over to, another asset, then it coming down to the ground, then it going into the PSTN network. This happening within milliseconds. That's going to be one of the things from a software standpoint, from an AI standpoint, that I think we're going to have to think a little harder on right now and put a little more effort with respect to that. And again, when you look at these platforms, the thing we love about them, based upon traditional assets that have been used for NTN type connectivity, these assets can go up very quickly. They're very cost-effective platforms. We're hearing numbers of anywhere from $2, $3, $4 million for an asset that can fundamentally cover 450 towers. That's pretty amazing when you really think about how far that technology has come in the last few years. But it's not just about connectivity. We look at connectivity as that biggest market that's out there, and truly it is about a $150 billion marketplace, we think, on a global basis. But then if you look at Earth observation, you look at security and defense, you look at government mapping, monitoring, surveillance, all these things that are fundamentally ones and zeros. They're digits that go across these networks. The interesting thing about HAPS that we see is you can actually bring them down. You can take a new payload out. You can put a payload in the nose of it. You can send it back up there, and it can be doing a different mission within hours. That's something that a lot of other technology isn't capable of doing. So another plus, or something that I put on the plus side of the ledger with respect to why we really think so highly of this technology. The other thing I look at, and this is kind of wearing an investment hat, but it's also wearing a technology hat also. Where are the macro trends going? Are we on the right side of macro trends? And again, I think when you look at HAPS technology, when you look at what's needed for power from solar standpoints, from battery life, from hydrogen power, I think all the things that we see adjacent to what we have in the marketplace is exciting. We're actually here leveraging off of Apple's technology, and Apple's technology from the standpoint of battery power consumption. Or you're looking at the Elon Musk of the world with the Tesla cars and what his battery technology is doing, composite products, things along that nature. So again, all these macroeconomic factors are also moving in our direction. We're kind of along in the wake of that and picking up the benefits of it. So I can't leave without, a little sales pitch here. So we would love for you all to become members. I know quite a few in the audience are members of the HAPS Alliance. Go onto our website here, which is down there, QR code on here also. But we are so hungry for more participation from the marketplace and from our good partners out there. So I thank you for that and the exciting environment and world that we have out in front of us. Thank you.
So, Greg, thank you so much for that. And it's great to hear about the exciting plans that you guys have at the HAPS Alliance, and of course of all your members as well. So, maybe just a couple of questions, sure, if I may. So, I mean, there's various different kind of, I suppose, ways where HAPS would work in the platform. So you have kind of your balloons, airships, fixed line, things like that. Would you say there's one that maybe has more potential and or potentially is better than the others, and any reasons for that kind of thing?
Yeah, be a little careful with that, since I wear a hat of an agnostic organization. Again, I think that last slide probably talked more about my feeling with respect to that, is that all those areas that I consider to be limited challenges right now seem to be progressing. If there were a couple that I would hone in on, I think power is important. Some of the things that we're seeing from the advancements of battery technology, but I'm also very excited about hydrogen technology and, you know, how we can utilize hydrogen technology and really capture the power that that can lay down from MIMO beam standpoint, things along that nature. So power is probably at the top of my list.
Perfect, thank you. And I mean, in terms of kind of making some of these solutions, I suppose that the commercial availability, maybe you could talk a little bit more about kind of I suppose the path towards that, the pressing issues that still need to be covered, and maybe the timeline ahead as well, I suppose.
Sure. I think for the most part, the technology, you know, we've seen record, Airbus has done another record, and I think the slide that they put up yesterday talking about, you know, how many times that it's actually could fly around the world from its miles that it's put on itself. I'm really happy with the platform side of the house. Again, I think that orchestration that I just talked about, how is this all going to come together behind the scene? I think we have to think about that a little more. And there's also some regulatory con-ops that are in there, and that's more of an education project, policy standpoint with a lot of regulators to help them understand, you know, the benefits of this technology. You know, they shouldn't be scared of it, but they need to be educated. So I think that regulatory aspect too of policymakers is important.
Fantastic. And final question, if I may. So, I mean, there's obviously been, you know, a lot of news recently and big announcements talking about link-ups between mobile and satellite companies and provision of kind of direct-to-device connectivity and things like that. So you've got kind of Apple, you've got kind of Starlink with T-Mobile and things like that. How do you see HAPS kind of fitting in with all that?
Again, complementary. When you really, again, think about that complete stack of NTN and the technologies, each one of them has a specific sweet spot. You know, when I look at what Apple's doing right now with Global Star and leveraging their spectrum, you know, that's, you know, incredibly important for, you know, the person that's out in the middle of nowhere, does not have a signal, maybe is in a car accident, maybe needs to send a short text message or something like that. You know, excellent platform for doing some of those things. As the technology betters itself out, you know, they move up into some of the other layers. You know, HAPS sits also, you know, somewhat above that, based upon the fact of, you know, direct to device, but also on 5G and quite frankly 6G that we see coming. And then you just move up through NTN and again, back to that orchestration of it's all got to work together.
Sounds good. Greg, look, thank you so much. Really appreciate that, and I'm sure everyone will agree, a fantastic way to start today's proceedings. So, Greg, thank you very much once again.
Thank you very much. Appreciate it. Thanks.
So we're now moving straight on, and it's my honor now to welcome up to the stage the second of our keynote speakers today. I'd like to welcome Abdullah Al-Kanal, Chief Strategy Officer from STC, who's going to be talking to us about ubiquitous and integrated broadband for all. Al-Kanal.
This is what takes the green button to move your slides forward. Good. Thank you very much. Good morning, ladies and gentlemen. And for those attending with us in Riyadh, welcome to Riyadh. Hopefully you have enjoyed the nice weather these days and the gathering last night we had hosted by the CST. And for those who are joining us online, looking forward to see you in Riyadh next time, inshallah. Would like also to extend my sincere appreciation to the organizers of this, one of its first time event, the ITU and the CST. It's also a great pleasure to be among you, the leaders who are working hard to connect the world from the sky. I do believe that such events and forums, organized especially by a regulator, putting us all as an industry together to make sure that we communicate and collaborate to solve a problem that really needs to be solved for a sustainable, thriving economy and digital societies. This is also coming at a very great time for our country. The CITC, which used to be the regulator of the communication and information technology, just last week being appointed also to take the mandate of regulating the space. This demonstrates how we believe in Saudi Arabia on the potential of this industry and the further collaboration with the ICT at large. Would like first to shed some light on our development strategy as a nation, which is the Vision 2030. The vision basically have been developed to deliver on three main pillars: an ambitious nation, a thriving economy, and a vibrant society. If we think of these, they can only be achieved through a digitally enabled economy that's empowered by the broadband and the connectivity. And that's clearly seen across the three levels of objectives as detailed on the vision. Several studies by the World Bank, by the ITU, and others have confirmed that around 10% growth in broadband penetration leads to roughly 1% in GDP. This clearly demonstrates the value that we as an industry on the terrestrial and non-terrestrial can add to an economy. No doubt that digital transformation is becoming a necessity to the different aspects of the economic developments across the different industries. It's a key driving force in the digital transformation, unlocking the full potential of the Industry 4.0, as well as shaping the future ways of work and trade and commerce. We've also seen how digitally enabled societies, been through the challenges of the lockdown by the pandemic, those who have been connected were able to continue their different aspects of life, let it be working remotely, trading, getting health services, education services, as well as the entertainment. So bridging the digital gap is becoming even more priority for our industry and helping the rest of the world to get connected. Well, we have heard, I think, yesterday and today from Greg, the remaining gap that still need to be bridged worldwide, where 1/3 of the population is still not connected, and that's hindering the potential of the economic development as well as the basic needs of life, where it have clearly been demonstrated, as I said, on the COVID. This is basically due to the limitation of the traditional technologies when it comes to connecting the world through terrestrial. That's simply because the economics does not work. The cost of delivering services to remote areas is not viable when it comes to investors investing in these areas. And there where it comes, the alternative solutions which are evolving like the non-terrestrial networks to bridge that gap. Also, this is hindering some developments in other industries and serving potential growth in economics. The IoT services in remote areas is not yet enabled. The airlines industry, where people need connectivity on the airplane, is also another potential that can be unleashed. Within this context, we also see how the satellite industry is developing, and it is transforming. The use cases for this satellite industry is shifting, where broadband is becoming a key outcome of what satellites can provide to the world. This is supported by the LEO's capabilities and the development on the technology, where higher speeds can be provided, lower latency. And this is, I think, what we have been seeing in yesterday's discussion, as well as what we have heard from Greg this morning. The innovation in the industry, let it be on how satellites been launched, how business models are being developed. We have heard repetitively yesterday and today the looking forward for the collaboration between the different stack of the layers, and that's something gives us the ambition and aspiration really to look forward for a potential on this ecosystem. The results are clearly transformational. We have seen this demonstrated by the players that are getting into the space. We are seeing the more interest from the private sector in the space domain, where it was a domain that was mainly dominated by the government initiatives, So this puts us at the right time where a great momentum is being built to flourish this industry. As a result, we are seeing that networks that support multiple industries on the wide variety of use cases. To name some of them, the commercial aviation, travelers today looking forward to be connected even on the airplane. And that can only be solved through the satellite and the non-terrestrial networks. A lot of civil and military users on the remote areas are still looking forward to have that solution to complement the terrestrial networks, and that's another use case that we see a potential for us together to grow. So the broadband connectivity for shaping the transportation and logistics on the land and on the sea, that's another domain that we see forward growing this industry. We in the terrestrial network and as a telecom operator, we look for the sky network to be clearly a complement to the terrestrial networks and address the key dimensions that today need to be bridged, whether it is the continuity, the reach, and the scalability. When we talk about continuity, the hybrid mode of using the satellite as well as the terrestrial network working seamlessly together is something that our industry needs today. When it comes to the reach, the digital bridge, the divide that have been said on the previous slides is clearly a chance to bridge that divide. When it comes to scalability, the non-terrestrial network, we also see it as a complement when it comes to seasonal needs, when it comes to events that are happening at a period of time in a specific location. The non-terrestrial network can also help complementing the terrestrial network. Yet to look at this, to unlock this potential, there are challenges that need to be looked at and addressed. And I'm very optimistic that with the discussion that we have here yesterday and today, and the agreement that the whole ecosystem will be working together, these challenges will be unlocked. To start with is the human capital and technical capabilities. Yesterday, Greg from eSpace was on the stage, and he was asking for people to join and trying to recruit. Clearly, the space industry still need to have capabilities to be developed, and with the potential and the massive growth that we see, governments as well as private sector need to work together to make sure that these developments are developed. The funding, making sure that there is the proper return on investment is a necessity, and that can only be done by making sure that we do have the right standardization, we have the right policies and regulations, we have the government intervention when it comes to making proper public-private partnership, and making sure that the demand is rightly bridged with the supply in this industry. The environmental sustainability is also a critical thing to look for. We want to make sure that while we are growing this industry, we're also having a proper control on the carbon emission through the rocket launching, and also making sure that the space debris are also looked at. Clearly, the challenges can be also solved, and again, with the collaboration of everybody in the ecosystem, they are manageable. First of all, the ecosystem approach, fostering the partnership between the non-terrestrial network and the ICT industry at large, the investors, the scientists, the government agencies, and we clearly see this demonstrated in this forum happening these 3 days, where we have been talking to people from different domains, whether from the research, the government, and the terrestrial and non-terrestrial industry in the same room, and that's a great start of it. Second, it's critical to ensure that the necessary policies and regulations are aligned towards driving standardization, with a focus on an investment-friendly environment, which will bring the funds and the investors to make sure that the proper investment on this infrastructure is happening. Third, the capital funding, making sure the proper sourcing of the funding to this industry is happening. And that can be done through multiple ways. Governments may nudge this industry by putting some subsidies where a gap needs to be bridged on the economical viability, public-private partnership, as mentioned, and encouraging foreign investment in countries where investment needs to be happen. Last, on the business model, it's clearly a co-opetition model that needs to be adopted, where a clear win-win between the different players in the industry need to be crafted well. And that's where several of the colleagues that have talked yesterday and Greg earlier talked today, that everybody is seeing this from the different verticals of the industry. On STC, as the largest telco operator in the region and the national champion when it comes to digitization and becoming the enabler of the vision, clearly our strategy, which is there, and we are here today, whether in our traditional business as well as on the potentials beyond our core business, to feed into the realization of the national vision, which is basically having the digital economy as one pillar of it, to contribute to strengthening and expanding the digital economy and in the kingdom and beyond. And we're ready to cooperate with the world on this one. Our technological experience and capacity, as well as our readiness to partnership and geographical expansion, supports the pillars of the digital economy infrastructure, including the connectivity, the platforms, and the services. As the leading network provider, we have always been significantly investing on the different domains when it comes to enabling the economy and enabling the digital infrastructure. Together with our regulator and policymaker and with the rest of the operators in the country, we have made a very big jumps on our national broadband connectivity. When this vision realization started, I recall 2017-18, we were standing not even in the top 100 countries when it comes to the mobile speed. Today we are on the top 5 or 10 on the speed. That clearly demonstrates how Saudi Arabia is looking forward to be among the highest connected nations. Thanks to the regulator and the government for the support. Thanks for the great team leading the spectrum and the country, led by Dr. Muhammad and his great team, where they have managed to release north of 1 megahertz spectrum in 2 years. And that made this jump to happen. On the fixed, talking about fiber, 2018, we were standing at 23% household penetration. Today, we're standing at north of 60. The operators in the country have deployed north of 2 million households, which is more than double what have been invested on the last 15 years. Again, this have happened because of the public-private partnership, where the government seen the gap, and they bridged that gap through a subsidy and making sure that we do have the right digital infrastructure to enable the rest of the vision objectives. The kingdom at large, and STC in particular, determined to continue driving the non-terrestrial agenda through a collaborative mindset, which is not only strengthening the current position on the broadband offerings, but also unleashing a new wave of ambitions across different industries. We aim to accelerate the use cases to become the partner of choice for the mega and giga projects happening in the country and beyond. We're also looking forward to extend our investment on the infrastructure and drive the efforts on the regional data hub establishment and expand beyond terrestrial. This is complementing what we have announced recently to become the MENA digital hub by also further investment on the digital infrastructure through the data centers, subsea cables, which we also see another complement for the non-terrestrial traffic. Once again, would like to highlight the importance of cooperation and ecosystem approach. And fortunately, we are seeing this happening today and looking forward to have more of these events. Saudi Arabia at large is open for business, open for opportunities, and open for collaboration in the region and beyond. As the leading economy in the region, we hold strong ambitions to grow beyond the core and maintain a solid track record of successful partnership. Join us to continue the efforts to provide connectivity for all and beyond, reaching a sustainable digital society and digital economy, unleashing the potential in different verticals of life and industry. Thank you very much, and looking forward to have a fruitful discussion today and the rest of the day tomorrow.
Abdullah, thank you so much. And that was a fascinating presentation and great to hear about the huge progress that is already made here in the Kingdom and, of course, the plans for the future and increased collaboration between yourselves and non-terrestrial network and satellite providers. So thank you so much for that. Again, a couple of questions, just if I may. So, I mean, first of all, maybe could you talk a little bit more about how you see the interaction between global NTN players and kind of local telcos, both here in Saudi Arabia and elsewhere?
Sure. As I said, I think the collaboration is happening worldwide, but in particular in Saudi Arabia, we have been very active at the government level and at the telco operators level. We have been demonstrating several use cases and pilots, let it be on the LEO, where we have worked with the CITC, Aramco, as well as OneWeb to make use of the LEO as a backhaul connectivity for our 5G network in remote areas. The HAPS pilot that the governor have talked about yesterday, that was also a point where the licensed operators have worked with the providers of the HAPS technology. That's because we strongly believe that complement is needed. Saudi Arabia is a wide geographical country where we have a lot of remote areas, a lot of projects on the oil and gas industry and several industries that need to be connected. And we also always look at it from a collaborative mindset. And as I said, we are welcoming this always.
Sorry, my mic just came off. Yeah, fantastic. Thank you. And you talked a little bit in your presentation about the challenges that you feel need to be addressed in order to unleash the kind of the potential of non-terrestrial networks. I wondered if you could maybe talk a little bit more about what you see as kind of the key enablers that maybe need to be in place in order to drive sustainable non-terrestrial network services here in the Kingdom.
Well, I think the alignment and collaboration among the ecosystem. I think this has been repeated several times yesterday, and we heard it yesterday. What makes me optimistic is what I see here in the country, the leadership of the country, the decision that have been made last week to have space together with the regulator of the ICT. That gives us the optimism to really see this is happening. An event like this organized in Saudi Arabia, having the people on the industry, whether from the terrestrial, non-terrestrial, people on the research, and from different government entities, I think puts this place of the world on the leading position towards this collaboration and making sure that we unleash the full potential of the non-terrestrial.
Perfect, thank you. And maybe one final thing, maybe I can just give you an opportunity to maybe make a bit of a pitch. So we have a lot of global players here in the room and watching online with us. So maybe a chance for you to let them know why should they be considering STC as a partner for NTNs.
Sure, as I said, our strategy is there, and we're here today to explore every opportunity beyond the core. And this year, we have launched several new companies that are on the IoT and the cloud, on the cybersecurity, on the data center subsea cables. We have also started the collaboration, as I said, with the non-terrestrial. We see a huge potential coming from our Vision 2030 as a nation, where we have a clear objective to diversify our economy from the oil. And we also believe that can only happen through a proper partnership. So it's a welcoming country, it's a welcoming environment, and we see the growth here that really makes us opening the hand and welcoming partnership. We have already done it on the several domains, and we are ready to do it in the non-terrestrial.
Fantastic, thank you so much. And I think we've all seen ourselves the welcoming nature of yourself and everyone here in Saudi Arabia through this event. So I really do appreciate that. And thank you so much again, once again, for those thoughts.
Thank you, and welcome again to Saudi Arabia.
Thank you.
Thank you.
So next, we are moving straight on to the next item in our agenda. So for those of you who were with us yesterday, you will have seen that we announced the top 3 winners in the competition that has been run with IEEE, the IEEE competition on non-terrestrial network for beyond 5G and 6G. So we saw the three top winners yesterday. And a reminder as well, we have the poster displays outside in the mezzanine area for anyone who wants to find out more about all of the finalists in that competition. But we're delighted now to actually have representatives from those top 3 projects who are going to be telling us a little bit more about their project and about the work that they've been doing on that. So to introduce those, I'd now like to welcome up to the stage Dr. Walid Al-Asamari, Director of Research at the Research and Innovation Centre here at the CST. So Walid, if we can ask you to join us. And I'll pass over to Walid to introduce our project representatives and to lead the session. So Walid, over to you.
Sure, thank you. Thank you. Good morning, everyone. I welcome the 3 winners of the IEEE competition for Connecting the World from the Sky. Connecting the World from the Sky. Congratulations to all of you. Please come to the stage. As explained yesterday, there was 28 submissions, and through a comprehensive selection process, a global committee from different universities selected the winners through careful reviewing process. As we have the audience today from different backgrounds, from telco, space, IT, and also from academia, our slogan for this session comes from the quote, "Let us make everything as simple as possible, but not simpler." So our speakers will try their best to convey the messages of every presentation. The session format will be as follows. Each presenter will present 10 minutes, more or less. They will present their work, emphasizing on the problem statement, the problem they analyzed, along with the proposed solution, and the validation process of their proposed solution. During the presentation, you are welcome to submit your questions by scanning the barcode. I think it's over here. By the end of the session, I will direct the questions to the speakers. Let us start by the 3rd place winner, Dr. Giovanni from UPF in Barcelona, who will give unique ideas to integrate connection from terrestrial and non-terrestrial network. I believe the novelty of the work will speak for itself. Let us welcome Dr. Giovanni.
Hello, hi, good morning. Salam alaikum. Thanks very much, Dr. Walid, for the kind introduction. Thanks to the organizers for the privilege of being here and getting your attention even just for 10 minutes. So today I will try to complement some of the things that have been discussed so far, talking about integrating terrestrial and non-terrestrial networks. Before starting, please, let me say thanks to my student Mohammed, who is the first author of this work and who could not attend in person. And also he probably doesn't know that we just received another Best Paper Award for this work at Globecom, which is the largest conference in the world in telecommunications with around 3,000 submissions every year. So maybe if he's watching video streaming, he'll be very happy to hear this. Briefly about myself, I'm based in Barcelona at UPF. It's a young university. It was ranked among the top 10 in the world, young universities. And we do research on 6G and Wi-Fi 8, so if you know of any talent, researchers who would like to join us, we very much welcome collaborations. And also, if you think we can do something with you or for you, please do not hesitate to get in touch. Right, so before starting, I would like to put things a little bit into picture to make sure we're all on the same page for what concerns the terms, the names we give to things, because at least in academia, there's been a little bit of a confusion as to what non-terrestrial networks are. So what I put on this slide is kind of like a taxonomy, at least according to myself, and I divided things into non-terrestrial networks and non-terrestrial terminals. So what do I mean here? So for me, non-terrestrial networks on the left are cells, means of connectivity. So you can put a cell, a base station, to provide connectivity on Earth or in the air. You can put this cell up in the sky, for instance, right? So of course, I think we're all experts here in this domain. So we have geostationary orbit satellites, non-geostationary orbit satellites like LEO. We have HAPS. We could also have UAVs or drones as base stations, and they create a multi-layer architecture and infrastructure, as it has already been said before. Then what we have on the right instead is non-terrestrial terminals. So regard these as users, okay? So these are beneficiaries of connectivity, not just suppliers of connectivity. So an example, a clear example is UAVs or drones, okay? So why do I think that UAVs could be beneficiaries of connectivity? Well, I think there's a huge trend into automating lots of processes by using UAVs. For example, delivery, monitoring, even air taxis in the very near future. I mean, you'll be surprised, this is not sci-fi. There's many cities around the world who are working on advanced air mobility, right? So we do want this to be flying autonomously in the future for the ecosystem to really scale up. And as you can imagine, if these drones fly autonomously, they require extremely reliable network connectivity, so that's where the network comes into picture. And particularly there's two types of traffic that UAVs generate that I want to point out. They had the data traffic, which is similar to our smartphones, except that it's mostly uplink. Perhaps if they want to do video streaming, then it's mostly uplink dominated. But then importantly, there's a command and control traffic. So for these to navigate autonomously, they need a very reliable, although perhaps low rate, but with a reliable connectivity and a latency requirement, okay? So terrestrial networks could be in a position for supporting this, but also non-terrestrial network, as I will show you later, right? So of course, then we also have aircrafts and eVTOLs, which stands for electrical vertical takeoff and landing vehicles, something like helicopters, okay? That could be also beneficiaries of connectivity. So let me start by giving an overview of the architecture with a simple picture that illustrates different pieces of this puzzle that I have in mind. So what I have in the middle is what I call the TN, the terrestrial network segment. So the good old terrestrial network we all used to. So we have the typical base stations or towers. They're typically down tilted, okay, because they have to cover the ground. That's what they're designed for. But in the future, we could also have up tilted cells. I'll talk a little bit more about this later. It's still a research concept, but if you want to cover the sky in terms of aerial users, then this is also a possibility to have up-tilted cells. Then, of course, we have non-terrestrial network platforms. We have satellites, we have HAPS, we probably have inter-satellite or inter-HAPS links in certain applications. This could be RF, but they could also be free space optics. On the left, we have the service link, so we have the terminals. And as you can see, we have so many possibilities there. It really depends on the use case and the application. We could have handheld devices, right? We could have airplanes, we could have drones. We could also have then drones acting as relays to provide connectivity to users on the ground who don't have that, or to other drones if they're flying in a swarm and there's a master and a slave drone, right? So the possibilities really are endless. And then on the right, we have to close that loop, of course. So we need to go back down to Earth. And so we need to connect to the core network, and for that we have the so-called feeder links, okay? So you connect typically to an NTN gateway somewhere on the ground, and then you connect to the core network. So here I put some more details on how things change depending on the use case, depending on the application, depending on the real estate you have on the end device, depending on how big the antenna you can fit, depending on the gain this antenna is, depending on whether you're working a millimeter wave or sub-6 gigahertz. So just in a nutshell, this really depends on the use case. So let me give an overview of some of the use cases that I have in mind. So of course, the key use case for non-terrestrial networks is to provide connectivity to those who do not have connectivity. And I think this has been discussed extensively by distinguished speakers so far. Now, I want to list some other possible use cases, which I think could be interesting if you want to increase the return on investment. Because, for example, think about LEO satellites. They will be orbiting. So, of course, they will cover the jungles, the oceans, the deserts, the underserved areas, but they will also pass over Riyadh and they will pass over Barcelona. So perhaps they can also augment connectivity in urban areas. So some possible applications are critical communications. So imagine you have a terrestrial network, but it's not working because there was a disaster, there was a problem. We all know what's happening in Ukraine, for example, right? So in that case, you can provide a resilient alternative, and you can provide direct access from space or even relayed access through a UAV or a drone. That's one example. Then we have massive IoT and immersive comms. So we're all familiar with the concept of the metaverse, I think, by now, right? So what about, for instance, collecting a lot of real-time sensory data from land, from sea, and then multicasting these to many users at the same time? Imagine users wearing goggles, right? So this is probably one use case that could work well for non-terrestrial networks. And then we have the third use case, which is probably the one I like the most, which is urban air mobility. So in the EU, the majority of people are going to live in cities by 2030. So drones are being considered, of course, not only in the EU, to deliver goods and people one day. So we're talking air taxis, we're talking flying ambulances or things like that, especially for first mile, last mile transportation. You want to get from the airport to the city center, okay? So you could use an aerial vehicle for that. There's many cities around the world, over 100, that are working on this concept of advanced air mobility. So at the beginning, I think for safety reasons, there will be a pilot probably, and then later on, maybe we could have a remote pilot, but I think that down the line, our aim is to have these flying autonomously, once again for scalability, right? We cannot imagine to have every drone associated to a pilot. So, of course, this puts all the burden again on the network because the reliability has to be extreme for safety and also to provide connectivity to those passengers inside the vehicles, right? So really the network becomes key once again. So let me talk a little bit more about this concept. So here I want to specify one thing. I'm in academia, right? So I've been working on UAV communications for the past 5 years at least, and I'm trying to work on supporting them with the terrestrial network. Okay, I was at Nokia Bell Labs before, so we were contributing to the 3GPP study items and work items on that. And I found out from my research that it's really difficult for terrestrial network to provide connectivity to UAVs. You'll be surprised because the terrestrial network is designed for the ground. So when the UAVs fly high, they receive a lot of interference. I will show that a bit later. But then I thought, in Riyadh, we have a lot of cars, but they all drive on roads, right? So if one day we're going to have a proliferation of UAVs, they shouldn't be flying wherever they want. There's probably going to be highways in the sky. I expect regulators to design these highways. And these will probably be network agnostic. They're not going to be designing a highway where there's connectivity. Probably the operator will have to worry about providing connectivity wherever the highway is. So this might be speculation, this might be vision, but I think it makes sense from a technological perspective, and therefore this changes a bit the goal of a terrestrial network who wants to provide connectivity to the sky to providing it to a designated region. So for us, from the research perspective, we have to rethink the ground network design, their operation, and their optimization for these aerial corridors. So here we did a simple study where we consider a multi-tenant scenario, a multi-operator scenario. So just bear with me for a second. Look at the picture. We have the standard G-Node B, or the standard 5G base station, which is deployed on the ground and it's facing down, right? So it's to cover the ground. What if we have another operator? So the first operator is MNO-T, terrestrial. I call the other operator MNO-A, aerial. Aerial means that it's targeting aerial end devices. It wants to connect UAVs, for example. So can they share, for instance, the same infrastructure, the same towers, and even the same spectrum? So this is what we ask ourselves. Would that work? What would the performance be? So in this case, they're trying to serve drones. Let's see what happens. So I'll navigate you through this plot. So here what I'm showing is the signal quality, okay, the SINR for the 5% worst users in the network. So you can regard this as the worst case, okay? So the blue is for the UAVs, when I'm trying to serve the UAVs, and the orange is for the ground users, because you always need to ensure coexistence, right? Like that's your legacy business, you don't want to jeopardize it. And then what we have on this axis is the intersite distance of the deployment. What does that mean? It means that at the beginning, I will not deploy so many dedicated cells, right? So infinity means I don't have any of these rooftop up-tilted cells, okay? And then as I move to the right, I decrease this intersite distance. It means I deploy more and more densely, okay? And the extreme case is 500 meters is when they are as dense as the terrestrial network. So look at what happens. At first, the performance goes down. Why does that happen? They're sharing the same spectrum. There's a tremendous interference between terrestrial and non-terrestrial ground users and UAVs. But then as you densify enough, because a UAV now is more likely to see a cell nearby, it can afford reducing the power a lot. This is uplink. So it will interfere less to the ground. So in a nutshell, there are many trade-offs involved there in terms of the signal processing that you use. You can use sophisticated massive MIMO, null steering, interference suppression. I'm not going to talk about all these details here, but there's really room for these new paradigms if what we have in mind is to support these drones in the future. Now I'm going to talk something slightly different, okay, just to give more of a 3D picture. Now I'm talking about complementing the terrestrial network with a non-terrestrial network, right? So this relates to some of what the previous speakers have talked about. So now I still have my good old terrestrial operator, MNOT, okay, on the ground. But now the partnership is not with the up-tilted cells operator, it's with the LEO operator, a satellite operator, MNOS. So why am I considering this? Once again, maybe to increase the return over investment, the satellite operator who owns the infrastructure is a different entity, who owns the satellite infrastructure is a different entity than who runs it, than the operator itself. So this infrastructure moves all the time. It's like in the matter of seconds or minutes, it will go over Riyadh and then set, and then there'll be a new satellite. So whenever such satellite is over an urban area, maybe it could be leased to a terrestrial operator. Therefore, this partnership, hypothetically, I'm considering, right? So in this case, they're trying to serve eVTOLs. So they're trying to serve an aerial vehicle that's much higher, let's say at 1,500 meters. So we will see that the terrestrial operator really struggles to support that because of the tremendous interference that there is. But under the right design and deployment conditions, the satellite operator could take that traffic offloaded from the ground. So when I say the right condition, it means that there's several engineering design trade-offs there, and here I just want to mention two parameters, okay? So one is the beam frequency reuse factor. So as you might know, a LEO satellite creates several beams on the ground. For example, 7. So you have different options. You have a certain band that you paid for, and you can reuse it in each beam, okay? So obviously, this is much more spectral efficient. You're reusing the same resources everywhere. But there's interference across beams. So the beam moves, and whenever a user is on the boundary between one beam and another beam, it will receive a lot of interference. So the alternative, which is more conservative, indeed, is to do frequency reuse 3. So you see each of these 3 colors is a frequency. So you split your band into 3, and then you avoid that adjacent beams or adjacent cells use the same frequency. So that means that you have solved the interference problem almost completely, but of course you have sacrificed 2/3 of your spectrum in this case. So again, there's a trade-off between coverage and capacity there, right? Another important parameter I wanted to mention is the elevation angle. What is the elevation angle? It's the angle at which a user on the ground sees a satellite. And that angle keeps changing, of course, because the satellite is orbiting in the low Earth orbit, right? So 90 degrees is the perfect scenario when it's on top of your head, right? And then 87, you'll be surprised, is already a pretty bad scenario. Right? Why it's bad? Because this increases the distance between you and the satellite, and it increases when there is interbeam interference. So what does this number depend on? It depends on how many satellites you have in your constellation. Because the denser the constellation, the more statistically likely you are to have a satellite with a good elevation angle all the time on top of your head. Right? So there's a cost-performance trade-off there. So now just showing you some performance results. So don't be scared by this image. I'll go through it with you. So the black curves show you the signal quality, the SINR of these eVTOLs, these flying UAVs, when they're connected to the terrestrial operator. So these numbers are not very good. So if you work in the telecom industry, you know that SINRs below -5 dB, they are not very good. You risk going into outage, okay? And different curves are for different densities of eVTOLs. So at the beginning, maybe there's going to be very few, but then one day they will be proliferating. So as you have more and more eVTOLs for every cell, things get worse. Why is that? Well, because the terrestrial network, even with massive MIMO 5G new radio smart capabilities, struggles to separate these in space because it sees them with a very similar angle, okay? Plus, the higher they are, the more interference they receive because they see so many interfering cells in their view, right? So that's not a good thing. On the other hand, the signal quality from the satellite, from MNOS, from the LEO operator, is much better. Right? Of course, it depends on the frequency reuse scheme that you used. If you reuse the frequency aggressively, red, you do worse. We anticipated that before. And if you instead are more conservative, then you avoid interference, of course things get better. That's the blue case. And it critically depends on this elevation angle. When the satellite is on top of your head, then the eVTOL gets a very good signal, right? But then as it sets, it goes to 87, look, there's a huge penalty. So really this tells us that we might need a dense constellation. Of course, there are ways to improve that. I'm not going to go into the details. Well, we have some research agenda to address this. But this is already quite promising because what this means in a nutshell is that you could offload this traffic opportunistically and dynamically to your satellite operator. And you can do this through measurement reports. It can be a data-driven approach, something similar to mobility management in cellular networks. All right. So just to conclude, I wanted to say that I do believe in this 3D wireless revolution that we're all talking about at this fantastic conference. I see many opportunities there. So to connect the unconnected world, absolutely, this is a fantastic endeavor. This will also, from the business perspective, open new markets, but also to hyper-connect the already connected, bringing up new services. For example, area services, which was the focus of this short talk on mine, but not only that. There are challenges as well, which is a good thing for us working in research, right? Because we're sure we can keep our jobs. So one is that the architecture is extremely heterogeneous, right? So there's different services to be provided. The spectrum is very different, right? Devices have very different capabilities depending on the use case and also the ownership, right, of the architecture and the platforms. So what we need is probably a unified optimization of these deployments and also some smart algorithms to make the most of this 3D architecture that we're going to avail of, right? So my hope is to make this 3D wireless network of tomorrow, and if any of you want to join us in this journey, please do get in touch. Thanks very much.
Inspiring talk, Giovanni. Thank you. Thank you very much. Let us now present the second place winner, Rawan Al-Ghamdi from KAUST. She will show how HABS does not only provide communication capabilities, but it can be also a computational system. She will show also that by adding hot air balloons to the system design, that will make it more interesting. The floor is yours, Rawan.
Thank you, Dr. Walid, and thank you all for attending. Good day, everyone. I'm Rawan Al-Ghamdi, a graduate student at KAUST. I'm happy to be presenting the work on behalf of my team, Dr. Haysam Dahrouj, Professor Tariq Al-Nafouri, and Professor Muhammad Salim Alawini. Our work titled Toward Equitable 6G Access Service via Cloud-Enabled HAPS Systems. So the future generation of wireless communication networks in the next 20 to 30 years will feature an immersive, full immersive connectivity ecosystem that spans multiple layers. So our team at KAUST studies this full immersive ecosystem that actually connects air, ground, sea, and underwater seamlessly. So, but today, in today's work, I will only focus on the air to terrestrial segment only. In order to realize such vision of a full immersive connectivity ecosystem, we must start by addressing today's connectivity challenges, right? And these challenges, as the pandemic has highlighted, is the digital divide or the digital inequality. So, driven by a pandemic view of the cost of the digital divide, the future development plans of 6G networks is to democratize connectivity as a service. And to do that, we known that the current terrestrial networks poses several challenges in terms of poor channel conditions, network inflexibility, and the high implementation costs, which actually the most obstacle that we have today. So in this forum, we have seen that connecting the world from the skies becomes an indispensable solution to providing ubiquitous connectivity anywhere, anytime, via integrating the terrestrial networks with non-terrestrial platforms. We believe that one of the key enablers of such seamless integrations is the high-altitude platform stations, giving their strategic hovering altitude and their high payload capacities. However, although the high-altitude platform stations have proven to be effective in increasing the connectivity, in serving the underserved, we believe that it's an underutilization of the HAP's high payload capacities to just use them as a communication hub. So the work that we're doing is to propose empowering the HAPs with cloud computing capabilities. So we're exploiting the HAPs not only as a communication platform, but also as a computation platform jointly, and that's the key word here. We're jointly providing communication and computation from the cloud, which is the cloud that is in the sky in the HAPs. So the cloud being in the HAPs provides a high data sharing front haul link to both the hot air balloons and the terrestrial base stations, meaning that we're using this as a complementary solution to terrestrial network, not as a substitution. Now, these hot air balloons and terrestrial base station will then provide radio access services for both aerial users, such as delivery drones, flying taxis, and so on, and our terrestrial users. We devised several resource allocation schemes that motivates having equitable service for both those who are in the unconnected areas, having higher coverage, and those who are in hyper-digitized areas, we wish to maintain their quality of service to an adequate capacity. So we first show the gains in connecting the unconnected via this integrated aerial terrestrial networks that are supported by the cloud-enabled HAPs. So in this figure, I'm showing an area, 300 kilometers square area that is covered by one HAPs. And we feature a highly populated urban area, a sparsely populated rural areas, and suburban areas. What we show here is that the users that are supported or served by terrestrial standalone systems are mostly, those are highlighted in green, are mostly clustered in the urban areas. When we integrate hot air balloons and terrestrial base stations under this umbrella of cloud-enabled HAPs, we can see that we can serve more users, both terrestrial and aerial users that are spanning urban areas, rural areas, and suburban areas. However, we can see that there is still a room for improvement for fairness. After all, what we're trying to look for here is a fair and equitable 6G access service. So we can see that there is still remaining users that are being unserved. Hence, we develop a proportionally fair access scheme that supports more users in a fair fashion. So we're using a multi-user diversity transmission schemes, and we're dividing the resource blocks that we have into small chunks that are orthogonal so we can accommodate more users. And the way that we accommodate users is not those who have good channel only, but also to make sure that even those with poor channel models can still, or like in rural areas with high distance, can still access the internet. So what I'm trying to show here is that compared to a system where we're using like one resource block to serve a user, if we divide these resource blocks into small chunks, we can increase the fairness by 8 times. Not only that, but we can see that we have been serving the users 90% of the users in our network, which is a great achievement. Not only that, but I will also compare this with like our benchmark, which is a standalone terrestrial system. Now, even though the algorithm that we have developed to have a fair access still improves the fairness in a terrestrial standalone system, we can see that it stops at a certain level, here in pink, and it starts decreasing afterward, because even though we're trying to increase the number of resource blocks that we have, some users can simply not be served because of their poor channel conditions, and so we create this disparity in access, which we can see that indeed the integrated hot air balloons and terrestrial system in the cloud-enabled HAPS framework is actually avoiding. So we have 80% fairness among all users that are connected. This provides a numerical testimony of the prospects of the non-terrestrial networks in providing a digital equity paradigm in wireless systems. Before I conclude, I just want to show the resilience of our proposed system model and optimization algorithm in connecting the unconnected and hyper-connecting the connected by showing that even for low transmit powers, for those hot air balloons, because they're battery powered, we can see 3-folds of sum rate improvement in megabits per second, even though we're on very low transmit power for these balloons. We know that they're battery powered and they might get deflated. So this is really important to realize that even in the worst case scenarios where they're close to be deflated or out of power, they can still provide better throughput for our network. To conclude, the agenda for 6G networks is to provide equitable access for those who are connected and those who are unconnected. So we want to alter-connect those in hyper-digitized areas, but connect those who are unconnected. Our work develops a resilient and inclusive digital framework that works for demographical and geographical, different demographical and demographical landscapes, such as those that are featured in Saudi, because we know like Saudi has a large landscape that is different. We have terrains and we have coastal areas and so on. So we believe that such a system model can improve the fairness of 6G access service for the connected and the unconnected by providing somehow a financially feasible solution. We also believe that this is one step forward towards realizing a large-scale connectivity, such as the one that I mentioned in my first slides, that spans multiple layers, not only air and ground. We're looking forward to having something in the ocean, in underwater and underground. Thank you.
Thank you, Rawan. We'll explain the ideas. Now we leave the best for the last. We welcome Dr. Wael Jafar from Carleton University to explain how their work in making HABS a multi-mode communication system gave the advantage for his team to win the first place. The floor is yours, Dr. Wael.
Thank you, Dr. Walid. I apologize from the beginning for my voice. Thank you for the organizers. Thank you, everyone, for being here today to hear our work about multi-mode HABS for future wireless networks. I would like to acknowledge at first the first author of this work, future Dr. Safwan Al-Fattani, and also our collaborators, Professor Halim Alikum-Roglo and Professor Abbas Yungaklur from Carleton University and University of Ottawa. So, as you know, for the future wireless network development, we are really looking for ubiquitous connectivity, and also we expect a massive number of connections. So by 2030, we expect nearly 30 billion devices connected, including user, robotics, Internet of Things devices, etc. So the conventional solution usually to connect these devices is to rely on network densification, or actually building base stations, terrestrial base stations in any place we need it. But the problem with this technology that if we have concentration or density of traffic or devices in some areas, this will not be efficient. So making more base stations, terrestrial ones, will lead to an increase of the costs for deployment. And also, this is on the long run not an efficient solution. So as you all know, we are here to talk about non-terrestrial networks, and you are all familiar with the different paradigms that have been developing over the last 10 years, starting with unmanned aerial vehicles, or known as drones. And then we have recently the deployment of LEO satellites, such as Starlink. And very recently, we start talking about HAPS, or high-altitude platform stations, such as what Airbus is doing with the Altair project, and also HAPS Mobile, that is one of the leading companies to deploy HAPS technology. So actually, why it is interesting? Because from the air, we have this strong line-of-sight connectivity link. We have also wide coverage that is provided by these technologies, and also very flexible deployment. But since here we are interested on HAPS, if you look into comparison between HAPS and the other non-terrestrial technology, we see that we have some advantages in the communication perspective. This would include a relatively large coverage area, a very good communication link. We have also high payload on the HAPS, such as the one provided by the airships, so that we can host or accommodate a lot of equipment. Compared to the other technologies. However, the drawbacks is actually the cost, that we don't know exactly how much it will be in reality for the next 10 years. And also, for example, compared to the LEO satellites, the coverage is smaller. But in any case, there is a lot of potential for the HAPS, and that's why we are here today to discuss it. So when we started working on the HAPS, we have been identifying different operating modes of the HAPS. For sure, the first one, people will say it's about communication. That's true. So the first vision of the use of HAPS we have proposed in our group is the HAPS as a super macro base station. So HAPS as a super macro base station, it means that it has communication payload as terrestrial base stations. However, due to its features and characteristics being in the air, it will provide a very large coverage area. And also, we envisioned in this work that we also have other payloads, which includes storage and computing power. And this is very important because with the development of applications such as virtual reality, augmented reality, and autonomous vehicles, we expect to have this power of computing and storage very close to users. And the HAPS payload will allow us to do that. So a number of applications that can be involved can be supporting aerial networks and aerial users, such as the drone, also supporting intelligent transportation systems, such as autonomous vehicle. And also, interesting thing is that with all these characteristics, the HAPS can be seen as a flying data center. This is a very interesting point because until now, we have these large, big data center on Earth and terrestrial everywhere. But we know that if something happens like a disaster, earthquake, you may lose this data center easily. So the flying HAPS data center has a huge potential for the future. The second operating mode we have identified is HAPS as relay station. This is something very familiar to everyone because actually in industry, this is the first thing that have been developing, like to use the HAPS for communication, for connecting different areas, hard to reach areas and isolated areas. So mainly in this mode, we deploy active communication equipment, RF chain equipment to make connections between receiver and transmitter and receiver in different areas. Also, these links can be used for backhauling traffic from isolated small cells or small base stations. And also, it can be used to establish inter-HAPS communications. And this is in the vision that we have in the future constellation of HAPS that would be covering large areas such as a country. And then we have envisioned recently a third mode. So you all heard about this development of reconfigurable intelligent surfaces. So this new paradigm that have been developed says that actually now we can control signals in our environment. We can direct the signals in the way that we like it. And this is in a passive mode. And this is very important, meaning that actually you really need very small amount of power to do this. And it has been proved to have a large potential. So in this work, in our group, our vision was really to involve or equip HAPS with this technology RIS. And we have looked into this potential and actually we found it interesting. And why? Because HAPS may have a large bottom surface area that actually can accommodate maybe hundreds or thousands of RIS reflectors that can be used for communication. And just a little bit about history. This concept of reflecting signal is not new. Actually, it was used for satellites back in the 1960s, where actually a metallic sphere satellite was reflecting without any control the signals. So now, with this new technology, we have control over the reflection of the signals. So this operating mode is very similar to the relay mode. So we will be supporting everything that a relay or active relay components would be doing, but in a passive mode. But also, since we can control the signals, we may use it also for other applications, such as securing communication and also supporting beyond cell communication, meaning that when we have problems at the edge of cells. So now that we have found these three interesting operative modes of the HAPS, in this work we have envisioned the multi-mode HAPS, meaning that since we have this large payload that we can use on the HAPS, why not have all these modes together? And depending on the use case that we are in, we can switch on and off these modes. And this is very interesting because we can use either one mode only or two mode combined, depending on what we want to do, including, for example, to satisfy quality or service, or actually to improve the capacity in some region. So to explain it rapidly, in the HAPS, we propose a controller that will make sure that this switching on and off between the different modes is done in the most optimal way or the best way, depending on the application. So we will have a controller that will evaluate the request that is coming. For example, if the request is simply requesting a video, like for video streaming, and since we have storage or caching capability, so we can just directly send this data to the user. So we are already in the super macro base station mode. If, for example, we want to establish a communication between one user that is covered by the HAPS and another one that is not covered, so in this case, we have to establish the communication link between the user and the ground gateway of the HAPS through either the relay station mode or the RIS mode. So there are many benefits. The one that we expect more is that we may use the passive mode very often. So this is from the energy efficiency side. Also, since we have these multiple payloads, we will provide more robustness to equipment failure. So if one of the modes is failing, it's okay because we can use the other ones by the time we recover. And also we can enhance the performance if we can combine two modes together. So to prove the feasibility of this work, we have considered two different case studies. In the first one, we considered backhauling data from a small cell, isolated small cell, to the ground station of the HAPS. And actually, in the first figure on the left side, we evaluated the capacity in gigabits per second of the relay station mode and the RIS mode. And you see like the green lines, which are the RIS modes. It depends a lot on how big is your RIS that have you installed on your HAPS. And on the right side, we have evaluated the energy efficiency. So we have considered the capacity divided by the energy consumption And as we said, since the RIS mode consumes lower energy, lower power than the relay station mode, we have these very, very great performances with the green lights that are very high. But in conclusion, it all depends on many parameters, including the location of the hubs regarding the transmitter and receiver, and also the RIS size. And in another case, we wanted to compare to the SMBS mode. So in this case, we looked into task offloading mode, meaning that we will need the computing power of the hubs. And in this case, we make comparisons. So first scenario is the hubs has enough computing power to provide the service. Second scenario is that if we don't have enough power, we have to relay the signal to the cloud. So to go to the ground station and to the cloud to get enough computing power. And we have evaluated the latency or the delay for these different two modes. And actually, depending on how much data you need to process and how much CPU power you have on your hubs compared to the cloud that is somewhere else on the core network, actually, it can be interesting to have this computing power on the hubs. Again, here we have more parameters to consider, such as the location of the hubs itself, the size of the data, also the CPU power that you have in this case. So to conclude, in this work, we presented this new vision of the multi-mode hubs that we believe will be interesting for many industries, since only having communication payload will be not sufficient, especially that failures may happen. So having multi-modes will be very beneficial. In addition, it will enable a lot of different applications of the futures that we expect, such as monitoring autonomous cars on highways, augmented reality, or even precision agriculture. So thank you very much, everyone. I hope you enjoyed.
Thank you, Dr. Wael. Thank you. So the plan was to take some questions from the audience, but unfortunately we are running out of time. So if you need to ask any questions or discussion, you can chat with the speakers on the break. Thank you. Let us thank the speakers one time more. Thank you, everyone.
So thank you to Walid and thank you to all our speakers. And if I could invite you now to take your seats back in the audience. Thank you so much indeed. And as Walid says, please feel free to ask any questions to our presenters here on their projects. And of course, to any of the other finalists during the breaks. Just to remind everybody, we do have another poster session running, which is going to be at 2 o'clock today. And if you haven't seen the posters for all of the finalists in the IEEE competition, they are up in the mezzanine area, up the stairs, just outside the back of the auditorium. So please, if you haven't seen those, make sure you do go and check those out. And as I said, representatives from those finalists will be there at 2 o'clock today as part of the poster session that we have running. So next up, we move to our final keynote presentation of this first session of today. This one is going to be a pre-recorded presentation. So we're delighted to have Rajiv Suri, who is chairman of the Global Satellite Operators Association and CEO of Inmarsat, who pre-recorded a message for us. He's unfortunately unable to be here in person, but pre-recorded a message, a keynote presentation focusing on dynamic multi-layered space networks. So we're going to run that video now.
Thank you all for your time today. It is a great pleasure to be speaking to all of you at a conference hosted by a country that is stepping up to such a strong position of leadership in space. The Kingdom of Saudi Arabia not only thinks bold, but is bold. It is a country that does more than talk. It truly walks the talk. As Minister of Communications and Information Technology, Abdullah bin Amr al-Swaha reminded us so eloquently in his speech at the recent ITU Plenipot meeting in Bucharest. Saudi Arabia is a country that has moved fast to close the digital divide and to use the power of connectivity of all kinds to improve people's lives. A country that has promoted entrepreneurship and moved assertively to increase the number of women in technology. They have brought incredible energy to their work in space, and I'm sure there is much more to come in the months and years ahead. I am delighted to talk to you for the first time as chair of the Global Satellite Operators Association. We are an association of 29 satellite operators, both global and regional, who share a strong belief in the power of space to help make the Earth a better, more sustainable, and more prosperous place. GSOA represents the widest array of satellite service capabilities possible: geostationary, medium Earth orbit, low Earth orbit, and more. You name it, we probably have a member who has it or is considering it. That gives GSOA a unique perspective on the industry, on the development of today, but also of those to come. I was asked to talk to you today about dynamic, multi-layered space networks. I will do that not by getting deep into the underlying technology, but by giving some perspective on why such networks matter. I'm reasonably new to the space sector, having joined Inmarsat as Chief Executive Officer in March of 2021. My previous experience was mostly in terrestrial mobile communications, including almost a decade as CEO of Nokia. And I have to say that the space industry can be, well, an odd place at times. There are heated debates about technology and about different orbits. Sometimes these debates veer away from fact and become a matter of personally held conviction, a belief there is only one solution versus accepting that there are many different solutions for many different use cases. As the old cliche says, if you're a hammer, everything looks like a nail. This is so true. If you are a low Earth orbit only company, you probably think the answer to every problem is a LEO solution. If you are a geostationary operator, same thing. Terrestrial mobile, same. Terrestrial fixed, same again. Sometimes this approach makes good sense. There are some use cases where LEO is the best answer, others where terrestrial 5G is best suited. But all too often, customers are forgotten along the way. What they need now and in the decades to come gets lost in these raging battles. Customers want the right capacity, resilience, and security in the right place, at the right time, at the right price. If they can get that, do they really care about what orbit it comes from, whether it is from land, air, or space? I think the answer is a clear no. As a result, there is room for the many diverse approaches that we see among the GSOA membership. To give a concrete example, Inmarsat launched its Orchestra network in July of 2021, a multi-dimensional, multi-frequency network in a bid to bring together the best of all worlds. The answer is not a hammer. Rather, it is a complete toolkit. Within the space sector, there can be big divides. There has also been a historical gap between terrestrial mobile and satellite communications. We argue over spectrum, over customers, over regulation, and much more. When we show up at common meetings like those hosted by the ITU, we keep our distance. But actually, it is time for us to become closer friends. If you accept the view that multi-dimensional networks are the way of the future, then it seems logical that terrestrial and non-terrestrial networks need to become closer partners. Maybe not brothers and sisters, but at least close cousins, who share many things, but also have some important differences. Top of the shared list is network interoperability. Top of the differences list is adequate spectrum segregation that allows each cousin to operate at their fullest capacity. Anyone who doubts that terrestrial and non-terrestrial are coming closer should just consider the recent announcement from Apple about their satellite-enabled iPhone 14. There are other mobile device companies who are taking similar steps, so the train is clearly leaving the station quickly. Which brings me to 3GPP, the group in charge of defining standards for mobile communications. And what a change there has been. In the 4G era, when it came to terrestrial and non-terrestrial working together, it was about interworking between networks. Acceptable, but far from ideal. In the 5G era, we moved to network integration with 3GPP officially launching satellite communications as part of its standard architecture requirements. Much better. With satellite specs now included from release 17, 5G NR and NB-IoT to support non-terrestrial networks, there is the promise of strong reach of 5G technology into remote areas, better network resilience and support for new IoT and mobility use cases. These are being enhanced now in release 18. When we get to 6G, I expect full unification, where the user should notice no difference between networks at all. That will be, well, fantastic for customers, operators, and technology providers. More scale, better use of well-known cellular technology innovations like virtualization or orchestration, ability to not just tap growth markets, but to create entirely new markets. There's already a satellite vision for 6G with release 19, where we are targeting advanced technologies like regenerative payloads that can deliver better performance, reduced latency, support of mesh connection, simplified implementation, and even lower costs. Making this happen will require hard work. It will require openness and dialogue and a spirit of compromise, and setting aside some of the assumed barriers of the past. But it will be worth it, not just to the industry, but to the 2.7 billion people who remain unconnected, to the many sectors across the globe that can become more productive, more profitable, and more sustainable by leveraging the world of the Internet of Things. If we get this right, it can have a massive impact on our world. As I said at the start, the members of the Global Satellite Operators Association are firm in their belief that space is essential for making the Earth a better, more sustainable, and more prosperous place. Space can help massively reduce the CO2 output from aviation by making flying far more efficient, by delivering on the International Maritime Organization's target to cut CO2 emissions by 50% by 2050, and by improving energy use across the entire world by connecting the Internet of Things everywhere. These are huge benefits. And as all of you know, there is so much more. More supporting smart cities, economic growth, digital and social inclusion, scientific discovery, disaster relief, safety at sea and in the air, projects like the Line here in the Kingdom of Saudi Arabia. The list is long and meaningful. Unfortunately, the future is not without risk. 10 years ago, the number of satellites in orbit numbered in the hundreds. Today, around 5,000. 10 years from now, hundreds of thousands. Some have even said 1 million. As we head down this path, we need to do it right. That means we need to balance the rush to space with a clear understanding of some critical issues like space debris, light pollution, the potential environmental impact on our upper atmosphere, the land grab of orbits leading to de facto monopoly positions of companies and countries. All these issues and more need to be understood and addressed before we inadvertently limit the potential of space for future generations. GSOA is committed to playing its part and has now established a working group to better understand sustainability issues and work towards a more robust, common industry position. We are committed to working with governments around the world to develop appropriate policies for continued safe, reliable, and equitable access to all orbits for all systems for all nations. At GSOA, we believe in minimizing the creation of more debris in space, maximizing orbital resources through appropriate space traffic management, including for launches, and enabling the development of responsible solutions to existing and future orbital debris. You can find more details about each of these areas on the GSOA website. But let me leave you with no doubt. Our members take the issue extremely seriously and collectively call for action that drives responsible behavior at international, regional, and national levels to secure space for generations to come. If we get the sustainability part right, we have a bright future. That future is together, with seamless networks that ensure a digital future is available to everyone and that provides amazing benefits to the Earth and all its citizens. Together, we can connect the world from the skies with no limits. With that, thanks to all of you for joining, thanks to CITC for organizing this event, and I wish you a successful second day. Thank you.
So thank you very much to Rajiv for recording those words on behalf of JSOA, of course. And whilst Rajiv's not here in person, we're delighted we do have representatives from JSOA here. So Arti Holamaini, many of you would have seen moderating the sessions yesterday. And we also have Natalia Vicente, who's going to be moderating a session today. So if you do see those, then any questions you have for Rajiv, I'm sure they'd be happy to help with. So we are now moving to a break. So we're running just a little bit behind time. So maybe if we could try and limit the break to around about 15 minutes. And if we could ask everyone to try and be back in here at 1 o'clock sharp, we're going to have our next keynote presentation. We're going to be delighted to be joined in person by His Excellency Professor Isa Ali Pantami, Minister of Communications and Digital Economy of Nigeria. But for now, there's going to be another fantastic spread laid on outside with coffee and everything from our hosts here. And I invite you to go and have your coffee there, and we'll see you back here in about 15 minutes. Thank you. So if I could invite everyone back to the room and to please ask you all to take your seats now, and we're going to be starting again with our next keynote presentation very, very shortly. So, welcome back, everybody. And I hope everyone has had the chance to enjoy some coffee, enjoy some food outside. And it's great to have you all back here now for the second sessions of today's conference. And to kick things off for this next session, it's my absolute honor to welcome our next keynote speaker. It's His Excellency Professor Isa Ali Pantami, Minister of Communications and Digital Economy of Nigeria. And the Minister is going to be providing us with a keynote presentation to look at connecting the unconnected and providing a case study of Nigeria's broadband plan. So, Your Excellency, it's great to have you with us. And please, I invite you now to come and take your stage.
My good friend and brother, the CEO of Communication, Space and Technology Commission, His Excellency Tamimi, other speakers here present with us, stakeholders from the digital economy sector, my colleagues from Nigeria, good afternoon to all of you. Assalamu alaikum wa rahmatullahi wa barakatuhu. May Allah's peace, mercy, and blessings be upon you. Firstly, permit me to begin by appreciating the effort of Communication, Space and Technology Commission for inviting us to come from Nigeria and be part and parcel of this very important event. I also want to use the opportunity to commend the Kingdom of Saudi Arabia for becoming an active player in the fourth industrial revolution. A lot is being conducted in this country when it comes to the fourth industrial revolution. The effort of the kingdom is highly commendable and it deserves to be emulated. Furthermore, I have been informed that the Communication, Space and Technology Commission organizes this event in partnership with the International Telecommunication Union, ITU. This is another point that is also important, that today, digital economy sector cannot be developed in silos. There is need for more collaboration and partnership. No country or institution has the monopoly of wisdom and knowledge. It is because of this collaboration, partnership, and supporting each other is necessary in order to be successful in having an excellent digital economy either in our country or globally. In addition, the theme of the discussion is very apt because it deals with connecting the unconnected. Why do we need to discuss about connecting the unconnected? To me, to have a good life today, to be successful economically, socially, educationally, medically, and otherwise, connectivity is no more a luxury, but rather a necessity. We have learned many better and bitter lessons during COVID-19 pandemic. There are some better lessons we have learned, and there are some bitter lessons we have also learned. COVID-19 swallowed the world, particularly in the second quarter of 2020, up to the end of the year. Nobody was anticipating it. There was not any budgetary provision in our countries on how to handle. We were compelled to go into lockdown. almost everything was disrupted. The few countries globally that had an excellent connectivity, their education was functioning, economy was functioning. Why? Because of the connectivity. In the developing countries like in Africa and part of Asia, many institutions were completely locked down. Even communication was difficult. So the lesson we have learned from COVID-19 pandemic has compelled us to know that to have a better life, connectivity is no more a luxury, but rather a necessity. This necessity in security is a necessity today because the technology we deploy in our security, they need connectivity to function. At least the 8 systems being deployed in security, without connectivity, they will not function effectively. Whether the command system, computer system, communication system, control system, information system, intelligence system, reconnaissance systems, and many more. None of them will function without connectivity. It is because of this, connectivity is key to our security. Connectivity is key to our education. Connectivity is key to our economic development. It increases precision and accuracy. It saves time and energy. And it allows us to have wider coverage in whatever we do. Furthermore, if you look at the global statistics, according to the United Nations Department of Economy and Social Affairs, by the 15th of November 2022, what is today's date? 9th of November. So in the next 6 days only, by the 15th of November 2022, the world population could reach 8 billion people. So we are only 8 days away from hitting 8 billion people. And if you look at the statistics of available, the people that are connected today are about or even less than 5.3 billion people globally, within that range. And people that are unconnected are within the range of 2.7 billion people. So if you look at percentage-wise, you will discover that we have around 64% connected and approximately around 36% unconnected. So by implication, we have a little higher than 1/3 of the global population unconnected. So we have a lot to do. Only around 2/3 of the world population connected today. So if you look at it, to say at least 1/3 of the whole world population unconnected, they have no privilege to access to education as we have, access to economic activities as we have. They have no access to the facilities and resources available online with regards to health, medicals, and many more. And sometimes one may not be able to appreciate the value of the connectivity until he experiences it. Without experiencing it, one may not be able to know. So the need for redoubling our effort to ensure that this percentage is connected lies on our shoulder, those of us who have been benefiting from the connectivity and also know the value of that connectivity in whatever we do. A report by the World Bank shows that if we can increase connectivity from around that 64% up to a minimum of 75%, there is a high probability that this will increase the global gross domestic product by a minimum of $2 trillion USD. This is one of the benefits of the connectivity. Look at it. That increase in percentage with around 10% will provide additional 2 trillion USD to the global GDP. If you take a simple example, Massachusetts Institute of Technology advocated for what they call IDE, Innovation-Driven Enterprises, meaning we should try to accommodate our small and medium enterprises globally to be online and give them wider coverage, global visibility. At the time, the world was agitating and advocating for small and medium enterprises. MIT was more proactive, advocating for IDE, Innovation-Driven Enterprises. That concept, along with other initiatives, catapulted the serial entrepreneurs of MIT as a university. Their collective GDP since around 2016, the serial entrepreneurs, was approximately 2 trillion USD. By implication, if MIT were to be a country, it could be the 10th largest economy globally. Why? Because of the value of connectivity they deployed when it comes to small, medium, and medium enterprises, and also that visibility given by MIT to their entrepreneurs. And this is indeed very important. This is to show to us the benefit of our connectivity is not only restricted to socialization. There are so many benefits in security, so many benefits in economic development. According to our research conducted by Information Technology and Innovation Foundation, that in developing countries, 80% of economic benefits are attained through the deployment of ICT facilities. While in the developed countries, around 90% of their economic development, their success, discover that is attached to the deployment of ICT. And connectivity is part and parcel of that. Furthermore, if I can take Nigeria as a case study, it is indeed a success story. For example, I took over as a minister on the 21st August 2019. If you look at some of the initiatives we came up with, and the success story we have been recording is really mind-boggling. First thing we did was to transform the ministry and the whole sector from just ICT sector to a digital economy sector. And secondly, we developed the National Digital Economy Policy and Strategy for a Digital Nigeria with 8 pillars. Pillar number 1, developmental regulation. Pillar number 2, digital skills. Pillar number 3, solid infrastructure, which broadband connectivity is part of it. Pillar number 4 is a service infrastructure. Pillar number 5, digital services development and promotion. Pillar number 6, soft infrastructure. Pillar number 7, digital society and emerging technologies. Pillar number 8, indigenous content development and promotion. These are the 8 pillars in our national digital economy policy and strategy. In order to simplify the implementation of the policy, we came up with so many policies. So far, we have around 19 national policies, and 17 of them are being implemented, including our Nigerian National Broadband Plan 2020 to 2025, which we have achieved a lot when it comes to its implementation. With that effort, in the digital economy sector, in the last 3 years, when it comes to contribution to GDP, we have set up 3 unprecedented records, year in, year out. For example, in the first quarter of 2020, the ICT sector alone, without the digital services. So ICT sector is only a subset of the digital economy sector, only a subset. So we are talking about that subset. Only the ICT sector contributed around 14.72% to our GDP. Secondly, in the second quarter of 2021, we set a new record of contributing more than 17% to the GDP. Look at the increase within 1 year. In the second quarter of 2022, this year, the ICT sector contributed 18.44% to our GDP. It is indeed the fastest growing sector of our economy in Nigeria. For example, in 2020, it was the only sector that grew by double digits. It grew by 14.70%. And not only that one, it is the only sector in the whole year that grew by double digit in the country. And if you look at the second fastest growing sector of our economy to the 7th fastest growing sector, 6 of them combined together, their growth rate was not up to that of ICT sector alone. And this has been supporting our economic activities in the country. And it is the sector that played the principal role of lifting out our country out of recession that was triggered by COVID-19 pandemic. We went into recession because pandemic swallowed the whole world, including our country. We were not anticipating that. So what happened? Immediately, we set up some initiatives at the federal level of government. The developed countries predicted that Nigeria could exit recession by the end of 2021. We exited that recession a year before the time predicted by the developed world. This is to show to us that connecting the unconnected is no more a luxury, but rather a necessity. And this is not only restricted to one sector. If you look at the entire sectors, this connectivity is no more a luxury. In health, it's no more a luxury. In our education, it's no more a luxury. The same with our security. The same with our economic development. Whatever we do, we will discover that this connectivity is becoming a necessity by the day. It is because of this I want to use the opportunity and this very important event that those of us that are connected, it is our responsibility to ensure that those that are unconnected get connected. This is indeed very important because we know the benefits of our connectivity. Stakeholders at each level have a role to play. At government level is to provide the enabling environment for the connectivity, for the private sector to be successful. Let us make our regulatory instruments to be very friendly so that we will be able to attract more investment. Secondly, also government needs to provide intervention and subsidy as the need arises. For example, in Nigeria, we have what we call Universal Service Provision Fund. This is a fund that is being provided by government year in, year out in order to provide connectivity to unserved and underserved areas. We have areas that are not profitable, mostly because of a lack of population. It's a huge landmass in our country, even though we are not up to Saudi. Saudi is around 2.1 million square kilometers. I know we are not up to that in size, but it's a huge landmass. So you'll discover that there are some communities of not more than maybe 1,000 people, some 2,000 people, and there are no strong economic activities that they will be able to utilize. So private sector, usually their investment focuses more where they will be able to get more profit. So government should always try to provide intervention or subsidy so that underserved and unserved communities will be able to get connected and get more benefits from that. And thirdly, as well, introducing certain incentives like tax holiday, pioneer status, among many others. These are some of the initiatives that will attract more foreign direct investment. And at the same time, roll out obligation. For example, we have a law that allows regulatory institutions and regulatory bodies of government to give targets even to private sector. This is part of roll-out obligation because of national interest. And furthermore, we need to create more awareness. There are many people into business, investing, but many of them do not know the benefits of investing in the digital economy sector. By creating more awareness, we will attract many more investors globally to come into the digital economy sector and invest. The more they invest, the more we create many more jobs globally, the more we support economic development, because today, if you look at the ICT sector or digital economy sector or connectivity, each and every one of them is no more a standalone sector, but rather it is the key enabler of other sectors. It is the sector that is unlocking the opportunities, the potential opportunities we have in other sectors. It is because of this we need to ensure that we attract many more investors into the sector, because we need to implement an approach where each and every stakeholder has a role to play. And the more we create more awareness, the more we partner together, the more we achieve it. We must try to be very ambitious when it comes to setting our target to get the whole world connected. This is indeed very important. We need to be very proactive, be too ambitious, so that the remaining percentage that is not connected will get connected. And finally, connectivity cannot be attained without addressing two major issues. Number one, affordability, which is very important. The more we reduce the cost, the easier for global citizens to patronize. For example, in Nigeria, as of 2019, when I took over, the average price of 1 gigabyte was 1,200 naira in our local currency. But today, the average price is within the range of 350 naira. From 1,200 naira in 2019 to 350 naira. If you look at it, the reduction is almost what? The reduction is more than 2/3 of the total cost. So the more we promote that, the more it becomes more affordable, the more our citizens patronize it. Secondly, the accessibility through digital skills. We need to ensure that we provide digital training to global citizens. If without training, they will not be able to utilize the connectivity. If they are trained, at least the basic training, it will facilitate that. Only last month in Nigeria, we signed an MOU with one of the tech giants with the plan of training 5 million citizens in Nigeria. Not only general training, but actually high demand digital skills, cutting edge digital skills. So we should try to be more ambitious in making sure that our citizens are digital literate. And we must introduce many programs that will ensure that no one is left behind. For example, training for people in rural areas, training for people with disabilities, ICT for women. We should try to identify the categories that are left behind. We prioritize them, and we also ensure they understand the benefit and they join the trend in order to be successful. And finally, I want to once again use the opportunity to thank the participants, particularly those who have joined us online. I have heard that we have thousands of people joining us online, and I do hope that as stakeholders, we will continue to work together to create awareness and also to be too ambitious so that the remaining percentage of the world, which is around 1/3 of our global population, get connected. And I can see my friend from ITU, Director Wario, is here with us. I'm glad to see you in Saudi Arabia, not in Bucharest or Geneva. My friend at Tamimi, thank you very much for the invitation, and I do hope that as stakeholders, we will continue to work together. The effort of the Kingdom of Saudi Arabia is highly commendable. The initiatives in the digital economy is worth emulation. There is no doubt about this. We are very proud of what this country has been doing in the last few years. Saudi Arabia is no more a follower in the fourth industrial revolution, definitely is one of the leading countries globally. And I do hope you will try to maintain that tempo. Thank you very much.
So thank you so much to His Excellency for those truly inspirational words, and I think you'll all agree it's fantastic to hear about the journey that Nigeria has been on, and we offer them all huge congratulations for the progress that they have made in connecting the unconnected, and of course for the journey ahead. So we're moving now on straight on to our next panel discussion. So we've heard already this morning from Abdullah Al-Kanal from STC about how STC are working with non-terrestrial network providers and the new partnerships that are emerging between mobile and non-terrestrial network organizations. And now we have a panel that's going to be looking at that in a lot more detail. So to introduce the topics, introduce our speakers, who I can see have joined me on stage now, I'd like to pass over to Soren Sorensen, Director of NERA Economic Consulting. So Soren, welcome, and welcome to the speakers, and I'll pass to you, Soren.
Thank you very much, Dan. And thank you very much to the organizers for inviting me back to Riyadh. I've been coming here for a number of years with CITC, as it was known, and I'm pleased now to be invited by CST as well. Thank you for that. So let's get straight into this. So we have a debate on, where the topic is hybrid connectivity. So hybrid connectivity between terrestrial networks, MNOs, and non-terrestrial networks. And I think, almost by definition, that means, contrary to many of the sessions we've had until now, not all of them, but the majority, we've been talking about connecting the unconnected. But I think this topic of hybrid connectivity, almost by definition, that means we're talking about how to better connect the already connected by new and innovative products. And I think we have a great panel to discuss exactly this topic. In the interest of time, we're going to go straight into it. So let me introduce our first panelist, Charles Miller, CEO of Link. I know you have some very interesting products being developed, so the floor is yours to introduce what you're doing.
So thank you, Sorensen. Thank you, everybody. Thank you, Your Excellencies. Thank you, Your Highnesses. This is it's a privilege to be among a great number of people who all share the same common vision, to connect the unconnected. It is, many people here have dedicated their lives to it. The minister's comments of all the benefits are all in our hearts. This has been considered a very difficult challenge to achieve. The possibility that everybody on this planet could be connected everywhere was considered impossible by many. 5 years ago, Link, the company I co-founded, invented the technology to connect satellites directly to unmodified standard mobile phones. At the time, nobody believed us. We patented the technology, and then we set about proving it. It's 5 years later, and earlier this year, we started providing proof to the world, and now everybody in the world is jumping in and says, me too. My message to everybody here is the era of the bifurcation between mobile terrestrial and satellite is over. Link has proven the technology. We're testing today in 14 countries. We have signed commercial agreements with 23 mobile network operators. I'll be providing some of the data and some of the testing in 4 countries after lunch. And we've received the world's first commercial license from the Federal Communications Commission to start providing commercial service, which will start early next year. So I look forward to collaborating with everybody that's in this room. We all share the common vision, and my message to you is the era of the unconnected is coming to an end, and I'm glad to be here. Thank you.
Thank you very much, Charles. Let me just follow up with one quick question. Did you say when you expect to kind of go live with this commercially available? I guess it depends on the country and the region.
Well, the first and only world's operational satellite direct-to-phone system is in orbit today. It's the first satellite. We've launched 6 satellites. It's, as I said, testing in 14 countries. Where we built the next 3, we're going to be launching them soon. And with just those 4 satellites, we can start providing some connectivity in countries. It'll be periodic connectivity. We're going to start with messaging. Over time, we'll grow it to continuous real-time connectivity everywhere, directly to phones, and then we'll grow it into broadband. It's a straight step-by-step path from periodic connectivity to continuous service to broadband directly to your phone. And so this solves many economic problems. So Mr. Weiler is, I esteem him greatly. He's committed his life to this. And it's really hard. Satellite terminals are unaffordable. They're just really expensive in some countries, right? But everybody can afford a mobile phone. In Nigeria, everybody there can afford a mobile phone, if not a refurbished feature phone, right? So the era of unconnected people in the near future is coming to an end with this technical breakthrough.
It sounds extremely interesting. We'll get back to that in a second. I want to bring the other panelists in as well. So we have Jane Rigard, Head of Dedicated Wireless Networks and Edge Clouds at Nokia. And Jane, you're with us virtually.
Yes, I hope you can hear me.
So I'll give the floor to you for a couple of minutes just to introduce what you're doing at Nokia.
Yeah. Good. So as I said, I hope you all can hear me, and thank you very much for the invitation. I'm really sorry I can't be there in person for this conference. So I think the first thing is for Nokia is I probably want to contradict a little bit when you said earlier that it's not about connecting the unconnected, it's about connecting the people already connected. And I think at Nokia, we do see that the biggest part of this is really that when we complement the existing networks with more technology, we're also broadening where is the coverage that we have for it. And that's back to the comment from His Excellency Professor Pantami on saying how do we actually connect and move on from the part, and how do we ensure that we all benefit from the digitalization that is there. So at Nokia, we see that this is a complementing part, but we also see that from a technology point of view, we need to ensure that it doesn't stand alone. And that's why, from our perspective, from pure wish to expand, we need to make sure we have a standardization part. And our biggest part in here is really how do we contribute to the 3GPP? How do we make sure that it is becoming complementing and not competing technology that we have when we start blending the non-terrestrial and the terrestrial networks technologies. At the same time, we also see that standards are needed, as also mentioned by Charles Miller, that's saying the handsets is there. Well, if we need to make sure we get the scale for the handsets and therefore the cost are right, again, we are back to saying we need to have a common way of treating this across the globe and ensuring that we use the scale that exists when we come together as an industry. So for Nokia, from a technology point of view, 3GPP and standardization is key part of it, but then also ensuring that how much can we use in the non-terrestrial network setups when it comes to the ground station of what we already have used on the terrestrial network side. Of course, we can see the industry moving. Quite a bit have happened since I spoke with some of you in a panel in Mobile World Congress, is not only do we see satellite launches, as also mentioned earlier, we see AST is up also with the satellite, but also the discussions as an industry, how do we connect the device setup, the standardization, and then moving from what I would call a theoretical insight on paper to really the right proof of concepts to saying, how do we get the best technology to work when we combine terrestrial and non-terrestrial networks in really creating a network of networks across the globe. So I think that I'm really looking forward to the panel now, because I think we have a lot of things we probably agree on, and then we need to expand on this, I would call it co-creation as an industry that needs to happen in order to really achieve what we want to have, not only about connecting the unconnected, but also using the right technology for the right type of services across the globe. I think that was my quick introduction to the topic of today.
Thank you very much. Very interesting. We also have Peter Hattinger on the panel, CTO from Inmarsat. Peter, I'll give you the word now. Go on.
Thank you, and a special thanks to His Excellency Dr. Al-Hamidi for you and your staff for a brilliant conference, and for the clear energy that you've put into making this such a success. I think that energy is felt by all of us, and it's reflected in improved energy by all of us. So you can imagine your efforts are multiplied by all who are attending here. So thank you very much. One of the things you had in your opening position was a discussion of the numbers. And it started with 10% of the land mass, and then that 10% became 3% of the global surface area. And I would just say from an Inmarsat perspective, we actually look at those numbers a little bit differently. Inmarsat was founded a little bit over 40 years ago to serve safety of life at sea. So we started with the global coverage mass and said that 70% of it is water. And so only 30% is the land mass, and then, of course, 10% of that is covered. But it's that commitment to global coverage that really was the founding principle for Inmarsat. And because of that, we've ensured that since the early 90s, the world has been covered by satellite. And so as the first to actually do that, Inmarsat has been in a position to ensure that for special occasions, especially in disasters and so forth, that communications is always available to those who need it. But it's not always affordable, and I think that that's something we're always working on, and this is something that I think all of our colleagues here on the panel are trying to address. But for us, as we move up in bandwidth and try to get into higher speeds, again, we've gone to Ka band and had global coverage now for close to a decade. And having gone to a wideband communication system worldwide, now our challenge is to fill that in, to get to high density in the places where density is required. And what we see is that adding satellites can only get you so far. And whether it's GEO or LEO, it only gets you so far in terms of really solving what we consider to be the critical hotspot problems. Those hotspot problems can occur any place in the world at any time. And to do that, we think that terrestrial represents an important component of an overall vision for connectivity that we call Orchestra. This was referred to a little bit in the video that Rajiv Suri presented a little bit earlier, but this includes the ability to use all of these different forms of transport seamlessly so that at the end the user gets the experience that they expect and they don't really worry about the transport mechanism it took to get there. So our focus has been on how to integrate the terrestrial and space layers. We're doing this for both the narrowband and for the wideband components of our system. It's a cooperative effort across a number of different partners, and we're happy to say that this has been a good success so far in the proof of concepts trials that we've been doing. We're looking forward to introducing this over the coming years, so you should wait and hopefully see soon some announcements on this. But we're very excited by the prospect of doing this and very eager to work with our partners here on stage, on the line, as well as all of you who are watching and here in the room to make this vision happen. And so I'm looking forward to the remainder of this conference and hearing good ideas from the rest. Thank you.
Thank you very much. Just a quick follow-up on that. So Peter, I guess when you're talking about hybrid networks, you're talking about it in a very different way than Charles is looking at it. So the way you're doing it technically and Inmarsat is radically different from the link model, right? I wonder if you could just elaborate, sort of, not too long, but a little bit on what is actually the difference before we bring in the rest of the panel.
Right. Well, our focus has always been on the mobile users, and Inmarsat does not serve individual consumers. It's not the target. However, the things that we do serve, people in planes, people at ships, typically have no other way to connect but by satellite. And because of that, these have become important things. For example, during the COVID pandemic, you had over 1 million sailors at sea at any time, and many of those sailors would go into port and never be allowed off their ships. You had people on ships for about a year at a time who could actually never leave their vessel, and they could only connect to their families via satellite. So for us, the ability to continue to grow and serve those markets, which include not only maritime and aviation, but global governments, and the humanitarian and relief agencies that we serve generally for free, those kinds of missions that we have to keep going up in bandwidth. And to do that, we keep having to find ways of introducing more and more bandwidth in a hotspot area. And for that, we're going to be looking for terrestrial technologies and incorporating 5G, obviously, as a standard to make this seamless across all the different domains.
Yes, of course.
So just to explain how link system work, your phone thinks our satellite is a ground-based cell tower. We trick it into thinking that. And your SIM card has all the cell towers your phone is allowed to talk to. The MNO does an over-the-air update and says you can now talk to the link towers as well as all the other ground-based towers, and then prioritizes which towers to talk to. So it's all within the existing system, right? There's no change of the phone. You just do an over-the-air update to the SIM card, add the link towers, say when they can talk to them, and your phone thinks our satellites are ground-based cell towers, so it happens naturally. So it's integrated. I actually think hybrid is actually the wrong word. It eliminates the silos between satellite and cell phones. They are now one system. So.
Thanks for that clarification. I guess also one of your sales points is that by the way you describe it, you're using mobile frequencies for that. We could talk about that at length, but I want to bring in the rest of the panel as well. We have Guy Christensen, World Regulatory at Apple. Guy, if you want to tell us a bit about what you're doing at Apple.
Sure, thanks, Søren. And I'd like to thank our hosts for an impressive conference, and in particular for amazing hospitality and kindness. It was very much appreciated, and very honored to be part of this panel. I work in the regulatory department of Apple, I have a satellite background. I've worked on for Alcatel, Boeing, and used to work with Peter. And I think Apple brings a kind of unique case study in how we've implemented satellite connectivity on the iPhone 14. I don't know if everyone, well, you've heard about it, if it mentioned in the conference, but if you go out and buy an iPhone 14 now, you're buying a phone that has satellite capability in it. It's not authorized everywhere. It's launching in the United States this week. But we're not a satellite company, and we didn't choose satellite because we're in love with the concept of satellites. We did it because satellite solves a very particular problem. And we wanted to, the purpose of Apple, our main business, is providing consumer products to our customers that thrill, delight, and hopefully improve their lives. And recently we've gotten into a lot of safety-related aspects. Or in health-related aspects. The watch and the phone have a lot of health-related features, and we've introduced a couple of years ago crash detection and emergency SOS. So if you're in a crash in your car or fall, your phone or your watch will detect that, and if you don't respond, it will automatically call 911 or local emergency services. But there was a problem, and that only worked when you were in terrestrial coverage. And a lot of times there are places where you need help and you're not within Wi-Fi or cellular coverage. In addition, Apple kind of had some personal experience among our employees in the fires that took place back in 2018. You might hear every now and then, each year there are pretty bad forest fires in California, and in 2018 it was the worst one in history. About 2% of California was burned in the fires, and roughly 100 people lost their lives. And some of these people had actually called 911 on their phone and were trying to get help, but the fire spread so quickly that they destroyed the cellular base station. So there was no cellular infrastructure. So Apple took it upon itself to develop a solution, and we worked with our partner Globalstar to implement a satellite feature that works in places where Globalstar is authorized to provide service, and when people are outside of the coverage of the terrestrial network. There were a couple of problems we had to solve, and the first one is this wasn't designed to talk to a satellite, and the satellites that are up there aren't designed to talk with smartphones. But we were able to spread out the carrier that we use and use a very low bandwidth to enable us to make direct connection with the satellite and enable short text messages in emergencies. And the feature also allows you in non-emergency situations to just share your location with loved ones when you're outside of terrestrial coverage through Find My. So there was another issue we had to confront, and that's that because we could only carry text in this feature, a lot of emergency service providers don't handle text. They're designed to handle voice calls. So we've been working with emergency service providers to integrate a relay center that we've set up. The first one goes live in the United States and Canada, where emergency messages are sent over the Globalstar satellite network down to one of our relay centers, and an Apple-trained employee will call emergency services on your behalf. So I think this is an interesting example of how satellite can really meet an extremely important need, and I hope this serves an example for future collaboration. Thank you.
Thank you very much, Guy. Just a quick comment on that. So this may be unjustified, but when I think about satellite services, especially as a consumer consumer product, I always think of it as very much a niche market. When you stick it in an iPhone, it's obviously a mass market product. Does that cause any particular challenges? I guess the answer is yes, but I wonder what it is. How do you do it?
Not sure what you mean by challenges, but there were a lot of challenges we had to overcome. One is that in several countries around the world, satellite phones are illegal. And the last thing Apple wanted was for there to be some headline that iPhone customer arrested or iPhones confiscated in X country. So we had a very large outreach to administrations, and I was very relieved as we talked to administrations that instead of there being apprehension about the satellite capability of the iPhone, there was a tremendous amount of excitement. And the question we got most often was, when is this coming to our country? So I think we're very encouraged by that, and we're very happy to work with administrations on this issue. Thank you.
Yeah, so correct me if I'm wrong, but I think the service is only available in North America at the moment, right? So I guess it is a lengthy process.
Yes. The service is launching it's starting in North America, and I believe it's this week. But we'll see going forward. Okay.
Very good, thanks. Let's bring in our last panelist, who's also with us virtually, Elizabeth Quintana, Head of Satellite Industry Engagement at the UK regulator Ofcom. Elizabeth, please.
Thank you, Søren. Once again, I'd like to also say that I'm really delighted to be here at this conference, on this panel, especially. Thank you to the organisers, to CITC and the ITU, and thank you, to be honest, to all the speakers and chairs. I've been listening into some of the discussions, and it's been really, really fascinating. So all I can say is what an exciting time it is to be talking about satellite services and spectrum. Actually, we've been talking about regulations in the round, but a lot of the discussions have been about access to spectrum. And we have been doing quite a lot of thinking about enabling innovative wireless services over the last 3 years at Ofcom. Our spectrum strategy, which we published in 2021, focused specifically on enabling innovative services, and particularly those that enable sharing between multiple services. So this discussion today is particularly pertinent. We've also been developing our thinking on spectrum for space. We consulted earlier this year on our space spectrum strategy. And while we have recognised that we have an expanding portfolio of space activities, ranging from radio astronomy through communications, Earth observation, GNSS, through to even launch now in the UK, that NGSO communications, so communications from low Earth orbits and medium Earth orbits, are going to be a particular area of focus for us, both in terms of how we evolve our national authorisations, but also how we engage on issues at international fora like the ITU. We think they pose some particular questions for spectrum management, and these types of services fall into that category. I had not anticipated talking about this, but actually worth mentioning that on Earth Stations in Motion, as we call them, eSIMs, which are the types of services that Peter was talking about, that's been an area of focus for us internationally for a number of years, and we've done a lot to kind of open up international regulations for these types of services. So really happy to hear this being discussed in the same context. also worth mentioning that we've introduced a new process for licensing what we call NGSO FSS, or broadband LEO constellations. While it's slightly off the topic that we've been talking here, the whole ethos and approach was to encourage cooperation between service providers, help us as the national regulator manage interference, support competition, and try to create an open and transparent process through better information and a short open consultation process, which is new to how we license Earth stations. And I think those kind of 4 steps are perhaps helpful when considering this technology too, and particularly how we extend mobile networks going forwards. The reason for this is there are, as I can understand, and I'm sure there are some alternative approaches to this as well, but in terms of spectrum, there are different frequencies that operators are looking at. There are the mobile satellite service frequencies, which are an established way of operating satellite services, and Globalstar is one of those. There are those like Link, which are looking to reuse mobile frequencies. And then there's another similar technology which is extending Internet of Things, which uses short-range devices, but like the extension of mobile frequencies, it's that these are both using frequencies that are not internationally recognised as spectrum allocations, and the way that we share isn't kind of globally agreed. So I'm not going to pass judgment on any of these things. We very much, when we're looking at new and emerging markets, try to act with light touch, or when we're talking internationally, propose very light touch regulations, because we don't want to inadvertently pick winners. I would just reiterate what many satellite operators have said over the last 2 days, which is that globally harmonised regulations make it easier for them. And so this is maybe something that as a community we might need to think about as we understand the technology better. But I mean, the bottom line is we think these services are really interesting. We will be monitoring developments. We welcome further discussions with industry and with our counterparts overseas. We are just one admin. We're a very small admin. We definitely don't have all the answers, but we just do think this is a really interesting development in technologies, and we look forward to seeing how this evolves. Thank you.
Thank you very much. Let me just follow up, Jane. Sorry, Elizabeth, with a quick question on standardization. So, I'm not an engineer, but when I listen to this debate on this panel, to me it comes across as you're doing sort of wildly different things, really, both from a technology perspective, but also the target you have in mind for how this would work into hybrid connectivity. Is there anything going on kind of on the standardization side of things, or is that a thing that's lacking? And I see you nodding, Peter.
Yeah, there's quite a bit going on in standardization. Obviously, the most recent release of the 5G standards, release 17, includes a non-terrestrial network component to it, which is great because I think it allows 5G NR to be used in a satellite context. But I would emphasize that just because it can be used doesn't necessarily mean it will be. The 5G NR standards are not necessarily the most efficient for use on satellites. And as a satellite operator, one of the things we have to trade off always is the efficiency of the spacecraft versus the cost of the terminal. It's an entire economic package that we have to look at. And if you find that the satellite, which is power limited by your solar panels and so forth, unlike a terrestrial base station, is only operating at half efficiency, then you've lost quite a bit of value in that asset. So what we expect to see is introduction of things where we're today using 5G technologies in our core network and trying to move that as far as we can toward the air interface to take advantage of standardization, but also realizing the point at which more satellite-specific air interfaces may in fact be better, not just for the efficiency of the spacecraft, but for the quality of the link. I did want to pick up on something that Liz had pointed out, which is the difference in the spectrum that's actually allocated to mobile satellite services and that which has historically been tied to MNOs. And obviously this is rooted in a lot of history, but the great thing is that the introduction of software-defined radios, and I think if you looked at the iPhone 14 and many other new handsets, they're pretty well described as software-defined radios. It's no longer an issue as to whether they tune these frequencies or not, and it can also not be an issue as to whether or not they can handle the different kinds of formats needed to talk via various assets. We've been running a lot of tests with narrowband technologies coming from cellular phone handset devices, and we can today close the link on those devices worldwide 24/7 with the assets we currently have in orbit. And all it really requires is that the phones increasingly adopt this software-defined radio technology, which gives them the flexibility to tune the proper frequencies and operate in the proper formats. So we're really looking forward to that as sort of a bridging capability technology-wise to make all this possible.
I'll just give the other panelists an opportunity to chip in on that question on standardization. Otherwise, I think we're going to flip to some questions from the audience.
Can I have a quick comment?
Yes.
Sorry. Sorry. So I think that we absolutely needed to have the standardization. So not only when it comes to how do we utilize the spectrum the best ways, which of course is a combination of what Liz is doing from a regulatory point of view, but also then what we achieve in the technology. And there has to be a combination of the two to make sure that the physical resources that spectrum really is utilized the best way, because we don't have infinite number of or types of spectrum that we can use for this, right? But then coming back to Guy's comment on the ecosystem and also what do we need to have, we have to make sure that both in terms of standards and in terms of regulatory framework, that we don't make small islands across the world, because when it comes to satellite, it is a global technology, right? We're not going to be able to leverage the benefits of having this network of networks if we then suddenly say that the physical boundaries that we have on ground is putting up the parts of how do we actually get technology to work across it. Because, and especially coming from Europe, right, no country is big enough to actually have a space above us that is ours alone in that sense. So I just want to say that for me, it's the biggest opportunity, but it's also the biggest challenge we have as an industry, because it's not enough to make these nice, I said earlier, right, if we make paperwork that gives us the opportunity on the technology side, we can agree on the standardization, but if we don't use it and if we don't continue to collaborate and have the co-creation of what is needed, then the standards becomes standards on paperwork, release 17, 18, 19, whatever we see in 3GPP, and we will have regulatory framework that might or might not support it in small pockets. But we have to bring it together. Otherwise, we will not achieve the benefits of what we have. So for me, standardization is key. Both in technology, but also the interworking with the regulatory frameworks.
Thank you. I want to switch to some questions we've received from the audience, and there's a lot of interest in Link, it seems, from this list. I'm going to try and condense them into a couple of questions. So Charles, there's a question on how Link will address the issue of affordability. So it sounds great what you're doing, but how pricey will it be?
That's a great question. So I think it goes directly to the issue. So first of all, just there's a couple parts of answering this question. First of all, as I mentioned, basically everybody can afford a mobile phone. In Africa, where the average income is $5 a day. You can, in many cities, find a refurbished feature phone for $2 to $5. If having connectivity does all the benefits that we all believe, it will grow your income and easily pay for itself. So what's the cost of the service? So this is the fundamental insight. We build the infrastructure in space, it's all fixed costs. The marginal cost of providing service in any country is zero. It's electrons. Our satellites will be flying over those countries whether we provide service or not. We will put down beams with the permission of that country and in partnership with the mobile network operator there. The mobile network operator in country will determine pricing. They have all the incentive in the world to price it at a price that can be afforded by the people in that country. Right? It will also be at some price above zero because everybody understands that to be sustainable, it has to be profitable. But if it's too high, nobody can afford it. So there's a dynamic pricing here. In each country, price is set by the local mobile network operator at a price they can afford, and that will be profitable to link. In countries like the United States or Australia, or Saudi Arabia, where you can afford a higher price, well, the prices will be different. It's set by the mobile network operator there. But in Africa, so we have many partners in Africa. One that is Telecel in Central African Republic. They will set the price. So it will be affordable, and the price will be dropped, can be dropped to whatever can be afforded by the country that the satellites are flying over.
Very good. I have not a related, but also a question on Link. So there's a question on, and this is also partly for Elizabeth, will Ofcom allow services like Link to operate with terrestrial spectrum in the UK? So Elizabeth, before you get to it, let me just quickly on Charles. So I guess what you're saying is that it's not really for Ofcom because you make agreements with the mobile network operators. Is that what you're saying?
We need permission from all the regulators. We'd be violating international law to transmit in a country without the country's regulator, their government saying you have permission. We'll do it in partnership with the MNO. Ofcom is a unique situation. I'm going to show a video of testing we're doing in the UK after lunch and showed some of the results we've never showed in public before of connecting to phones in the United Kingdom, as well as 3 other countries. Ofcom came to us and said, we would like to support your testing. So they're one of the exceptions to the rule where the regulator came to us before the MNO and said, we want to support this. So we deeply regard the Ofcom as being forward-leaning and visionary in this area.
So, Elizabeth, if you could chip in on this, has Charles been knocking on your door, and if so, what did you tell him?
So I'm glad he told that. He said that because we don't talk about commercial in confidence discussions that we've been having with various companies. But yes, we have authorised Link to run some tests in the UK. It doesn't allow them to provide a commercial service. It is something that we are considering in the round, and as I kind of indicated earlier, this is one of those situations where there are no established international regulations, so we need to understand better how it's all working and have a think ourselves about how we might want to authorise it. Or if it's appropriate to authorise it. So we will be in discussions with various parties as we kind of consider that. But yes, as I said, very happy to talk to all the panelists here and to other admins as we think through this kind of service. Because it's not just about us, as I think one of the other speakers said earlier. In Europe, we have lots of countries that are all very close, and satellite services can't always distinguish between borders. We're quite lucky, we've got a lot of sea around us, so that makes it a little bit easier. But we need to understand how this works and make sure that we don't cause problems for our neighbours as well.
Thank you. I also want to bring up a couple of questions on performance. So when we're talking hybrid terrestrial, non-terrestrial networks performance, what kind of performance can we expect? What kind of performance is available now, and what can you expect in the next 5 or 10 years? So, for example, Guy, your SOS text service at Apple, is that just the first step, and in 5 years you can do a lot more satellite communication via the standard, say iPhone 18?
Well, I have to take the standard company line that we don't talk about.
Yes.
We don't talk about future products that haven't been launched. But yeah, I can talk about the iPhone 14. It is very, very low bandwidth. And it's enough to send compressed messages to the relay center and get them back. So there's information about this on YouTube or on the Apple website, but there's an interface in the phone where you have to actually follow the satellite as it's tracking across the sky to complete the link. But yeah, we're talking with others. We're always interested in bringing out better, more innovative, more useful products. So we'll see what the future holds. So.
Well, let me help Guy out. The iPhone 18 as well as 14 as well as the iPhone 12 and 13 will have, with our current technology we're demonstrating in orbit today, it all depends on bandwidth. So let me just give you an example. If we had a 10 by 10 block of LTE in a country, the current technology today supports 30 megabits per second per cell. So now you have to share that 30 megabits per second with every phone in that cell. So that's got a limited capacity, and you got to share that capacity. Now over time, as the performance get better and the cells get smaller, capacity goes up very fast. But in the beginning, the key constraint is not speed. We could give 30 megabits per second to one iPhone 12 user today, right? And they could do broadband from their phone. Now they would use up all the capacity in that cell. So our choice, which others in the industry follow on and see the logic as well, is the best way for connecting everybody is to start with messaging. That you use that limited capacity, everybody gets something. Something is infinitely more than nothing. And so we'll start with messaging and enable not only emergency messaging, but SMS messaging, emergency alerts, cell broadcast, two-way regular commercial SMS messaging on all types of phones. And so that's what we can do. So that is the key thing for everybody to focus on is the capacity constraints are going to be the drivers, and over time as we build more capacity, more satellites in orbit, we'll be able to, allow people to turn on faster services.
I'd echo, I think, what Charles just said, that when you look at the return on capacity from an economic perspective, the return is much, much higher at the low end of the bit rates. People will always pay a lot more for the first bit of connectivity than they will for the million in first bit of connectivity. And so for us, our focus in the small device area has been primarily at the low end of the data rate speeds to make sure that we can provide global coverage in only a few hundred kilohertz of spectrum, but do that to devices in real time. And I think that's the focus for us at the low end. But you asked, where is this on the other end? And because what we're doing in the broadband component is really looking at terrestrial underlay for the hotspots, the hotspot capacity that we're looking at is in the gigabit per second class, which is really intended to provide services to large groups of ships, planes, and other users in these concentrated hotspots. And in part, what that's doing is really lifting that hotspot off of our satellite network, allowing the satellite capacity to be used further afield where it can't be reached by terrestrial communications. And that extends the capability of the spacecraft and actually provides an uplift to the performance of all the users, whether they have the connectivity terrestrially or not.
Very good. I get a lot of questions on the chat here from the audience on links, but I'm going to cut it short on link because I don't want to give you too much talking time. I think I heard that you're giving a demo later this afternoon or something.
I think it's after lunch, the first session after lunch.
Right. So any more link questions, would be directed to that session, I guess. We have a couple of minutes left, so I just wanted to basically allow everybody on the panel to kind of say a couple of words to wrap this up. I'm conscious to bring in, our virtual panelists as well. Jane, anything you want to add to the discussion we've had so far?
I think the last discussions here on the performance. So of course for Nokia, where we are, I would say, known for building 5G networks on ground, when the key part for me is here when we start talking about the performance and we start talking about what can we achieve by adding, and of course from a terrestrial point of view, I'm adding non-terrestrial networks to the scope. So this coexistence is key, and with that comes a performance where we don't, coming back to saying it depends on what kind of spectrum is available, because when I talk 5G on the ground, I have a complete different spectrum package I can use. So I think that we need to, when we talk about performance, exactly find the type of services and also be conscious about how can the services be designed in the future to leverage I would still say less bandwidth when it comes to non-terrestrial networks compared with the terrestrial ones. But how can we leverage the connectivity that is there instead of just focusing on lower parts?
Thank you. Elizabeth, any final words from you?
No, that's fine. Thank you.
All right, let's go down the line. Guy, I'll give you a minute.
Okay, yeah, I'll be shorter than that. As someone coming from the satellite industry, I've been doing satellite regulatory work for 25 years. It was really interesting coming to Apple to work on the iPhone 14 project, and I think the one thing that made it work was neither Apple nor Globalstar approached it as, I'm a satellite company, I'm not a satellite company. It was just, we were trying to solve a problem. And I think if there's a lesson to be learned from our small experience to share with the rest of you, it's that approach that, I had a colleague that used to say the customer doesn't care if the bandwidth comes out of the kitchen sink as long as it works. So I think that's the problem. That's the solution, is kind of moving away from our technology and our past and just trying to solve the problem. And our experience was approaching things like that. We came up with a product that was really, really great.
So I don't want to open the whole question on business models for this, but just a quick question, guys. So your service is basically paid for when I buy the iPhone, right? As opposed to, I guess, yours, Charles.
Yes. So when we launched the service, we announced that the service is free for the first 2 years. That's not an implication that it's not free after that. It's just we didn't want to guarantee anything after that. So.
Good. Peter, any last words from you?
Sure. I would just observe that in a regulatory sense, regulations were dealing with satellites long before they were dealing with mobile phones. Mobile phones have come along and sort of dominated the discussion for quite some time, and I find it refreshing and encouraging that satellites in space are now back, and not only in prominence in the topics, but actually showing up in the titles of various agencies around the world. That having been said, we have, I think, a wonderful opportunity ahead of us as a number of things converge enabled by technology. The handsets are getting more capable in terms of bridging the divides that have existed in spectrum and formats between the space and terrestrial worlds. As Charles has noted, the satellites are getting more capable of bridging the gap between operating in the traditional satellite formats and actually operating in something that terrestrial existing handsets can use. And so I fully expect over the next few years, with examples like what Gaia's company has shown, that we're going to see this convergence, which this whole topic is about, continue, and I expect that to be fairly rapid. So 2 or 3 years from now, this panel may be considerably different.
Charles, anything to add? Otherwise, we'll cut it here. I want to limit your speaking time, given there's been so many questions on Link.
I just want to thank our hosts, CST and the Kingdom, and the ITU for putting on an amazing and important event for connecting the unconnected, and I'm just glad to be part of this community doing something so great for humanity. Thank you.
Thank you very much. Join me in round of applause for the panel.
So thank you very much again to all our panelists, and thank you to Soren for moderating that session as well. And yeah, I think, Peter, when you say that if you had this session in a couple of years' time, then it's going to look completely different, you've hit the nail on the head. I think it's exciting times, lots of new partnerships, new kind of business models emerging in their early stages. So really looking forward to seeing how things continue over the next couple of years. So thank you all very much indeed. So we're now moving to a lunch break. So there's going to be lunch served down in the lower area, the basement area, as it was yesterday. So we have an hour for lunch. So if I could ask you all to be back in here for 3:35, so just under an hour actually, where we're going to be starting our afternoon session. So we have a busy afternoon. We have 4 technology demonstrations, including the live demonstration that I mentioned, panel discussions, thoughtful discussions, and a couple of keynotes. So please make sure you're back. But for now, enjoy lunch. And we'll see you back here in just under an hour. Thank you. hear you all this. Oh, it's on already. There we are. I'll just say a few words in you, and then we'll go from there.
You need the iPad?
Have you got the iPad there? It is. That's the one we put the questions on. So we will leave it here if there is time for questions. And that's the one from the last session at the moment. These are the ones from the audience. We'll get someone to do that after in a minute. There we are. Any questions before there? Oh, okay. Yeah. Okay. So, welcome back, everybody, and I hope everyone has enjoyed once again the fantastic spread laid on for us by CST, and I hope everyone at home as well has had a chance to go and maybe stretch your legs a bit, and it's great to now have everyone back here for the next session, so the next round of our technology demonstrations. So before I introduce the technology demonstrations here, one thing I did want to just mention that we do have our next tutorial just starting now in the Hall 2, so up on the mezzanine floor. So that tutorial, a parallel tutorial which is running, is about to start now. And that, for anyone watching online, that's available on the second stage. So you'll see there's 2 stages. So if you access the second stage, you can go and watch the tutorial that's running. And to see what that's going to be focusing on, should know. Integrating terrestrial and non-terrestrial networks, 3D opportunities and challenges. So that is starting now as well. But back here on the main stage, we're delighted to have our next round of technology demonstrations. So these technology demonstrations are going to be focusing on connectivity everywhere from low Earth orbit. And we have 3 more demonstrations with us. So to introduce those and to introduce our speakers for this session, I'm delighted to pass over now to Ayman Maghrabi, who's going to be, as I said, introducing the session. So Ayman, welcome. Over to you. Leave your paper there.
Thank you. Hello, everyone. Welcome again after the lunch. I hope you enjoyed it. Again, my name is Ayman Maghrabi. I'm Director of Frequency Assignment at CST, and we're really excited to have you with us today in the first technology demonstration session we have for this day. From the name, it's about connectivity everywhere from low Earth orbit. LEO, for short, is in low Earth orbit, has been an increasingly hot topic in the past few years in the space domain. It's really considered to be the starting point for the new space race. Every month or so, you see new satellites being launched here and there into LEO orbit and GSO, and really so many companies and new solutions are tapping into that orbit to provide a unique set of solutions. And I'm really proud and happy that today we have 3 of those companies who have providing a unique set of solutions. We will give the floor to them to introduce what they have done so far, what's their plan in the future, and I'm sure there's trials embedded there. So I'll briefly introduce them, and then they'll leave the stage for them. First, we have Laith Hamad, CEO and board member of OneWeb NEOM joint venture. We also have Charles Miller, CEO of Link, who was here previously on the stage. And finally, we have Mendel De La Torre, Chief Regulatory and International Strategy Officer at Omnispace. I will give the floor to each of our speakers. They will have about 15 minutes to showcase their technology and show any trials they have done. And then, if time permitting, we'll have a very short Q&A at the end. So I'll start with Laith Hamad. The floor is yours.
Thank you so much. Thank you so much, Ayman. It's a pleasure being here in Riyadh in this very important event, demonstrating what technology has come far and how advancements we have technologies now to connect everyone everywhere. My name is Laith Hamad. I'm the CEO of OneWeb NEOM joint venture, and I'm here to present to you the demonstration we had with our partners here in the kingdom about connectivity from the sky, a broadband demonstration we had, and a cellular an IMT cellular backhaul demonstration we have as well. So if you allow me, I'll start with a very quick slides about what is OneWeb, and then how we have actually come here and we did the demos. And then at the end, I'll leave you to see two videos. Will show the story, but maybe I'm now in a position to show a few pictures. Those pictures are nice pictures taken in a very nice environment, but I will not show you how much we were sweating in the middle of the desert in around 50-degree temperature. But that's all a credit to our partners facilitating facilitating and solving all the hurdles until we are finally here. We're happy to announce what we have accomplished. So OneWeb, maybe if I switch to the other microphone. So OneWeb is a global communication company. We use satellites in the low Earth orbit to connect to the ground. And this satellite constellations are hundreds of satellites which orbits the Earth from north to south or south to north. And we have 12 orbits and 49 satellites in each orbit. So that's a total of around 600 satellites connecting the globe on 24/7. This is how our satellite looks like. We do 36 satellites per launch in one rocket, and we have launched so far around 460 satellites, and we still have 4 more launches until we complete our constellation and we start provide the continuous service. So first of all, what is the LEO orbit? The LEO orbit is an orbit which is close to the Earth, and we have different other type of orbits where satellite being providing services to the Earth now. We have a geostationary orbit at 36,000 kilometers and a middle Earth orbit at 8,000 kilometers, and OneWeb is at 1,200 kilometers, and that's basically why it is called a low Earth orbit, because the satellites are close to the Earth. Why we need the satellite close to the Earth is to serve some type of applications which is latency sensitive. The latency is the time for the signal to go from the Earth to the satellite and it comes back. And this is, in the geostationary, for example, around 600 milliseconds, which will not allow some type of applications to be provided. Having a lower latency, as OneWeb we have like 50 millisecond latency, will allow us to provide a range of applications which is latency sensitive. We have launched so far 464 satellites. We have built many of our ground stations that we are going to build around the globe. We have a total of 45 ground stations. 2 of them will be in Saudi Arabia, or basically one gateway in Saudi Arabia split it into 2 locations. And these gateways is basically a farm of antennas. We have many antennas because each antenna speaks to one satellite at a time. We manufacture our own satellites. We have a factory in Florida, which is a joint venture between OneWeb and Airbus. We manufacture 1 satellite per day, and we have recently announced that we have all our satellites manufactured and stored at a safe as a warehouse, ready for launch. So the remaining 4 launches, we have all the satellites ready, and our last launch was next week. Last week, we have launched 36 satellites. Our next launch will be this month, and the following launch will be late December, early January. So by then, by beginning of Q1, we should have launched all our satellites to the space. This is how our satellite looks like. It's not a small satellite, but not a big satellite. It's like a 1 meter by 1 meter by 1 meter satellite, which has all the avionics and the payloads in it. We have several type of user terminals to connect to the constellation. We have a dual parabolic terminal. We have a flat panel terminal, and we have a plan to have a mobility terminal. And this is how one of our gateways looks like, several antennas. So OneWeb was in the kingdom since 2017. We have opened our presence here. We started our engagement with the government. We have been granted a license from CST. And in October last year, we have signed a joint venture with NEOM. So now we're partnering with NEOM to deliver the connectivity to NEOM, to the kingdom, and to the region. And this is the signing ceremony in October last year. So the ceremony was attended by the CEO of NEOM and Minister Al-Falih, Minister of Investment, His Excellency Al-Falih, and Minister of Communication, His Excellency Al-Swaha, and the Minister of Investment of the United Kingdom, and the Chairman of OneWeb. So now let me take you quickly to the demo, and I'm very glad to be in this position, and I will start by thanking our partners. A huge thank to CST for their support, to our partner Aramco, Saudi Aramco, and to our partner STC. So we've done 2 demos. One demo is to show how we can provide a broadband connectivity, and the other demo is how we can do a cellular backhaul connectivity, which means you extend the cellular network to remote areas where you don't have connectivity. So the system that we use to do the connectivity is combined of 2 components. The first one is 2 antennas which represent the gateway, because you need, for connectivity, you need 3 components. You need the user terminal, the satellite in the sky, and a gateway which is connected or tapped to the internet. So we have 2 antennas to represent as a gateway installed at Saudi Aramco, and we have our user terminal from our partner Kemeta. This is a flat panel user terminal. So we have installed everything in Aramco in Dhahran, just tested everything, and we made sure everything is okay. We configured the system, and then we moved to the desert. So this picture is, as I told you, it's very nice, but it's super hot. That was in the morning. We had some nice photos there, and then we have connected the antenna to the cow. The cow is a cell on wheel, which is basically a small base station, which can provide the 5G coverage, but it does not have any backbone. It does not have any fiber or microwave connectivity. So what we did is we connected the cow through a fiber link to the Kemeta flat panel terminal, and then this terminal will speak with the satellite. The satellite will communicate with the gateway at Saudi Aramco, which is tapped to the internet, so you go the exact way back. So we did the test around 9 p.m. That was one of our satellite passes during that time. And what we have achieved, we've run multiple demos, and we achieved a 99% successful ping rate, which an average of 23 millisecond latency. So we've done this many times. So the successful ping rates is around 98 to 99, and the latency is always around 23 millisecond. And this is the last picture. Obviously, you see here a 5G network in the middle of the desert on my phone, and I'm speaking to my colleagues on a video call. And the team was supporting us in the demo. And I'll leave you with the 2 videos. The first one is the broadband demo, and the second one is the cellular backhaul demo. Thank you so much.
As you can see, I'm in the middle of nowhere. Fortunately, I'm not alone. So let me introduce you to Engineer Abdurrahman Al-Rafa' from SSC, as well as Engineer Muhammad Al-Jabri from CITC. So guys, what are we going to see today?
LEO basically means that it's in the low Earth orbit. Those satellites fly roughly around 1,200 kilometers above the Earth.
Okay.
OneWeb full coverage and services will be ready in Saudi Arabia later. This year is utilizing a small compact user terminal. However, for today and for the demo purpose only, we rely upon 2KA gateway and 2KU user terminal, which will connect to the OneWeb constellations of 648 satellites orbiting in 12 orbital planes. This user terminal will connect with the active satellites one after each other once it's passing at very high speed above us.
Interesting. But literally, how does it work?
OneWeb satellites connect to our device through these customized terminals.
Exactly, which encrypts our data and sends it to OneWeb low Earth orbit satellite fleet.
These spacecrafts are literally revolutionary. They fly 30 times closer to Earth compared to ordinary geostationary satellites, flying at 36,000 kilometers. This enables real-time connection with no interruption or annoying lag. Our satellite fleet keeps orbiting in a constellation organization, creating a seamless coverage. Each of our satellite uses a set of beams covering 663,300 square miles. Our flight pattern encounters no terrain obstacle and always finds your signal, even in the trickiest locations. And this is a major difference over GEO satellites.
OneWeb has 2 operational centers, one in London and the other is in Virginia, where fleet management, ground operations, and customer technical support teams are based.
OneWeb is dedicated to the idea that space is a shared natural resource, which, if used responsibly, can help transform the way people live, work, and interact. We actively manage the satellite fleet and work to every best responsible space practice standard to minimize orbital debris.
Now, our data re-enters the web through one of OneWeb's point of presence and gateways located within Saudi Arabia in a secure location.
Thank you. This is an innovative technology realized for the first time in Saudi Arabia by CITC. We will try for the first time a LEO OneWeb connection.
This is Wi-Fi. You need to remove this option. هذا اللوجو هنا. علي ايوه فيصل حيكون معانا في التسجيل. فيصل صوتك. يس. That's better one. Can you direct? Yes, I can hear you.
I'm trying to connect. Hello, can you hear me? Hello? Oh, hello everyone.
Congratulations, everyone. This is the first LEO satellite broadband connectivity in the Middle East. Thanks to our partners from OneWeb and Saudi Aramco for making this happen. Saudi Aramco operations depend on multiple remote sites. We are in need for high-speed connectivity, for quality of life, and enabling digital transformation. This is a real advanced technology which will not only benefit the remote areas in the Kingdom of Saudi Arabia, but the region and the globe. Would like to thank everyone for this achievement. You have connected the unconnected.
Thanks to OneWeb space-based LEO broadband connectivity, introduced and authorized by CITC in collaboration with Saudi Aramco, everyone will soon enjoy the ability to remain connected even in the most remote areas of Saudi Arabia. Thank you so much.
Yeah, we did it. It works. It works. Congratulations.
So that was the first video. I hope you like it. And it tells the story basically. And the second video is about the cellular backhaul demo that we have done. I'll leave it with you. Thank you.
CST introducing 5G cellular backhaul from low orbit satellite. Part of the non-terrestrial networks experiment, CST, in partnership with OneWeb, STC, and Saudi Aramco successfully managed the first 5G cellular backhaul experiment in MENA region using OneWeb low Earth orbit 648 satellite constellation. The test was held by engineers from OneWeb, STC, CST, and Saudi Aramco, connecting OneWeb satellite constellation to a Kymeta flat panel antenna of 82 centimeters diameter. STC cell on wheel provided 5G connectivity to Aramco rig in Abcake remote area by connecting the site to STC network located in Dhahran through OneWeb low-orbit satellite constellation. This solution offers mobile operators the latest technology for connecting any of remote site to their network all over the Kingdom of Saudi Arabia.
So I hope you enjoy it. Thank you so much. Thank you for having me here, and a big thank you to our partners. Thank you.
Thank you, Laith. I think that was a very interesting start for the session. We've seen how the LEO has enabled broadband and also backhauling for 5G. I invite to the stage our second guest, Charles Miller, the CEO of Link, to introduce. He was here earlier, so he's in no need of introduction.
Thank you, everybody. So first of all, let's see here. I'm just having a great experience here, my last couple days here in the kingdom. I think what's going on in this country is magnificent. I want to commend everybody here for what you're doing in technology and communications. I'm blown away by what you're doing in space, and I just think I encourage you, hopefully with my words, to keep it up, and hopefully you'll get some inspiration out of what I'm going to share today. Some of what I'm about to show you has never been shown in public before, and some of this testing data. I'm going to show you testing data from 4 different countries. We are testing in 14 different countries, and hopefully you'll get something out of it. So this up here in the top left is the world's only operational satellite cell tower in space. We call it Link Tower 1. It's our 6th satellite in space. The first 5 were experimental prototypes to rapidly develop and demonstrate and test out the technology. And this one is operating today. So our mission is to connect everybody in the world, everywhere, no matter what. And when we say no matter what, we're talking about some bad things happen. Hurricanes, earthquakes, volcanoes, tsunamis, that when things on Earth take out the mobile network, you'll get instant backup from space. So this satellite is another picture of the satellite connected to inside the Falcon 9 SpaceX fairing. This was launched in April. To date, Link has signed 23 commercial contracts with mobile network operators around the world. Our plan is we will only sell through mobile network operators. This is a partnership. We want to be the trusted partner of MNOs around the world. This makes it easier on you. You don't want to have to figure out who Link is. You just want your phone to stay connected everywhere. You don't want to have to figure out if, should it connect to that satellite or another satellite. You really don't care. You just want your phone to stay connected everywhere. And so that's how we're going to do it. You already have your favorite MNO, and suddenly it'll stay connected everywhere, and many people won't even realize it's because it might be connected by satellite. So we're testing in 14 countries on 5 continents. We're working on the next continent here coming soon. We were granted the world's first commercial license for satellite direct-to-phone by the Federal Communications Commission in September. We had gathered a couple years of testing data, testing in the United States and other countries, which we shared with the FCC as part of this process. We had to demonstrate in great detail that we could connect phones without causing harmful interference. That's what testing licenses are great for. So FCC was very rigorous about this. They have a lot of engineers. And we are proceeding very quickly to ramp up from here. So we're now the existing satellite tests in 2G or GSM and 4G LTE. We're launching the world's first 5G payload in space for satellite direct-to-phone this fall. So let me start showing you some of the data. So how do I hit? So the kingdom is very big, 2.1 million kilometers square surface area. I tried to find a country that was as big as the kingdom. That's hard to do. Mongolia is 1.5 million kilometers. I'm not sure how to play the video. Can click it? All right. So this was a test in June in Mongolia with our partner Unitel in Mongolia, one of the MNOs in Mongolia. They asked us to put down the beam there. Clearly, there are some phones. Every one of these dots here is a mobile phone that somebody in Mongolia owned, and we're out of connectivity at that time, and we connected. And so what this means is proves a couple things. One, we're connecting existing mobile phones, and in Mongolia. Two, means there's a lot of disconnectivity there. So it turns out in Mongolia, about 50% of the landmass has no connectivity. So this is we're going to provide extending coverage everywhere in Mongolia, and rural coverage is just one of the use cases that Link can serve. Let's go to the next test. Here is Central African Republic. So our partner, we conducted this test with our partner. This test was October 1st with Telecel in the Central African Republic. And, you know, there's various countries in Africa. So put down the spot. They asked us where to put down the spot beam. We put it down in that location. We can put this spot beam wherever the MNO partner would like us to put it. It's a steerable spot beam, of course, and this allows you to, you know, stay away from countries' borders and prevent cross-border interference. Let's see here. I promised you a test in the United Kingdom, courtesy of Ofcom. So, I hear often how everybody's covered in cities. Well, there's an easy way to prove that. If we put down a beam over a city and every phone is covered, those phones will not request a connection to our satellite. They already have coverage. Right? There'll be this satellite, this cell tower that shows up on them. If they have coverage, they don't even ask. There seems to be a corridor in London that has a lot of disconnectivity. So we have, you know, an engineering and an office and subsidiary in London. We do lots of testing in the UK, and the UK has been very supportive of what Link's doing. Here's our last demonstration. This one's in Bahamas. It's from the other side. So we put out often field engineers into areas in different countries of figuring out, do certain phones work better than others? Do older phones, newer phones, different types of configurations? Getting the signal from the ground is part of constantly improving the service. You know, so let me just put in here, we're not only connecting mobile phones, we're connecting every type of mobile phone, every type of iPhone, Android phone, Samsungs, Google Pixels, other types of Android, feature phones. And it's not just that. When we're putting these beams down and testing, in many cases, we're connecting to standard cellular RF IoT devices. Sometimes these IoT devices, you don't know what they are because they're through some IoT aggregator. but sometimes you do. So we have connected over 8 different types of John Deere tractor from space, to my knowledge. It may be more than that. So this solution works also for standard cellular RF IoT devices. But just want to show you, I picked this for a reason. Every one of these devices here basically did, standard SMS, but they don't make much sound when you send an SMS, but this does. So that was the first SMS. The emergency alerts came through, and then the SMS from those devices and all the other devices went through. So you can today, on virtually any type of mobile phone, send regular commercial SMS up and down. You can send emergency alerts. And Link has also invented a whole new application we call Linkcast, which is over the broadcast channel. Satellites are constantly broadcasting down to Earth like, I'm here, do you want to get on? You can put down information. So if you have an app on the phone, you can send everywhere in the world constant weather updates, and you don't even have to connect to the satellite. We can provide a free utility to those countries that allow us to put down a beam. Everybody in your country has updated weather for the next 3 days. Even without a subscription, you will get that service. So Link is going to give away, countries where we're doing commercial service, we're going to give away that service for free. So many different things, really cool things you can do with just messaging. So I'll stop there and look forward to the questions.
Thank you, Charles. I think that was a really unique approach to delivering connectivity straight to the devices, and I think we discussed this in details in the previous session, and it's good to see actual testing and devices working on this. So thank you again for the demonstration. And last but not least, we have Ms. Mendel from Omnispace. If you would like to come and take the floor.
Good afternoon, everybody. It's really a delight to be here today. Thank you to the CST and the ITU for inviting me. It's been a long time since I've actually spoken to a group of people in person, so that's really fun. And it's good to be back with Forum Global. You know, you all are great organizers, and it shows in the conference. So today I'm going to introduce Omnispace and show a couple of videos to you. A demonstration of the hybrid satellite mobility connectivity that we did here in the Kingdom of Saudi Arabia. And then, you know, the first video that you're going to see is basically Omnispace's vision of a 5G NTN system. And we see ourselves basically as the first global hybrid satellite mobile network using the S-band. We'll be delivering that 5G NTN service to consumers, to enterprises, to government, to IoT users. And the idea is to bridge the digital divide that exists in 5G. So in 5G, you know, 5G is normally deployed in cities, in areas that have a lot of, you know, congestion and people there. And then the people in rural areas and in isolated areas really just don't get that. And so what we're seeing with that 5G NTN is it will be able to bring some of those really high-level services to people all over, you know, all over the world. And you know, so we're basically looking at you know, the future, but the demonstration that we did here was with our Omnispace Current satellite, which is a MEO satellite, and we were demonstrating basically simulating what 5G NTN would be in the future. And we were looking at sort of how you might be able to do connectivity, hybrid connectivity. So you would do both satellite as well as the mobile service using the same systems. And as I said, we have a MEO, but we have 2 prototype LEO satellites that have been launched for our next generation LEO system. So we are MEO, but we're moving to LEO. And, we're looking at, I think, similar to what you've heard a lot of companies saying here, is that the direct-to-device capability is something that we're really interested in doing, and we're seeing very many possibilities with that. And, now that the 3GPP has come out with release 17. You've heard other companies talk about that. That is really a game changer for the mobile satellite industry, and particularly for companies like ours, where you end up with in fact, the spectrum that we use has been standardized under Release 17, so that's a very good step for us. But it'll bring economies of scale, and I think you've heard during the last couple of days about the fact that sometimes the satellite devices can be extremely expensive. But when you get those economies of scale, then you can have lower prices, you can get a variety of different devices, but that are all standardized. And I think that's one thing that's been lacking in the industry so far. And so, as I said, one of the things that we're looking at for that 5G NTN is working with mobile network operators, similar to what Charles said, that we would basically expand out the coverage that they have. So in an area where a mobile network operator has coverage, fine, they use their coverage. And then when it goes into a network where it's either a visiting network for them or on a roaming, they could actually use our satellite network to get to their own customers or to other customers. So, we see that, and in the demonstration, you'll see that we did that with STC here in the Kingdom, and it was an example of that. And so, one of the things that you'll see in the demonstration that we're going to show is that, we were running a TT&C kind of thing. But anyway, so first we'll do a demo on the OmniSpace itself, and you can see our vision for 5G NTN.
Imagine the transformative power of 5G, connecting directly to billions of mobile devices, anytime, anywhere on the planet, directly from space. One visionary company is making the promise of global 5G connectivity a reality. OmniSpace is uniting the versatility of mobile wireless solutions with the reach and resiliency of satellite connectivity to deliver the world's first truly global hybrid network. OmniSpace is leveraging the power of 5G to deliver mobile connectivity for consumer, enterprise, government, and IoT users worldwide, and to fuel innovation through a globally harmonized connectivity platform, providing reliable, real-time data delivery unlike the world has seen before. OmniSpace will unlock a global ecosystem to empower economic opportunity with improved access to education and commerce, to power industry by optimizing supply chains and automation, and to save lives by ensuring rapid response to any disaster, humanitarian crisis, or tactical situation. Power possibility with global 5G connectivity. The future of 5G is hybrid. The future of communications is OmniSpace.
So that gives you a view of the company, and so what we've done with our trial here in the Kingdom of Saudi Arabia is we used the hybrid system to be able to provide, connectivity to a drone. Now, it's a little different than some of the drones that you've seen here, because we're not using the drone as a base station in the sky. What we're doing is we're doing the connectivity and the TT&C from both the satellite as well as the mobile network that are basically, connecting the drone and commanding the drone to do what it was. And so we've been working with our partner Air Market, which is based out of Canada, and our partner UAV Systems, which is based out of Mexico. And what we've been doing with them is, one of the applications that we've been working with them is on sending drones along pipelines to see whether there's leakage or other kind of anomalies. That made it very perfect to work with Aramco here in Saudi Arabia. And so what the video will show is basically the application of working in an area where you'd have pipelines and other things like that. And so we're working with our two partners for Air Market and UAV, and then we're also working with STC, who's doing the connectivity, the mobile connectivity, as well as Aramco. So now we can play that video, please.
Assalamu alaikum, everyone. I'm Faisal Al-Said. We're fortunate to be here today at the Aramco Dhahran Fire Training Center to witness one of the most promising and innovative mobile connectivity solutions for the 21st century, developed by Omnispace in partnership with Air Market and UAV Systems. We're going to demonstrate how powerful global hybrid real-time connectivity can be. We'll be demonstrating this using a drone that will be controlled all the way from Edmonton, Canada. Yes, that's correct. Controlled from Edmonton, Canada, and yet flown locally here in Dhahran. Follow me, and let's discover what this is all about. Assalamu alaikum.
Assalamu. Welcome, Faisal. Nice to see you.
Nice to see you. So tell me, what this technology is all about?
It's a very advanced technological solution to what seems like simple request, seamless access to global voice and data connectivity. One that makes reliable communication possible from anywhere in real time, eliminating coverage gaps in unconnected areas around the planet.
Can you show me some of those technologies on the drone?
Yeah, of course. Come with me.
All right.
Here we have a GPS satellite antenna. Also, we have omnidirectional satellite antenna.
And this must be the cellular connected companion computer.
Yeah, that's right. Today, we'll first demonstrate how it's possible to start communicating with the cellular network, and as the drone flies away, it will switch to satellite connectivity. We will then manage to do the opposite as a second trial by switching from satellite to cellular network, and we will establish the third connection, maintaining hyper-connectivity through satellite and cellular. Omnispace is pushing the limits of what's possible, and we are demonstrating how satellite communication technology can augment mobile telecoms network and enable ubiquitous mobile voice and data communications in real time around the globe. Follow me. Let's join our partners and start the trials.
Right.
Let me introduce you to our pilot based in Edmonton. He will be the one controlling the demo drone in real time.
Hi. What if the satellite connection gets interrupted?
No problem. Our local safety pilot here in Dhahran can take control of hexacopter in case of need or any emergency.
All right.
Okay, guys, ready to start trial number 1.
It's the moment of truth.
Look, we are communicating to the hexacopter using cellular connectivity. Okay, now let's switch to controlling the drone using the satellite connectivity.
Here we are. It works.
Okay, Faisal. As the first trial worked, let's now establish a connection with the satellite and start the second trial. We are connected.
We are connected with no interruption.
Now, the final trial, combining satellite and cellular connectivity. It's a complete success. We are connected. This is a huge accomplishment by all. We are demonstrating that it is possible to unite the simplicity of mobile telecom, roaming with the scope of satellites, to create one seamless connected experience.
Indeed, what an amazing result. We just showed that continuous connectivity for mobile assets is possible around the globe. Now imagine what we can do with the 5G non-terrestrial network and how that will empower enterprises and IoT users with access to seamless data and connectivity worldwide.
Thanks a lot, Faisal. CITC would like also to thank our partners, Aramco, Omnispace, Air Market, and UAV System, the drone provider, for making this happen. Now, thanks to this brand new technology, the entire world can remain connected from the sky.
So while this is not actually 5G NTN because it's just been standardized at 3GPP, it's an example of what could be done. And I think that the word that I loved that the announcer was made was the seamless part of it, because it did go from mobile to satellite and back again. And I think that's something that's what, you know, one of our phrases that we use a lot at Omnispace is that it will be a seamless. It'll go from satellite to mobile connectivity. And we successfully connected, commanded, and basically flew a drone, which if there is any problem with it, as they said on the video, that would have, you know, you would have seen a big crash of the drone, which would not have been a very good thing for anybody. But we believe really that this is a preview of the technology innovation of 5G NTN, you know, to provide that connectivity anywhere in the world. And we're very appreciative of the fact that Saudi Arabia, and through the CITC and now the CST, has been looking at NTN in particular. In fact, we think you're probably the first country to look at NTN itself as, I won't call it a service, but you know, as something to be licensed. So we really think that that's great. And we do think it's super important for a country like Saudi Arabia, that is a huge country with with a lot of areas that are unconnected. And you all, I know, are trying to bridge that digital divide and you know, fill those coverage gaps. So we think it's really a solution to issues that you have here. But anyway, on a final note, I just wanted to thank the CITC, now the CST. When we were working with it on the video, it was the CITC and Aramco and STC and you know, here in the Kingdom of Saudi Arabia, and then our partners Air Market in Canada, and then the UAV systems in Mexico. Without their support, we wouldn't have been able to do this, but we really appreciated it, and we very much appreciated being part of the demos here in Saudi Arabia. So thank you so much.
Thank you, Mendel. I think it was a great demonstration showing, you know, how we go from satellite to cellular. This is really integrating NTN and terrestrial as well. I need to check with Dan if we have time for a question or two. No? I'm afraid we don't have time for questions, but I would like to thank our partners, our guests. I think the demonstrations really piqued everyone's interest. We've seen what NTN can do. We've seen what LEO in itself has. We've seen so many offerings on LEO, and I think we will see more and more services utilizing NTN in the other technology demonstration sessions. Thank you, everyone, and we hope to see you soon again.
So thank you to Eamon, to Laith, Charles and Mindell, and three fantastic examples and demos of technology in action. So apologies that we don't have time. Sorry guys, we didn't have time for the questions, but I think hopefully Mindell, Charles and Laith will all be hanging around for a while. So please do feel free to find them during one of the breaks, and I'm sure they'll be more than happy to answer any questions that anyone has. But we're moving straight on now to our next panel discussion. So the next panel is going to be focusing on new disruptive connectivity competition. So I'd like to please invite up to the stage our moderator, Natalia Vicente from Global Satellite Operators Association, and our panelists, Mikhail Brichta, Motoi Matsumoto, Vadim Tarasov, and Mohamed Maki to join us, please. And I think we also have Jennifer Manner hopefully joining us virtually. So we'll just do a quick change around now, and then we'll be back with you with this panel very shortly. Okay, so I think we have everyone here, so I'll pass you over to Natalia. Natalia, over to you.
Good afternoon, everyone. Thank you very much, Sam. I'm very happy to be here today. First of all, thank you to STC and to ITU for organizing this fantastic event. I think we are all enjoying and learning lots of things. My name is Natalia Vicente. I'm the Public Affairs Director of Public Affairs and Communications of GSOA, the Global Satellite Operators Association. And I'm here today. We are here in a panel that we are actually going to discuss about the disruptive connectivity competition and how all the different technologies, and we have been seeing this for the last couple of days, but how they can integrate and how they can work together to connect the unconnected, to connect the future, and especially to fulfill the connectivity goals that we're seeing that we need worldwide and globally in our demands. So today I'm here with a fantastic panel. We have Jennifer Manner, SVP of EchoStar, joining us virtually. We have Michal Brikta, head of the Slovak office. Motoi Matsumoto, Deputy Director for the Global Communication Business Division at SoftBank. We have Badin Tarasov, Managing Partner for Advanced Autonomous Solution at UAVOS. And Mohanad Maki, VP for Career and Wholesale Marketing at STC. And so I would like to start with you, Michal, because when we talk about technology, one thing that is clear is that governments and regulators are playing a key role in allowing the new developments and the technology to move forward, and connectivity is not an exception. So please, it would be interesting for us to know what this government in Slovakia is doing, and how are you managing to create a space environment and an ecosystem in your country?
Thank you very much. Thank you for having me, and great pleasure to be part of this interesting conference over the past 2 days. Thank you to the host. We've been talking a lot and listening a lot over the 2 days about connecting the unconnected, about connecting new people, about connecting users of technology. I think that along with this important topic, it's also very key question how to connect the technology developers, the new emerging technological ecosystems, the new and smaller industrial players, to enable us fully use the potential of the, in case of space sector, to fully use the potential of the global space community. And in Slovak Space Office, we truly believe that the so-called democratization of space economy is an important answer to how to truly utilize the full potential of the global space community, and how to ensure that through the collaboration, through international partnerships, we can move forward in our development. So this is what I wanted to kickstart with this session. And to your question, we have started the space ecosystem development relatively later in 2019. So even though we are not new to space as a country, we've had scientific missions and payload R&D back in 1970s, but only recently in 2019 we've took a look at space as economic domain, about economic sector, and started to take systematic steps to develop it further. And our first idea why we did that was to increase the investment interestiveness of the sector and the investment appeal, to make it more interesting for incoming investors. And the second key objective was to help our country to get ready for moving forward with our collaboration with the European Space Agency, to prepare our space ecosystem for associate membership in ESA. So we identified 2 key challenges in the very beginning of what we understand being very general challenge for any smaller and new emerging space ecosystem. And first of all, it's a very small size of the sector, which means that it's very difficult to create synergies, to create collaboration within the ecosystem. And secondly, very small international awareness about what's being done in the country abroad. So in 2019, we start approaching these topics, and working mostly in area of spinning in, so attracting non-space technological companies to the sector, and also being engaged in a lot of international awareness raising and supporting bridging our companies and our stakeholders with foreign partners. So this is basically how it started. And last year we created, together with our partners, the Ministry of Education and Research, the Slovak Space Office. So it's moving forward with new supportive tools aimed at sector development, with hackathons, with incubation program, outreach activities, and also a variety of international partnership forming activities as well. So it's been an interesting journey, and it's great to see that it bears fruits, as last month we finally officially became associate member of the European Space Agency, so now we are looking forward to further developments.
Thank you very much, Michal. And indeed, I think precisely space and satellite, like Slovakia, they are focusing more in space and satellite in the last few years. There is a spotlight for them. So Jennifer, you as the satellite operator representative, on this matter, the spotlight that space and satellite is having for the last few years, and it's mainly or mostly because of all the NGSO systems that we're hearing and all the trendiness that has come along with it. But we know that there has been a lot of work done also with the Standards Forum in 3GPP. I know you are very involved in that. And this clearly will have an impact in the future of connectivity. So how does EchoStar see this happening?
So first off, I want to thank you, Natalia, for the question, but also thank CST and the ITU for having me. I really do apologize that my schedule didn't allow me to come to Saudi Arabia. I so wish I was there in person. But what we're talking about is so important. So we started getting involved in the standards process as early as, well, we've been involved the whole time, but I'd say 2000, even before 2012, 2013, there really was a movement. So 10 years ago, trying to include satellite into the 3GPP standards was so important to us. And first, I'd like to say we spent a lot of time trying to convince others, and I think one of the things JSOA should be proud of is JSOA really helped to align the industry along with ESA to ensure that we were working together to be successful. And because of that, I think with changes in technology, you know, you talked about the LEO or NGSO technology, but it's just generally, I'd say, since I started in the industry, which was almost 3 decades ago, I was only 2, of course, we've really seen dramatic changes, especially with regard to cost. And really, when we think about what's going on at 3GPP, and in June, when we finally, for the first time, had satellite included, the NTN satellite standard, not just satellite, but also drones, of course, we really see a market change. And I think what you're going to see for the first time is the fact that we're going to have consumer electronic devices having satellite in them, I would say almost naturally. I mean, now we've got a standard for the chipsets. So as you've heard a number of speakers talk, all of a sudden, the dream, I mean, this was a dream back when I started, you were going to be able to use your regular phone to call a satellite. And I'd say within a year or two, that will be a reality as the equipment starts to evolve. But you're also seeing this brought into broadband. I know I heard when I first joined about the OneWeb test with cellular backhaul. All of this is going to make satellite a transparent part of the global communications network. No one at the end of the day really cares how they get their communications, whether you're in Riyadh or in one of the beautiful deserts in Saudi Arabia. What we care about is that we get quality service. And so I think really what you're going to see is better connectivity, Natalia, because satellite is able to provide service where no one else can do it. And you saw Mendel's clip, you heard from Lynx. All these technologies together using 3GPP standards, I think is just going to give a better user experience and meet our goals, all of our goals for a connected world. So thank you.
in line with all that we have been hearing during these last 2 days and the presentations that have been in our panel before, and precisely from the sky with Jennifer, we can go down to the ground with STC. So, Mohanad, STC has been partnering with satellite for a long time, so you are not known to the skies. But with the innovation that is happening, how does STC see the satellite requirements evolving, especially now with 5G and with the requirements that are now, and with a focus on the rural and remote areas?
Well, thank you, Jennifer. In fact, as you rightly mentioned, STC has been always in collaboration with the non-terrestrial networks. We've been working with satellites for so many years, all the way offering connectivity to the high-throughput satellites, HTS. However, in Saudi Arabia, we do see that the investment could happen on both areas, the terrestrial and non-terrestrial. STC has been investing in the terrestrial networks massively while utilizing the non-terrestrial networks to make sure that we have the full combination of reachability to the customer. While there is a terrestrial network that we can provide, there is a non-terrestrial that can reach to the customers in areas that are untapped by terrestrial networks. Yes, there could be a competition between both parties, but if we look at the bigger picture, it's more of a complement between both networks, where we can create a hybrid model, where we can have an ecosystem of both networks working together through a seamless integration between both networks. The advancement that is so massively happening, I believe, in the last few years of the satellite technologies is providing a very solid non-terrestrial networks that can offer all the way up to the 5G capacity and technology. All what customers cares about, as Jennifer has mentioned, is the connectivity, a reliable connectivity, a low latency, a high speed, and being able to be connected to the world. So if we can look at this model and how would it look like between offering services from the non-terrestrial network or from terrestrial network. For example, a nurse station that's serving non-terrestrial network is actually backhauled by a terrestrial network to provide a 5G connectivity and high-speed, high-quality connectivity to an area that is untapped by the terrestrial network. That doesn't only work in areas of non-terrestrial networks that are not available, but it also works in the areas where disaster recovery could be essentially needed, and providing more of reliable and business continuity to the customers.
And we see that there's more and more collaboration and integration. And it's not only about the satellites or the terrestrials, and innovation is happening in different forums, and as we have seen during these days, hearing a lot. So Motoi-san, please. I know that you are working very much on a project about hubs in sub-Saharan Africa. It would be interesting for us to know a little bit more about how the hubs and the labs are. Do you think that they are the game changers? They are the ones that are going to break it?
Thank you very much for inviting me, continuing from Genova. I'm proud of being here. Thank you again, CST and Saudi Arabia. I'm very comfortable here now. Let me get this straight answer your question. I believe that perhaps is a promising technology. Yeah, will be a game changer. It may take several years from now, due to some issues we are solving. But when it comes to the sub-Saharan Africa, whenever I visited the unconnected school, some school doesn't have electricity, where satellite network won't be able to cover, right? Practically speaking. So that's why even with the 4G handset, hubs will be able to realize mobile dialect. So I think, again, hubs will be game changer. But I don't deny the new advancement of satellite. D2D of satellite is also interesting movement. And one thing I want to stress here is that we don't have substantial HAPS market yet. So we don't have to compete each other. We have to foster the HAPS market jointly with Airbus, and all other partners in the HAPS industry. And then also in the future, we don't have to fight between satellite and the HAPS. We can be kind of a complementary, partners in the future, I guess. Yes, that's what I comment. Is okay? Thank you.
Sure, it's perfectly okay. And you've talked about connecting schools, and just jump into Vadim a bit, because I know that in your portfolio in WAVOS, you have from projects from agriculture to industrial services, and your technology is relatively a new technology. So definitely you have to have different challenges that maybe for the other industries are unknown. And so it would let us know a bit of those challenges that you are facing precisely with this innovation.
Oh, yeah, now it is. Apologies. So basically, first of all, we've been involved in HAPS development for quite some time. I think our earliest experiment with HAPS dates back to 2013. And we've been, I can even say, pioneers in reaching the stratosphere with the, let's say, heavier than air HAPS, with the solar power HAPS. Our first flight at 18.5 kilometers was back in 2017. So now we've advanced already to the second generation. When it comes to issues, I would say that the biggest issue as of today is actually regulatory issue. When it comes to testing your HAPS, it takes quite some effort to receive all of the necessary permits. So to whoever in this audience or related is involved in regulatory environment, my huge request would be to view HAPS as a separate category, to foster, to promote this industry, to allow HAPS-related flight permits and things like this to be issued faster. We have actually an additional complication with the fact that our HAPS is actually a non-standard aircraft. So unlike the vast majority, or maybe even all aircrafts of solar-powered, which have a rigid wing and quite resemble the traditional aircraft, UAVOS's HAPS has a flexible wing, which, for a number of reasons, it makes it lighter, it makes it more scalable, more maneuverable, and whatnot. But at the same time, it sort of takes it out from the category of traditional aircrafts, which many times the authorities, when they look at it, they are puzzled how exactly to classify this. Is it an airplane? Not quite. So anyways, with the new technologies in general, not only with our HAPS or with whatever else which flies out there in the sky, I think the only focus of the regulatory authorities should be on the safety of the operations, nothing else, not being stuck to a predefined cliche that it needs to be an airplane with solar power. But anyways, so this is the first challenge. The second challenge, it actually disappears with years. When we were trying our first versions of HAPS back in 2015 in already high altitude flights, the solar panels and the batteries had very limited capacity. This obviously affected not only us, but everybody, from Airbus to whichever other partners or competitors would be doing the HAPS. So our deep conviction is that, at least in our case, HAPS is already feasible, even with today's capacity of batteries and solar panels. But once this reaches a level of, let's say, 500 watt-hour per kilogram for the batteries, we would be absolutely relaxed in terms of the HAPS capacity to carry a much heavier payload and deploy very complex and energy-consuming missions. But this is going quite fast. So I would assume that in the next couple of years, we would be there. Probably these are the only challenges. That's it on my end. Thanks.
Well, it's very good at least to hear that there's only a couple of challenges then. And Motoi-san, maybe on this matter, one of the things that we have heard also, whether it is for LEO systems, it's also the possible challenge of affordability. How can we make this a sustainable business? Do you think that HAPS is different and it has more opportunities into making it as a sustainable model?
I don't have to compare between HAPS and LEO, something like that. What I mean by that is 3 years ago, I visited unconnected school and demonstrated HAPS in front of a lot of people in Africa. At night, headmaster of the school said to me that, Motoi, you are doing great, but do you know that a student in a rural area cannot read light language, especially English? Oh my God. They won't be able to use a Google search even with connectivity. That's why I have been struggling for 3 years to solve this issue. In the end, I successfully create a kind of ecosystem, bringing contents application and a device, sometimes need off-grid electricity deployment with connectivity. So that's why whether that HAPS or LEO is just a connectivity issue, right? But the issue is, for unserved area, is ecosystem, affordable ecosystem. Did I answer you?
Very much.
Yes.
I was just taking notes. And again, you mentioned the importance of connecting schools, and I like this idea, and I will bring now Mohanad back, because we all have lived the last few years with a pandemic, and we've realized in these years how precisely the connectivity for education is relevant for our own day-to-day. And this has also gave us a little bit of perspective when we discuss about new technologies and the 5Gs and the speed and the latencies and all these different terms, but it has also brought back the reality that there is unconnected people, there is this divide, and so I want to hear from you how to balance these two and how not to leave one of them behind by prioritizing the other.
Well, thank you, Natalie. The unfortunate experience of the pandemic itself, specifically the lockdowns that we have lived all together as one world, has really put a pressure on us, on this industry, to keep the whole citizens of the world connected and being able to communicate while they're locked down, and while they can also be able to reach to the essentials of their lives. Now, the pandemic has passed, but a new experience has come, where such an experience of such lockdown has become also part of a lifestyle. We're still wanting to be connected. We're still wanting to be communicating through the same approach and experience. That by itself has brought up an importance of how we want to be connecting every single customer, every single citizen of Saudi Arabia, and to be able to be connected. Looking at it, the non-terrestrial networks have really provided what is needed. The advancement now is becoming more important while we are addressing the digital divide and trying to afford how we can provide services to any customer within Saudi Arabia. So what we're trying to do over here and what we have achieved is providing a service that has the reachability, the high speed, the low latency, through an affordable and reliable connectivity. STC has been adapting to the technologies to offer such reach through the mobile satellite services, direct to the devices, and also through its engagement with the LEOs and other means of communication through the non-terrestrial networks. And soon we would be hearing more and more about the engagements and possibly the partnerships that STC would be having in such an area as well.
I like when we talk about partnerships, because I think that now more than ever we are becoming that ecosystem that we have already heard from some of the panelists. And bringing Jennifer back to the discussion, we talk about the digital divide, and satellite is not it's quite knowledgeable about the concept, but more and more we have heard in the 3GPP work and the integration of 5G, satellite in 5G, and the relevance that 5G, that satellite is having in these new technologies. But now we are not only talking about 5G, we are actually talking also about 6G. And so, Jennifer, how do you see the role of the satellite in 6G compared to the role of satellite in 5G, or how it is going to be different?
So thank you, Natalia, for the question. And I actually have a ball over there. If I can pick it up, I'd pretend I have my crystal ball and I could see. This is an area I've been giving a lot of thought about, which is, what do we do in 6G? And I think that's where satellite becomes even more important. And I think Mohammed said it best when he talked about satellite as a complement today. But I think satellite's going to become more of a core service as we move to a 6G world. And it also depends what 6G looks like, but we've heard it's going to be the internet of the senses. And if we're really going to be out there sensing things, that means you absolutely have to have everything covered. And that's where satellite plays an important role. And I think you're going to see broader use of the spectrum resource by satellite systems. Today, we have services. We're about to launch our Jupiter 3 satellite, which is a geostationary broadband satellite with very high speeds. We're using the V-band. That's really the first commercial satellite that's going to have the V-band as a major part of its network. But when we talk about 6G, I think we're going to see ourselves in the terahertz bands. And we're not just going to be talking about communication satellites. There's lots of other satellites, whether it's sensing satellites, Earth monitoring, and so forth. Those are going to become more important. And I think the standards process is going to be so important. We already know 3GPP is beginning its work on 6G. The ITU's had underway, I'd say, for at least 4 years, 2030, IMT 2030. I think satellite's lagging a little bit, unfortunately. We're just starting, we've just begun our work on IMT 2020 and the satellite component and really fleshing that out. So I'm hoping the satellite industry will get more involved. But I think what you're going to see is satellite everywhere, and I think even more transparently to people. As I think all the panelists have said, none of these communication services by themselves are really going to be enough. You're going to need this this ecosystem of services. And I think with the Internet of the Senses, it's going to even more so require what I call a three-dimensional outlook on spectrum. And I think the other piece we haven't talked about is space. I mean, we have people deploying a 5G system on the moon. We know others are looking to go to Mars and other planets, but you have, I think it's going to come up at the WRC this year, ISLs around the moon. So I think we really have to think more holistically. And I think it's a really exciting time for the satellite industry, as well as for the HAPS industry, of course. So thank you, Natalia.
Now, indeed, I think it's a very exciting time for satellite, for HAPS, for telecommunications in general. I think we are in a moment that we are all quite happy to be in. And because we have talked about some of the challenges and the regulatory challenges and the importance of investment, whether it is on terrestrial or on satellite or on HAPS. And Michal, maybe you being from head of the Slovak, how do you think the governments can precisely support or provide a framework of investment or a framework that will attract companies also to establish themselves or to participate or collaborate more with you?
Yeah, if it was a couple of years ago and I wanted to be short, I would just repeat investment, as you said, but no, it's not enough. Of course, investment is still an important base, and it will continue being so. In space sector, being a sector of strong involvement of the government, and the government being still very often the key customer and the key end of this whole value chain network, whether it's one state or whether it's an institutional player, like in case of Europe, it's the European Space Agency or the European Union. But now it's not enough. In 21st century space economy, with these new space features and growing commercialization, growing commercial customer base and growing markets and enlarging amount of markets, it's needed to be done much more also from the side of the government. And over the past 3 years, we've been actively contributing to exchanging knowledge and best practices among the emerging space ecosystems to support their growth and to also learn a lot new, either through our own platform, which is called Emerging Space, and also through various international fora, including United Nations COPUOS or International Astronautical Federation, where we are bringing this topic to contribute to this important discussion. And what we see that in many countries it repeats is 3 points. If I wanted to make it maybe simpler and shorter. So point number 1 is that basically each country has something unique to contribute to the global space activities and to global space ecosystem. It's just very key and important to, in the very early stage of the ecosystem development, to identify what the sources are, whether it is, let's say, the non-space technology industry base, whether it is academia with some scientific experience, or it is new young entrepreneurial community that is eager to create startups and be funded to go to some breakthrough new technology solutions. So it's important to identify and then to try to maximize the use and the utilization of this potential. Secondly, sometimes it's quite beneficial to use on the first sight, being new and small seems to be disadvantage, but sometimes it's quite good to try to use it in your advantage. New and small space ecosystems have sort of flexibility, so they're not anchored to large projects which are going on for years, so they can sometimes more easily jump to new technological trends, to new markets being created. And it's good to use this to the advantage of these new emerging ecosystems, to be creative and to be diversifying your markets and your investment sources, also taking a look at commercial space. And third, it's very important to try to be an interesting and valuable international partner. Now, this might sound very simple and quite clear for everybody, but being a newcomer to the dense market, one has to take extra step. One has to do a little bit more than the others to be able to get to the table, to get the seat at the table. And this means that these new emerging ecosystems and countries, for example, like Slovakia, we have to think what is interesting for the big players, what is interesting for the old players, new technological areas which are being now currently developed, and there is strong demand for them. And we have to target these areas to bring something new to the table. Thank you.
Thank you very much, Michal. And because you have repeated new and flexible, and it starts creating in my imagination all the things that WAVOS has and is doing, precisely like we see in the movies also, and we see all these ambulances and different possibilities that the UAVs provide. And so, Vadim, let me bring you back again to see all these that we can imagine happening. When do you think we are going to see it as normal day-to-day life?
So I would say that depending on what capabilities you are talking about, but some of these, are actually already enabled. We don't see them in day-to-day life because, unfortunately, again, mostly due to regulatory issues, we see these in the applications by government and defense-related entities. But, for example, from our hubs, we're already, in a number of cases, providing connectivity to a number of UAVs. At this moment, both are our own, both hubs and the UAVs are by UAVs, but definitely this will spread around. Now, in terms of mass adoption, that, again, heavily depends on the regulatory authorities. I would say that we would see the first real massive cases of application maybe 3 years down the road when it comes to enabling commercial, solid, not in test mode, but solid hubs-enabled connectivity. And who knows, maybe it will start in Africa out of all places.
And again, you mentioned how the regulatory environment is going to be key for the success of any project and any innovative technology. And we have a question from the audience that is questioning or is to any of you or all of you, which sector regulators are best equipped to lead equitable regulation and competition management in space? So should it be the telecom, the space, the media or device manufacturers? Who would they be? I don't know who wants to take the question, but I don't know, Vadim, if you want to follow up on that question already.
Honestly, it's a tough one for me. I would say that connectivity is probably one of the top ones. I mean, when it comes to regulations, there are regulations on two kinds, and there are two types of permits we're supposed to receive when you're doing hubs flights. So once is on actual aircraft itself being up in the air at certain altitudes and passing through certain locations, and the other is on the connectivity devices. And many times the regulations related to the actual connectivity and the spectrum and whatnot are on occasions even tougher than the rest of it. So
I don't know if Jennifer, I see you raising your hand.
So thanks, Natalia. I think that's a hard question and that there's not one entity that should do it. I certainly think the telecommunications regulators, when it comes to spectrum issues and licensing issues, are the right place. But when we get to things like Vadim was talking about, who's going to handle who's getting permits for safety in the sky, or things like space sustainability and so forth, I do think you want to go to the expert agency. So I don't think there could be one agency. I do want to applaud CST for changing their name to include space. I think that's a growing importance. We saw in my own country, the United States, just last week, the FCC is creating a space bureau. So I think it's really important that the regulators begin to treat this as a different service, just like they do today for wireless or for terrestrial fiber, more common carrier. But I think what we're seeing is an evolution. But I do think there's different expertise. And one of my concern is that if you don't have the proper expertise in that regulatory agency, I think it's better for industry and it's better for the governments. I can say this as a former government official, to have the expert agency work on those issues. Thank you.
I don't know if anyone else wants to follow up on these questions, but what I hear from all of you is precisely that the expertise is from different groups, and that the industry still has an important role to play. One of the things that I'm seeing, and maybe you can comment on that, but is even though it should be looked at it in different places, maybe it's avoiding creating silos so that the communication in between happens. I don't know if you maybe want to follow up on that, Mohanad.
No, I totally agree with that. It's all about how we communicate, how the authorities. Now, there are so many applications that we're talking about, so many technologies we're talking about. Jennifer mentioned how things are moving between even the fiber, between the satellite terrestrial and the non-terrestrial. There is the the Agency of Space. There is today we have also the CST in Saudi Arabia. The collaboration between all these policymakers is the one that will create the unified view of how things would be working. So I believe it's multiple entities that would be engaged, but I do see how a lead of one of them could be happening. Maybe at this stage could be the CST as we speak of the communication and the connectivity between the customers.
Please, Vadim.
I would actually wanted to add that basically I completely agree, but it also helps when there is like a major project such as NEOM, for example, is being launched, where the intent is to introduce all of the newest technologies and try them out to make sort of the entire space well connected, fully autonomous, green, zero carbon and whatnot. So this allows to to showcase essentially all of these newest initiatives, which would be very difficult to implement in existing cities and whatnot, to show what advantage all of these technologies would bring. And for these, I think entities like NEOM have introduced a lot of sort of exceptions to the traditional limitations, and they allow very, let's say, fast track to showcasing of new technologies. So that is a major, I think, major help to promote all of these initiatives. I think also in case of Africa, and probably SoftBank would know a lot more about this, the intent is similar in terms of the promotion of new technologies. Sorry.
Maybe Motoi-san, you want to complement what Vadim was saying?
I'm not expertise in regulatory things, but I agree on what Vadim said, that yes, working with a regulator, I mean, a top guy of aviation and spectrum are key for success, at least in Africa. I don't know the other area. Yeah, thank you.
And we have been talking about all the different disruptive technologies, and we have LEOs, and we have MEOs, and we have GEOs, and we have hubs, and we have labs, and we have terrestrials, and we have all these different technologies that are making us all dreamy and excited about the future. But is there a market for all that we can provide? Is there enough demand? Is there going to be, how is it going to look like in 5 years? Will we all be there? Are we all needed? Who wants to take the question? Please, Mohanad.
Yeah, I may start, if that's okay with everyone. It's all about the use cases, the business case that is built behind it, how we can efficiently utilize these resources and assets. And this is why I believe that myself, my colleagues over here at the panel, we've been talking about partnership. We've been talking about how we can complement each other, how we can utilize and create an ecosystem where things could be really beneficial for the returns and the increment of the investment to advance. On the technology side, it's more and more of how we can provide high-quality devices with also more of appealing, affordable prices by the end of the day for the end customers, be it the industry or be it even the individual customer. It's a little bit of a complex sometimes equation, but this is how you progress. This is how we challenge ourselves to advance towards the right, I would say, use cases and the returns, and how we can continue into such business. Thank you.
I would want to maybe add on this, in terms of use cases and the business cases. There is so much of new functionality that would be enabled that would allow services like fully autonomous delivery, both last mile and intercity. And all of these depend heavily on connectivity. All of these depend heavily on positioning, on data collection and whatnot. So the more services become available and, what's important, affordable, the more new services emerge that require these capacities. So I would say that once, again, things like autonomous delivery come into play, they will consume a lot of bandwidth, and we would use satellite, LEOs, hubs, and whatnot, whatever we can get our hands on.
Natalia, can I add just one thing?
Please, Jennifer, go first, and then Motoi-san.
Thank you. So I just wanted to just bring up the standards process. And I think cost is critical. And I think the move, traditionally satellite's been very proprietary based on its technology. And I think the fact that we work so hard as an industry to be included in the 3GPP standards, and we're ultimately included. And remember, 3GPP has always largely been a terrestrial body, really shows that we're going to be part of the ecosystem, and it's going to be on a more cost-effective basis, because all of a sudden you're going to have a choice of technology. So I go back to the cost, which I think Mohammed brought up at the beginning. I think that's a critical factor. But I think one of the game changers here is the fact that we now have satellite included in 3GPP, and that's going to develop further with release 18 and beyond. And on top of that, it's taken a while. We've been talking about LEO since the early 90s, but all of a sudden you have this new class. You've got much cheaper access to space than you ever did with competitor providers for launch. And so your cost structure has changed dramatically. And so I think that means there's more success. Does that mean every single person who wants to launch a satellite or HAP system is going to be successful? No, but it does mean there's going to be inclusion going forward, and I think greater and greater inclusion of these technologies. Thank you.
So in terms of NTN market itself, it's huge. In addition to Africa, Latin America, and Southeast Asia, there are lots of digital divide we should tackle. But important thing is consisting of two pillars. One is that variety of services from connectivity, contents application, devices, if necessary, electricity also be deployed. Another pillar is money. Since rural area, people cannot afford to pay the expensive SIM card, right? So right now, we are talking with satellite company to realize community Wi-Fi. Without SIM card, we are realizing connectivity. But connectivity itself is not enough. So variety of services is very important. Another is, again, money. So we are talking with Impact Investment Fund, and also grants donors. And also, as you may know, Fumio Kishida, who is the Prime Minister of Japan, pledged $30 billion for next 3 years to Africa in August at Tunis 8. As long as I know, my project is the biggest project to bring the money to Africa, so I will do my best. And then $13 billion is not enough to cover the entire digital divide. So European Union pledged more than 100 million, as long as my memory is correct. So, but time is more important than assets than money. So now we shake hands and put together and go forward. That's all my comment. Yeah, thank you.
Thank you very much. And indeed, time is of the essence, I think, for all of us and for all our projects. And our title, the title of our session was New Disruptive Connectivity Competition. And so just one or the other, I'm going to ask you a question just to finish because time is finishing. And it's, where does the disruption come from? From the competition or from the collaboration? So, Michal?
I would say it's a little bit of both. We need competition to force ourselves to be better and better every day with any technology sector, space included. And we have to collaborate because the sector itself it's incredibly comprehensive and complex. So what we have heard today during the panel and what we heard over the past 2 days, I would say it's definitely a combination of both.
Motoy?
Yes, day one, the moderator asks the panelists, what is the most important things? Most of them said collaboration. I agree. But collaboration with concrete activity, this is very important, with numerics and some deadline. It is not competition. This is what I mean. Thank you.
Vadim?
It starts with collaboration to produce new things, but then competition is essential to bring the price point down.
Good. Mohanad?
Well, all the nice words have been said already. So yes, it is about the complementation of both systems, of both technologies, and how they work together. Honestly, the disruption itself is the good thing, I see, is how we work together in two different technologies and all the technologies and how we combine them into the ecosystem. This is a positive disruption that I would like to see happening over here.
Jennifer, the last one to answer the question.
So I agree with my colleagues, and I would just point to the example that today, I think if you had asked 5 years ago any of the wireless MNOs, are they going to have satellite in their network to the extent they're planning, I think they would say no. And I'm pretty sure that all the MNOs today are looking at a way to include satellite, whether it's direct to device or a backhaul or others. So I think that's just a good example of the disruption, and the collaboration and the competition. Thank you.
Well, for me, it's clear, and I thought it was going to be more just on the collaboration side, but I'm very excited that there's also that competition, because I think, as you're saying, all of you have said, you need that to advance, you need that to continue innovating, and I see that the future looks at a very integrated world of solutions. Now time has finished for us, but this has been a super nice panel, super interesting, and I wish that everyone can join me in thanking my panel and my speakers. Thank you very much.
So to echo Natalia's words there, excellent panel, and thank you to all of the panelists, and Natalia, thank you to you. Excellent job, well done. So that's another break. So we have 20 minutes now, and then we're going to be back in here at 5:40. Make sure you are back, because we have another thoughtful discussion going to be taking place then, looking at the road to 6G through the sky. We then have a live demonstration. So we've seen a lot of demonstrations on videos. We actually have a live demonstration that we're going to be running here, where we're going to have Alteros and World Mobile launch an aerostat in, I think, somewhere on the east coast of America. So make sure you're back here for that. And then we're finishing off with 2 more keynote presentations from Smart Africa Alliance and SpaceX. So again, make sure you're back for that. But for now, enjoy the coffee. We'll see you back here in 20 minutes or so. Thank you. So welcome back, everyone. And again, I hope everyone has managed to grab a coffee to keep yourself caffeinated. So we're all back here and lively, ready for the last sessions of today. So just to let you know again what's coming up after this session we have now. We have a live technology demonstration that we're going to be seeing soon. So as I said, we've seen a few demonstrations and videos of some fantastic technology demonstrations, some fantastic technologies being shown. We actually have a live demonstration which we're going to be showing. That's coming up in about an hour or so. And then we're finishing off today with 2 keynote presentations from Smart Africa Alliance and SpaceX. And then finally, we're going to invite everybody to join us for continuing some networking and some conversations at our reception, which is happening up in the mezzanine right at the end of the day. But before all that, we're delighted to have another thoughtful discussion. So this one is going to be focusing on the road to 6G through the sky. And again, we have a fantastic lineup of speakers with us. So to introduce them, I would like to now pass over to our moderator, Professor Giovanni Giambene from the University of Siena. Giovanni, welcome. Over to you.
So, good afternoon, everybody. I'm very happy to be here. I am Giovanni Giambene from the University of Siena, and I have to be grateful to IEEE Future Network Initiative if I am cooperating with this, connecting the world from the skies. So today we have a good panel with Professor Shan-Min Shea, Professor Martin Weiss, Professor Muriel Medard, Dr. Stefano Cioni, and Professor Michele Zorzi. The last two participants will be from remote. The topic today is about the road to 6G through the skies. I would like to give you a very brief 5-minute introduction of the discussion. Maybe it's a little bit, repeat a little bit. But satellite system will be complementary, providing services and covering use cases that terrestrial system cannot cover. And so there is room for satellite in the 6G world. Satellite system have a unique capability like multicast and capability to reach everywhere in the world and provide reliable and robust communications. Today, satellites have also a new, very increasing importance also to manage IoT and machine-to-machine because there are many areas where they can do this. And 3GPP has made recently a great progress with the satellite 5G and 6G in terms of non-terrestrial network, including a hybrid system with GEO, Mega LEO, high-altitude platform, and unmanned aerial vehicles, and everything to be empowered with artificial intelligence that will play a great role in 6G. So let me go fast. Probably it's very clear that the system will have a multi-layer architecture, and all these components, so UAVs, hubs, LEO, MEO, and GEO will be integrated in one unique system, and they will have a different and complementary role. In our activity, of course, in this satellite roadmap activity, we worked trying to investigate the driver and possible application for future non-terrestrial network in 6G, considering that still are about 3 million of people are not yet covered by internet, and considering healthcare, autonomous car, manufacturing, agriculture, education, and smart infrastructure. So all the fields that have important, for which we consider non-terrestrial system have an important role. So not only broadband connectivity, but also machine-to-machine, massive machine-to-machine communications, and we consider also a role for ultra-reliable low latency that are very robust, but needs very stringent latency requirements that are possible with hubs and UAVs. So let me go quickly to the point. In this work, we addressed the mega constellation architecture, the role of millimeter wave, and we will discuss also today about this. Architecture combining hubs and UAVs, And also, we are considering security scheme to integrate a satellite with the 5G, 6G infrastructure. As you see, the KPIs of 6G will be tremendously strong in terms of data rate, density of users, and speed and jitter requirements. So it is a quite important effort and a challenge for us to do our best with the next generation. And this is the reality. So there are many satellite systems and LEO mega system already in place. We can consider for sure Starlink that is progressing very well, completing the deployment of the first generation satellite in their orbit. But also OneWeb, we saw a grateful presentation that is also having a good number of satellites and providing services. We can also consider O3B that has the peculiarity of using MEO satellites and the possibility also to exploit GEO with some form of integration by SES. Sorry that I cannot go through all of this. Let me just conclude with a few numbers from this slide. First of all, from Ericsson, that has done a very great job doing analyzing the future needs. We can see that mobile data traffic will be increasing in all the region. And this is a quite demanding needs for the future 5 years. Current data that are shown on the table, sorry, there are only numbers, but I can summarize the message that already a LEO system that is Starlink with a not complete deployment coverage is providing a capacity that is quite approaching the capacity of terrestrial mobile and similar latency. So we believe that there is room for non-terrestrial system to do their job complementary and unified with the terrestrial one, considering especially their unique advantages when there is the need to cover large distances. So I think this concludes my introduction. We will discuss many topics, how to connect the unconnected, the challenges of hybrid system, standardization, millimeter waves, CubeSat, and I'm very happy to have a rich panel to give them the floor for their short introduction. Thank you so much.
Hi, my name is John Sui. I'm a director of Khalifa University Space Technology and Innovation Center. So as you can see that I'm going to go through some of the relevant activities regarding the 6Gs and providing space solutions for communications and data analytics. This is just a brief overview of who we are, Khalifa University Space Technology Innovation Center. We are pretty young. We launched June 2020. And this center has been supported by 3 entities, Khalifa University, UAE Space Agency, and YASA Communication Company. So it was very nice kind of integration from the academia, government entity, and also industry. So we do have a very vital of our center is YASA Space Lab. As you can see that the YASA Space Lab is honestly funded. All the equipment was actually provided by YASA Communication Company. And it was being identified as a center of excellence in terms of designing and the AIT, the testing, assembly, integration, and assembly of the satellites. So since 2016, we have up to this point we have launched 4 satellites. So as you can see, all the way from 1U, 2U, 3U, and etc. And the latest one, which is about to decommission, is a Light 1. I think as of end of this month, it will be decommissioning it because it has as you can see, has a solar panel, so the life cycle is shorter. You can see that there are, since the first satellite, we have a very clear science objective. Be it battery technology and to do camera and then do remote sensing and data analytics, etc. And also coming up with our internal in-house built technology. I think the whole goal of our development, research development effort is at the end of the day, we're trying to have developed technological self-reliance. So the next 3 slides, I'm going to just share with you some of the research activities and also capabilities. This doesn't mean that they're summarizing all that we do. We have a lot more going on in terms of space, particularly on the lunar in situ resource utilization aspect, and also Mars mission coming with the space robotics, space rover, etc. So these are just simple, just to list out some of the relevant for the satellite and satellite-related activities. And particularly, these are the kind of technology that was all built in-house. And some are more mature than the other. Honestly, for example, we have already developed this advanced EPS system, already patented, prototyped it. We are actually looking for opportunity to actually flight test it in LEO. We have a next generation space antenna system, something that we are going to be hugely pushing as part of the SAS project, synthetic aperture radar project. UAE Space Agency, over the summer, I think July timeframe, about 4 months ago, has announced very ambitious national project, which is a third project, which is a constellation project. And that is exactly something that we would like to leverage and then, build up continually upon the level of competence that we already have handling small form factor satellites. So we also have very extensive in-house capability in terms of mission design. We do our own trajectory design. Honestly, we can go beyond, LEO. Dr. Lainena Fantino, who is the expertise in mission design development, that emphasis also on, beyond LEO and go to Mars and then different planetary. We have also prototyped the dosimetry, which is sensing the radiation. So as you know that, we really like to integrate this dosimetry sensor to provide additional the kind of a health information about the satellites. Right now we have a temperature and etc. But this will actually give us additional dimensions about the health of the satellite and also the environment. This is a very interesting project, and honestly, we are continuing building up. We just filed a patent on this one. It's a plasma-based microelectric propulsion system because everything that we are doing, honestly, is focusing on the first question we ask is whether this is going to be able to fit in, small satellites, okay, namely CubeSat-based. So this micro propulsion system that we developed, that we have a prototype, has a bidirectional, meaning that you can actually thrust in both ways, okay? And we have another idea that can thrust all 6 directions. So it can be in potentially in the future can be used as attitude control system. I think I will actually summarize this. I mean, as I said, this does not conclude, our entirety of our research activities, but relevant to developing advanced satellite technology and relevant for sustainable space accessible to the space, especially LEO. But I think some of the debris removal activity is something that we're also doing. But nonetheless, we can talk more. I think I'm done. Thank you very much.
Yeah, thank you, Professor Sway. Then we hand over to Professor Martin Weiss, University of Pittsburgh, that will give a short introduction.
Hello, everybody. Thank you for inviting me to attend this. Whoops, got ahead of myself. So this has been a really interesting panel. The whole couple of days have been extremely interesting for me. I've heard a lot of different conversations about regulation, about cooperation, and as some of you may know, some of the things that I've been interested in lately has been governance. And governance isn't necessarily government regulation, it's how people get together to control a resource that they share. So I've been thinking now about how does this apply to these NTN systems as we look forward. And so I just kind of want to provide a little bit of perspective and suggest some research questions with that. So first of all, from a starting point, I kind of want to, we talk about spectrum use, and again, spectrum is mostly the thing that I care about, but I think a lot of the issues that we think about also apply to orbital slots and as we think about HAPS and coordinating different HAPS platforms in space, we have similar kinds of problems. So even though I'm mostly talking about spectrum, it could apply to a lot of different topics. Anyway, supply and demand in spectrum is very uneven in almost every dimension, in time and in space and in frequency. And I think one of the challenges that we face is how do we build systems that help us manage these resources with this heterogeneity. One of the, again, it's a bit of an overstatement, but the fact that we have this kind of heterogeneity means that most spectrum problems are local. And when I look around, especially in the United States, and I won't necessarily say this is true everywhere in the world, that we have local problems and we try to come up with global solutions to local problems. And that seems to me to be backwards, right? I mean, I think we should have local solutions that we learn from globally, that drift up more globally. And this allows us then to reflect different kinds of priorities and challenges in particular localities. I think about the HAPS platforms, for instance, serving the underserved. You have a particular kind of a communications environment that's very different from what you have in a central city, and so it requires different sorts of technologies and different sorts of economic arrangements. And I think one of the things, just again, broadly speaking, that has changed, and this is was reflected in Professor Giambini's slides too. We've had these massive advances in data processing that allow us to have different kinds of techniques, some based on database kinds of coordinations, the way we're experimenting with fairly heavily in the CBRS band in the United States, but also using this massive processing power and machine learning algorithms to do a much better job of providing services that are tailored to localities and local priorities. And just when I think about this, and I stole this slide shamelessly from Professor Cioni with his permission, and the thing that was interesting to me about this, and there's a laser here, so yes, each one of these platforms has a different kind of a footprint, and the fact that they have a different kind of a footprint means that the way in which you have to organize the management of this is different for each one of these platforms. So, when Jennifer Manor, for instance, in the previous talk was talking about this integrated approach, I think the integrated approach is important, but I think we have to be careful about having leaning towards a single approach for everything. We need lots of approaches that work together that help us solve some of these local problems. This, by the way, applies to space debris too. I know we're going to hear a lot more about that tomorrow. So when we talk about governance, it's really about the collective approach to managing shared resources. And we can do this in a number of different ways. There's been, especially in the spectrum world, we've spent a lot of time defining rights that can be sold. I mean, many of you have been involved in spectrum auctions, or you hear spectrum auctions, and in those cases we can define these rights fairly clearly so that they become tradable, and that's an approach to governance. But it sometimes doesn't work. Sometimes it's not the best approach. Sometimes defining these kinds of rights is really costly. So we had a paper at the last Telecom Policy Research Conference that some of you may have read about satellite rights in response to the FCC's Notice of Proposed Rulemaking from about a year ago. And one of the things in our discussions in developing this paper was, so how do could you define rights that LEO satellites could trade amongst each other? And as we were kicking this idea around, it became pretty clear that it's very costly to define these rights, partly because these satellites move very quickly in various orbits, and they are international. They're not national, so it's not necessarily sensible to do this. And so we have to have different kinds of governance structures to manage. I mean, in the case of this Notice of Proposed Rulemaking, it was the uplink and the downlink spectrum, the KU band and spectrum that they use. So anyway, so we have to come up with other mechanisms. The FCC, as their default mechanism, says, well, just divide it amongst yourselves, and that's not necessarily a feasible approach. Sometimes government solutions are good solutions, sometimes they're not. Sometimes, I mean, there's a famous paper from Friedrich Hayek from 1945 that argues that many times these centralized approaches lack adequate information to make these kinds of on-the-ground, hyper-local decisions that have to be made quickly. And so the governance, when we talk about it, the benefit for doing it locally is that you can be responsive to conditions that are present at the moment. So there are lots of research questions. I threw a few up on the ground on the screen here, and some of it has to do with what kinds of mechanisms are there? What approaches are there for this? There is actually a fairly large literature on the governance of shared resources. If anybody is interested in learning more about it, please reach out. But crucially, the choices that we make technologically today may affect the degrees of freedom we have for governance in the future. There's a quote I was going to use for this. I spent a little bit of time looking it up. It's often attributed to the famous philosopher Yogi Berra. This is a joke for people who have some experience in the United States. It's actually, in looking it up, Yogi Berra was a catcher for the New York Yankees, so he wasn't actually a philosopher. The quote was misattributed to him. It actually goes to Niels Bohr, but he says, prediction is hard, especially about the future. And so maintaining degrees of freedom is critically important. And how does this play in with government? What's a good relationship between private sector and government institutions? And so these are really just meant to be food for thought. I have more questions than I have answers, but this is what a discussion like this is for. Thank you very much.
Thank you, Professor Martin Weiss, for your presentation. So now we have Professor Muriel Bedard, NEC Professor of Software Science Engineering, Massachusetts Institute of Technology, from remote. Thank you. Yeah, the floor is yours.
Thank you very much. Thank you to the organizers for inviting me. This is really a pleasure, and I'm sorry I'm not able to join you in person. It sounds like a wonderful meeting with lots of great meetings with colleagues. We've heard a lot about standards. We've heard a lot about connecting people. We've heard a lot about ultra reliable communications. And I wanted to bring a few of these topics together with some of the technological advances that can make this possible. So really what I want to talk about today is how do we design standards in a way that will enable innovation to achieve these desiderata of reliability, low delay, security, which we also heard about in the presentation at the start of this session, and of course, flexibility. And when we talk about satellite systems, what's very clear to all of us, and it's become even more clear through this event, is that satellite systems are becoming a really crucial element of a very complex, rich, and highly heterogeneous architecture, ranging from Wi-Fi to different terrestrial systems, 4G, 5G, in the future 6G, IoT, so terrestrial systems, which are very, very different maybe from the ones that were generally connected to satellite system. And the idea is that standards should be allowing all of these different elements to work together, but they cannot do so in a way that's highly orchestrated because there's simply no way to remain stateful in such a complex, time-varying, and often only partially known type of setting. So this role for standards, what I believe, and I am being involved in standards bodies, is to allow variety whenever possible, to sort of embrace this heterogeneity and to do those standards in a way which allows APIs, so to move away from prescribing specific solutions and rather enabling correct connection between these different modules so that innovation can happen. And let me give you a couple of examples of this type of innovation to achieve this reliability, low delay, security, etc. So one of the main technologies I have been working on for much of my career is randomly network coding. You can see the picture here. The idea is that you randomly combine algebraically the data. And to give you some idea, what you see there at the bottom are actual traces. This is from an island in the Pacific, Rarotonga, which is one of the hard-to-connect, underserved communities that we've been talking about in this session and in other sessions throughout this event. And you can see here traces of packet losses. Those are the little black crosses. And the connectivity with normal TCP as measured versus the connectivity with TCP with network coding using RLNC. And you can see that there are really days when connectivity would have been, in effect, almost useless in the absence of network coding. So the idea here is to not just add more resources, more spectrum, but to make best use of the spectrum so that you have days where basically you can have good puts around 10 megabits per second rather than having them around 2 megabits per second. And that's really the kinds of gains you get here. I just want to give a shout out to my colleague and friend Ulrich Spiedel, who's really led this for several years, his working with our software. His team just won the Information Society Innovation Fund Asia Pacific Prize for connecting the unconnected. So very much along the theme of this event. Okay, and then what happens in these sorts of systems? Well, what you see there on the right is just a picture to show you the gains that you get in throughput. We are the blue plane, and in delay, two different measures of delay on the middle and the right-hand side. Again, we're the blue plane, so much higher throughput, much, much lower delay. Again, the types of advantages that right now systems, because they tend to be prescribed and not flexible, systems need to actually use a lot more bandwidth to achieve this lower delay. We basically replace good engineering with a lot of bandwidth, which is not cost effective. And to how we can do this in these very complicated meshed heterogeneous systems. I just want to make a note about security. Of course, security is very important and it has become even more important as quantum computing has become now a real possibility. And, you know, the search for post-quantum secure systems is, of course, ongoing. And we can see what's happening, for instance, in the United States with NIST. One of the things that you can do actually with network coding is obtain very low-cost post-quantum security. Usually post-quantum security costs a lot, both in terms of bandwidth and complexity. We can obtain very low-cost post-quantum security by actually involving a secure link in the sky, basically using the network in the sky to secure the terrestrial network. And we have some work which show that you can do this, again, in a very low latency, highly reliable way. So I think that there's real space here for incorporating network coding into these systems. We've seen already how it on a nonprofit basis it has connected the unconnected, but it can also secure the unsecured and bring low latency to systems that really need it. I want to move into a second part of, again, this theme of how we can do standardization to enable new technologies to come in. And satellites have often been really at the forefront of adopting new FEC or forward error correction schemes, often because they have the most stringent needs. They have really very difficult problems in terms of link budgets, and so they tend to be really at the bleeding edge of FECs. So forward error correction codes have been around since the 50s with a lot of different modifications, also for forward erasure coding. I've just talked about network codes. And, you know, if you have been following the 5G, which of course is very important now, again, in the combination of terrestrial with satellite networks, you'll know that there was a very contentious discussion about what kind of codes to have. And for the data channel, LDPCs, which have been around since the 60s, they were the PhD thesis of my doctoral advisor, Bob Gallagher, and then CRC polar codes based on polar codes developed by another student of Bob Gallagher, Erdal Arakan. Those were really chosen as the codes for data transmission and channel control transmission, respectively. And the reason why there was such contention and so much discussion is that currently we have a system where there is a co-design of encoders and decoders. So we have a mass of different hardware, which is specialized for different codes, different chips, sometimes even different rates of the same family of codes will come along. And requiring a new chip. So it's a very complicated, very onerous system. And for satellites is really very, very deleterious. Why? Because we have very long cycles in satellites, and therefore you end up stuck. In effect, even though satellites, as I've said, are often at the forefront of error correction coding, you end up stuck with specific hardware which is not able to adopt new codes as coding evolves in different areas of technology. So in this respect, we have recently, with my collaborator, co-inventor Ken Duffy from the Hamilton Institute in Ireland, designed an algorithm which we call GRAND, which stands for Guessing Random Additive Noise Decoding. And we have created a chip. You see the chip picture there with our colleague at Boston University, Professor Rabia Zizicic. And it's able to decode all codes. So it means that rather than being with moderate redundancy, rather than being stuck with specific codes like Reed-Muller, CRC-aided polar codes that I mentioned before, Reed-Solomon, which only exist generally at certain rates, certain lengths, we can actually look at any rate any length as long as the redundancy is moderate. And we can use codes such as CRCs, which are very heavily used, as this crowd knows, in satellites for error detection. We can use them for error correction. We can use codes that were not decodable up until now, such as random linear codes, which are quite decodable on the erasure correction, as I mentioned before, but had heretofore not been decodable on the error correction. And basically, we can consider now that to sort of, again, not standardize things which don't need to be standardized, but instead just consider having APIs. And with that, I want to leave time for discussion. So I'll cede the floor and look forward to having more conversations.
Thank you, Professor. Thank you, Professor Medard, for your nice introduction. Now we move to Dr. Choni from the European Space Agency, the Netherlands.
Thank you very much, Giovanni, for the kind introduction. Ladies and gentlemen, good evening. First of all, let me thank the local host, CSCT, and all the excellencies from the Kingdom of Saudi Arabia for this outstanding conference and for the very kind hospitality. It's my first time here in Saudi Arabia. I hope it's not the last. And said that, I would like to present, let's say, our view, let's say, in terms of 6G roadmap. I think that in the last couple of days from all the speakers, we have heard that NTN, satellite, and in general, satellite industry and the satellite community is experiencing for the first time a unique opportunity to play a role in the global connectivity. And actually, I have to say that the motto of this conference, connecting the world from the sky, is perfect. And this is a very nice endorser for all the satellite stakeholders at the industry level and the investors. As I was saying, today the opportunity for NTN is really to bridging the world. And from a different perspective, I would like to show you how evolved the approach of the satellite industry to global standard. And I'm happy to echo some of the keywords that were said this morning by the chairman of GSOA. So I think that we all agree that before 5G, satellite and terrestrial standards were following two completely independent paths. They were somehow segregated. We have the approach in 3GPP or in general for a global standard worldwide, while for the satellite system were mainly based on proprietary solution. Anyhow, before 5G, as I said, in 3G or 4G, we have solution as called interworking capability or interworking feature to make, let's say, available 3G or 4G technology in underserved area. But this, let me say that is somehow is come at a cost because the two networks were not designed to work together. And I think one of the key elements, as was said many times during this day, is of course to reduce the cost and to enlarge affordability of satellite communication. Then, thanks to the principle of 5G to be a network of networks, satellite, and actually lately, just a couple of months ago in June with the release 17, is now fully endorsed and blessed by the 3GPP community, so from the largest community of terrestrial mobile standard, to be part of the 5G ecosystem. And this is a very important step, but anyhow, if we want to be somehow a bit also realistic, we have also to admit that NTN is part of 5G, but is arrived a bit late when 5G was defined. And so NTN, let's say, is a building block on top of the old feature that 5G is enabling, with the, let's say, aiming to have a minimum impact on the already deployed 5G network already in the world. So with now this full vision that NTN is part of a global standard of the 3GPP family, the aim is looking at 6G as the really first opportunity to design since the beginning a waveform or a general network, as it's called in 6G, this sensing network, or the worldwide unified network in the world, to be able to seamlessly working in space or in ground or both with multi-connectivity approach in a way that the satellite from the day zero, from the first day actually, is already part of this global network. So moving to this concept of a fully integrated 6G network, what I really like looking at this picture, that behind all these links, all these elements, in space, on ground, connection, apps, and intelligence in all places in this network, what I like is that the principle behind is one principle that we at ESA, at European Space Agency, we care the most, that is innovation. Innovation in space. If you look at this picture, you can really notice that going in this direction of a really unified network with intelligence in all elements you see in these pictures means that for the satellite industry, for all the investors in the space technology, there is a very big opportunity to create more and more excellence in this domain, to allow this, let's say, very wide network with multi-layer, multi-orbit, and multi-band concepts that are the keyword, they are the basis of this 6G network. So just concluding my initial introduction of some element of 6G, I have just reported some of them, of course, not all, some of the keywords related to 6G that could have a very strong impact also on the space segment, and as I said, all the space technology that is involved. So we said many times that 6G, one of the elements, the key element of a 6G network will be based on artificial intelligence or machine learning techniques. So this means that going beyond release 17 means that we have to move intelligence also in space, not only in ground. This means moving to regenerative payload, moving on onboard computing or onboard edge computing, in order to have all the, if you remember the previous picture, to have an equal distribution and a fair distribution of intelligence among all the layers of the network. Then, as I said, 6G has this opportunity to start from the day zero to be a standard for both satellite and terrestrial system. So the new waveform is there will be a new waveform design and optimization process, as we know, is typically the basis of all new G in global communication. From the first day, this waveform, should be looked at to be optimal and designed for both terrestrial and satellite link. And these are some example of, let's say, new techniques that have been popping up in the last couple of years. Non-orthogonal access that was already part of an initial brainstorming in 5G, but then was abandoned. Or this new waveform, orthogonal time frequency space, that is looking at like FFT in 2 dimension, also in the Doppler domain. And last but not least, also this morning there was some speech about this new concept related to reflecting, or for satellite probably is much better talking about refracting intelligent surface that could allow satellite links also to have indoor coverage, or in general to increase or to augment the capability of the satellite link. Said that, I thank you all, and I'm waiting for the discussion in the panel. Thank you very much.
Thank you very much, Dr. Cioni, for your interesting introduction. Now we move to the last speaker, that is Professor Michele Zorzi, University of Padua, Italy, that is connected from remote. I don't know if... Okay. We need to fix the audio. We need to fix the audio.
Is it fixed now?
Okay.
Yeah, can you hear me?
Clear. Yes, we can hear you loud and clear, so please...
you can hear, okay.
Thank you.
All right, so thank you, Giovanni, and thanks for the invitation. Sorry for not being there, even though a member of my group, Marco, is actually there, representing us at this very interesting event. So I want to speak about our networking issues in NTN. We are a networking group, and I thought I would mention a few interesting technical issues that need to be addressed for this NTN concept to become real. First of all, NTN is not satellite communications, right? So there are two key differences. Non-terrestrial means not only satellites, but in addition to the satellite layer, or I should say satellite layers, there is a lot in between that can happen. And we heard, Giovanni mention the HAPS, the AUVs, drones, things that can be in between and give richness and heterogeneity to this system. And then the last N, so this is not just communication, this is not a single link or a broadcast system as in the old days of satellites, but this is a network, truly a network with all the opportunities and complexity that networking brings to the plate. And so we need to address issues such as architecture, such as protocols, such as what are the KPIs from the network and networking issues that are very rich and sometimes very complex. So this is why makes this a very exciting area and revives a little bit this field of satellite communications, which has been around for many years. So Marco actually put together this chart where you recognize many keywords, I think. In red are the two main keywords I'd like to mention in this talk, millimeter wave and multi-layered, not because they are the only ones, but because these are the closest to what we have been doing recently in terms of research in this area. And I think they raise a number of interesting issues that could be discussed. Now, millimeter wave has been a centerpiece of 5G for terrestrial communications. So it's been success in terms of research and development, and now we'll see how the rollout will actually play out in the real world. But definitely, the use of millimeter waves for the abundance of spectrum that can be found in this frequency range is very appealing, and this is likely to be there for the near future of 5G and also 6G. Of course, with its opportunities in terms of increased spectrum, millimeter waves come with a number of challenges related to propagation because of the severe path loss, the impact of blockage, the impact of mobility. And so these are issues that need to be addressed in terrestrial communications, definitely, but also in satellite or non-terrestrial space, because there may be blockage from trees, for example, or severe path loss due to the potentially large distances we have to deal with in this type of context. So the research question we asked ourselves, well, first of all, you need to observe that millimeter waves have been used for many years in satellites, in the satellite domain, but not in the way we're talking about now, because now we talk about mobile networks, we're talking about communication directly to the user terminal. And so this is not the scenario where we have an Earth station with a huge antenna that can compensate for the path loss over long distances. And so we need to ask ourselves, can we actually close the link for these systems? Can we deal with the severe path loss inherent for millimeter waves over those long distances? And so you need to go through some link budget exercises, taking into account different models that are different from those used in terrestrial networks, and see if the potential performance you can achieve over those links is sufficient to serve the needs of these new generation of communication services. A second research question, which has to do also with regulatory issues, is if we use these millimeter waves for providing these mobile communication services, we know that in the satellite domain, these frequencies are often used for other services that cannot be displaced. And so the question of coexistence of these new services with the incumbent services needs to be addressed. Of course, if you separate the frequencies, there's no problem, but we'd like to be able to be smarter than that. And so make different services coexist by managing interference, by using smart beamforming or smart techniques to deal with that issue. And this is an interesting question and also a complicated issue to be addressed, which needs further study. And so the spectrum license or spectrum coexistence is another challenge there. Now, a second technical issue that comes with this concept of non-terrestrial networks has to do with the multi-layered architecture that is inherent in the fact that these different flying objects live at different altitudes, and so they provide naturally a layered structure where different distances and different attenuation patterns for the different layers can be synergistically used to come up with the optimal solution for the many different services you can think of. And so you can flexibly play around with these different tools or different elements of your architecture to and combine them to make the most out of this. Now, this element has been mentioned already, and they have their pros and cons, some of which are quite obvious in terms of, for example, distance from the Earth. Others are maybe less obvious. And one question that we asked ourselves is the following. Given that we have these different elements that have different features and different capabilities and live at different altitudes, how can we combine them in a way which maximizes the performance? So, for example, in this picture, you can see to the left, the baseline is a geostationary satellite sending directly a signal to the Earth, but we can break this link into a multi-hop link by introducing intermediate elements, intermediate nodes, and we ask ourselves, what is the best way to do that? And once we do that, and we have a multi-hop system, then we're no longer talking about a single link where we measure SNI, SNR, or bit error rate. We need to go to networking metrics in a multi-hop fashion, so end-to-end performance need to be examined, and especially if you have a more meshed structure. So here is just a multi-hop link, but obviously you can extend this vision to something where you have multiple objects per layer, and so you have a full mesh network, which is of course much more flexible and powerful, but at the same time it's much more complex to manage. And so just to give you an example of the type of results we can obtain to answer these research questions, this is table with the 3GPP parameters for these systems.
Professor Zorzi, sorry to interrupt you, because the panel is expected to last 5 more minutes. Then I think I'm so sorry, but we need to summarize a little bit. Sorry for you're the last and you take the consequence. Thank you.
So I take the blame for
to give
everyone else.
time for question. Thank you. Time is.
Yeah, okay, I can skip the results if you think that's appropriate. That's fine. The issues I wanted to raise, I mentioned.
Sorry for, we have a few minutes remaining. So I'm very, we received also some good question from the participant. So we have one question from Professor Martin Weiss. So here we saw the satellite, there are many satellite systems and they are going cross-border. How can be coexisting global regulation and the local regulation? How can make them consistent and system work?
Yeah, well, I mean, none of us can make anything happen across borders, right? Across borders, it's really just, it's a matter of bilateral agreement, and bilateral agreement by itself is a governance outcome in this broader context. But, you know, it does, for satellite systems, it raises the role of international organizations like the ITU who can help serve as a platform for this, or even regional organizations within, you know, for example, the European Union or the Arab League, other kinds of places. They can serve as places where this kind of coordination can take place.
Thank you so much for your answer. Then we go quickly. I have one question for Professor Zway that is has introduced the activity of his group. I saw a CubeSat, and I think they have a big role. So can you tell us the challenges for CubeSat to be part of NTN?
Yeah, I think I can absolutely share with you some of our concerns about the CubeSat technology development. I think the key point, we are actually come to a crossroad that we need to rethink about how to develop small form factor satellites. We did some studies. I think that. About 40% of the small CubeSats are uncontrollable. So meaning that very soon, once they are in orbit, they become debris. Okay, and then we have no way of deorbiting them. Okay, so they're gonna stay there for, I don't know, for a few years, if not 10 years. So this is raising a huge concern as far as we're concerned, because we thought that the LEO would be an excellent platform for us, serve as a springboard to mature our technology and then go beyond. The CubeSat technology, I think, there are a couple of ways that we are currently working on. Is number one, that's why one of the micro propulsion system that we're developing is exactly that. In the future, we're hoping that all small satellites should actually have a capability of deorbiting. Okay, if it's not something wrong, then you can, by default, you can deorbit them. And the other, I think, from the material point of view, we need to also rethink about the way that we actually building satellites. So I do know there are some effort to develop, to build a CubeSat using wood, the CubeSat satellite made of wood, so that when they are actually returned, they actually, dissolve completely. Because as you might know, some of the material, when they return, when they burn through the reentry, they burn, but they have a toxic remnant. And then they can come back to us on Earth. So these are the technology challenges, in my opinion, to make it as more sustainable. Yeah, thank you.
Thank you so much. So now, very quick question. I hope we have still a couple of minutes. So we have a question for the ESA, the European Space Agency representative, Dr. Choni. What will be next with the new TGPP releases 18, 19 coming?
Thank you very much, Giovanni. Yeah, so from the standard point of view, let me say in a, let's say, provocative way, Release 17 is already there, is approved, is frozen, and has been done in June 2022, so a couple of months ago. Now the process is going on, and release 18 is already in the process to be finalized, and NTN is still part and is in the mainstream of the 3GPP definition, and NTN is evolving with new feature in release 18. Let me just remind, for instance, that from the broadband point of view, above 10 gigahertz spectrum will be introduced and specified by the RAM 4, so from the RF specification and performance point of view. So we are expecting to add on top of the already endorsed L and S band, so for in frequency range 1, new spectrum in a millimeter wave. And we have from the IoT, for instance, the introduction of the new feature called store and forward in order to allow IoT constellations that are not fully deployed to be even operational with lower number of satellites. And then the streamline is going on with release 19, and as I mentioned, some of the keyword, release 19 is already somehow preparing the path for regenerative payload. We are expecting to have more intelligence on board, and other feature like also to improve the coverage enhancement or the overall power saving or cost efficiency of the satellite link. So let's say in a very few words, this is some of the already planned path in 3GPP. Thank you.
Thanks a lot for your interesting topic. Then I have, I think, a very quick question for Professor Medard. So I would like to ask you to which extent non-terrestrial system could help to cover the digital divide and to cover the non-covered people?
Yes, thank you for that great question. I think that there's a huge amount of promise there. I showed you an example of some of the recent work that we've done with underserved communities in Pacific Islands. It's of course not just islands, but there's a huge amount of the world that has a sparse, difficult to connect population, possibly not even population that stays in one place. So I think that there's a huge amount of potential there, but we need to make the most use of our spectrum and use the best possible engineering to make that possible. I really appreciated the discussion previously about having in the previous panel where there was a discussion about having people who could not have a SIM card and instead were having connectivity with satellites but without the use of a SIM card. That's actually what you can have in some of these islands where people are just connecting to Wi-Fi, but the Wi-Fi is then connected to the rest of the world through satellite. So for small communities, you can see that you can do this in a very cost-effective manner.
Thanks a lot for your interesting contribution for connecting the unconnected, and I appreciate the idea of this terminal capability. So final question for Professor Zorzi. I'm referring to millimeter wave use. I would like to know what are the challenges you see in the non-terrestrial system, what you think they can do with non-millimeter wave.
Yeah, so thanks for the question. Besides the usual issues that I mentioned already about the path loss and the blockage and the Doppler related to mobility, in a non-terrestrial network scenario, there are some additional challenges. So Doppler clearly is much more important because if you think of LEOs, for example, the speed of the satellite is very high, and so Doppler frequencies may be much higher than usual in a terrestrial setting. Also, there is a lack of channel models for these air-to-ground links. So we have many such models and a well-established knowledge of how to deal with these channel models in a terrestrial setting. But in this aerial setting, very much less so. And so I see a need to make measurements and provide a good models that can be used to design our systems.
Thank you for your presentation. So there will be room for millimeter wave and 6G. Thanks. So I think we are running out of time. I have to thank the speaker that have provided a very great value to, and I would like to thank the organizer for such a beautiful location and for giving us the possibility to be here. Thank you very much.
So as Giovanni says, a huge thanks to our panelists. And Giovanni, thank you for guiding us through that session. And I'm sure you'll agree there was a huge amount of fantastic information, really interesting information there. So thank you so much indeed. Thank you. So if I can invite our panelists to now retake their seats in the audience. And we're moving on to our next technology demonstration. Now, this technology demonstration is one that's a little bit different because we've seen some videos of some fantastic technologies, fantastic demos that have been taking place, both here in Saudi and elsewhere in the world. We're now going to have a live demonstration. So we're going to have a demonstration which is going to be linking up live to an aerostat somewhere on the east coast of America. So if I could welcome to the stage, please, our moderator for the session, Abdulrahman Al-Najdi from CST, and also our panelists and the guys who are going to be leading us through the demonstration. So it's the teams from Alteros and from World Mobile Group. So we're just going to do a quick move around with things here, and we'll be back with a demo in just about 30 seconds or so. Perfect. So once again, I'll pass over to Abdulrahman to lead us through the demo. Abdulrahman, over to you.
Thank you, Dan. Good evening, ladies and gentlemen, and welcome to another demonstration technology that we'll have today as a live demonstration, connectivity from low atmosphere. It is a great technology we will have it today, and a new idea of new tower from our guest today. Let me introduce to you first the Alteros team. The Alteros team, they are the creator for the first autonomous aerostat. They have the primary innovation called aerostat autopilot, which is one of the greatest autopilot provider in the market, especially for the aerostat. They have the last project called ST Felix, which is adorable autonomous aerostat, which means that you can deploy the system within a day to provide the service within a certain area. It is my great pleasure to introduce to you the CEO and the CTO, Ben Klaas, raise your hand, and the director of the sales, George Allen. Also, we have the World Mobile in here. Join us this evening. The World Mobile, they are a dynamic global mobile network that built by blockchain and shared economic. They focus on connecting the unconnected. They are using the air and ground infrastructure. It's my great pleasure to introduce you the Chief of Investment Officer and Founder, Emmanuel Glath, the Chief Business Officer and Co-Founder, Charles Bernat, and finally, the Head of Aerostat Activities, Gregory Garthret. So, I would like to start this evening by saying, what you have, guys? Gregory.
Thank you very much indeed, Abdulrahman. Your Excellencies, ladies and gentlemen, Salam alaikum wa rahmatullah wa barakatuh. It is my great privilege to be back in Riyadh after several years. I worked here a few years ago on aerostats for Dr. Sami Al-Humaidi at the Prince Sultan Advanced Technology Research Institute, which I'm hoping to visit whilst I'm here. But it's also a privilege to be here as part of World Mobile and working with our partners in Alteros, because what we're actually doing as a team is quite extraordinary and disruptive. And I'd like to begin by sharing with you something of our vision.
We're doing things that other people won't do because they're locked into existing ways of doing things. So we're taking an innovative approach to build a new network, and the guys that we're working with have some extremely leading edge technologies that are going to make it much better to deliver telecoms from above rather than, you know, the standard base station to base station to base station solution. We're bringing tether balloons, house-to platforms, wireless mesh, a new dynamic mobile network, and you're bringing them all together into this new way of doing things. Nobody's done it before.
I believe that together we can do this quicker. We're taking existing components off the shelf and we're creating a mobile network from it. So we're in a wonderful position where, although we are starting now, the last mile is actually here and is within sight.
You can learn a good thing from the internet. I learned a language. I never go to school to learn it. Now I can speak French, German, and a little Polish, you know. Connection brings people together.
Internet is so much more than just a utility. It's a human condition. It allows us to talk to each other, connect to each other, share ideas with each other. And it's the single biggest driver of change, usually throughout the world.
We believe that every single human on this planet has the right to access the internet to contribute to the world at large.
My name is Femi. We will be driving into the hinterland, the southern part of Nigeria. Our focus is to go to about 5 rural villages to find out about their use of mobile internet. This is the rural settlement in the Ofarise, and apparently they don't even have a network here.
The only problem we have there is the road and the network service. If we want to call our customer, we don't be able to call very well because of the network service.
Take the next step with Alteros. Their aim is to connect the unconnected and, you know, to use this technology to deliver the communications at a more affordable price. So the solution has been designed and now it's ready. So they've spent many years developing the solution, developing the right size, the different tethers to keep it steady for communications, and we're going to be one of the first to deploy this, you know, new solution to do what they designed it for.
A network built by the people, for the people.
And now, ladies and gentlemen, it's my great privilege to hand over and introduce you to the Chief Executive Officer and Chief Technology Officer of Alteros, Ben Glass.
Thanks, Gregory. It's a real privilege to be here, to have a chance to introduce Alteros. Alteros' mission is to connect people, machines, and data no matter where in the world they're located. And we do that by building the world's only fully autonomous aerostat platform. For those of you who aren't familiar with aerostats, it's actually an incredibly old technology. During both of the world wars, they were used as barrage balloons, and more recently, militaries around the world have been using them quite successfully as a platform for ISR and comms. The challenge with these traditional aerostats, as you can see here, is that they require a huge crew to operate, and this introduces personnel safety risks, and it limits the conditions that they can deploy in and makes them quite expensive. When you contrast that with one of our aerostats, which you see here, you can see it launches, it flies, it lands without anybody on site. So this autonomy not only eliminates that personnel safety risk, but it also drastically reduces the cost to operate these and increases the conditions that they can fly in. So for the first time, we can take what is, for a long time, been a defense-focused technology and bring it into commercial applications like connecting the unconnected. So each aerostat has a few basic components which you'll see here. So we have a helium-filled envelope, which supports the payload, which you can see sort of the bubble underneath the envelope. So that's where the radios and antennas go. That's then connected to the ground, in our case, by 3 tethers, which is unique for aerostats. And critically, that aft tether transmits power and data to and from the payload in the air to the ground equipment. The real sort of core innovation that Alteros has brought to the aerostat industry is what we call Aerostat Autopilot. And this is a suite of autonomy features, multiple layers of autonomy. So starting at the low level, these are the controllers for individual actuators. But as we go up above that, that's when the real smarts start to come in. So the middle layer is what we call AI Flight Director. If you think of an airliner, this is the pilot. This is the layer that's actually flying the aerostat. And then finally, at the highest layer is what we call Automated Dispatch Control, which is akin to the flight control tower. So this is deciding when it is safe to fly, when it needs to land. Here you can see a couple of our products, which you'll hear a little bit more about. But I just want to point out that the ST in the name stands for super tower because it really is just a super tall tower without the steel. It's a much more effective way to get that payload well above what you typically would see with a traditional tower in order to provide coverage over sparsely populated rural areas. So with that, I'm happy to hand it over to George to share more.
Thanks, Ben. I just wanted to take a couple of moments to talk about the benefits that Alteros super towers bring to solve the mission, to solve the problem of connecting the disconnected. The super towers are designed to fly at a maximum altitude of about 305 meters above the ground. So that gives you a view shed to a horizon about 70 kilometers away. And we've already done a lot of work with carriers and with our partners at World Mobile and have been able to reliably demonstrate connectivity beyond 50 kilometers from the aerostat. So that gives you an area of coverage from that altitude and level terrain of almost 10,000 square kilometers. So that would be equivalent to an area that you could cover with 10 to 15 traditional cell phone towers. So by able to do that with one aerostat instead of all of those towers, what are you eliminating? Besides the towers themselves, also the redundant radios and antenna sets, the power supplies for those, the backhaul connections for those. So we're able to bring down the capital expense to cover a very broad area to a point where it's profitable to cover rural areas that here to now have been too expensive to cover because there's not enough population in those areas. Ben showed a couple of the models, the ST Flex and the ST300. Both of them give you that extended range of coverage, but the difference between the two, the ST300 with a 300 kilogram payload capacity could enable you to put on a 12 to 14 sector system. So you have tremendous capacity. You could put that in an area where the population is a little denser. The ST Flex with a 60 kilogram payload capacity allows you to put maybe a 3-4 sector system on that. And that's tremendous in terms of its ability to go into a new location, deploy it rapidly. It can be deployed in a day by a 4-man crew. So you can quickly establish coverage in a new territory, or if in the event of a natural disaster or a man-made disaster, you could bring the ST Flex into a location to quickly reestablish communication capabilities after one of those events. I'd like to quickly talk about the demonstration now before we get into it. And the aerostat is far too big for this room, so we could not bring it here with us. So instead, we invite you to join us in New Hampshire. So instead of being here in Riyadh, we'd like to take you to our R&D center in Fremont, New Hampshire. Cue the video. And just to give you a sense of how far from New Hampshire we are, a little global exercise of halfway around the world or a good chunk away around the world. And what we've done in our facility in New Hampshire is we've loaded a World Mobile payload onto one of our aerostats, and we're going to remote launch it from here in Riyadh. We're going to give it some time to get to altitude, and then we're going to demonstrate connectivity with that payload live from here. Over in New Hampshire, we've got some helpful folks. We've got James from World Mobile and Peter Mitten from Alteros. Gentlemen, how are you?
Good evening, everyone. Welcome to Albany, Penn State, New Hampshire.
Okay, great to see you guys. So they're connected to us right now with a cell phone, just with an AT&T connection. So they're just on a Zoom call from their phone. What we're going to do after we remote launch the aerostat, we'll give it some time, and then we'll have them connect to the World Mobile payload with the CPE on a laptop and demonstrate that connectivity. And they are located miles away from the facility in Fremont, New Hampshire. Gentlemen, great to see you, and we'll check back in with you in a little bit.
Okay, George. If you allow me, George, I would like to invite, or it is my great pleasure to invite our Deputy Governor for Spectrum, Dr. Mohammed Al-Jaibi, and also the head of the space operation of Space Agency to start this to launch our live demo and come to stage and push the button to launch it from here to United States, New Hampshire. So join us.
Welcome. So who wants to launch?
I like launching.
Yeah. All right. Of course, the space agency. Yes. All right. So we have the remote command and control interface up here, and we set. We're just going to fly. Given the time constraints, we're not going to fly too high, but we've got this all set up here, so you can see. Very simple. You're just going to hit the execute launch button whenever you're ready.
Oh, go for it. Yeah. Both of us. Both of us.
Oh, gotta left click it. And there you can see.
And we're takeoff.
So I want to congratulate you. Present. Unfortunately, I only have the one pin, but I'm going to give you an official Aerostat pilot pin. Thank you. So thank you very much.
Ben, I think that's a world record for the distance for a remote launch of an aerostat. We should need the Guinness Book of World Records here for that.
So it's actually, unfortunately, it's a very calm day in Fremont, New Hampshire right now, so you really don't see a whole lot of motion. But if this were a more exciting, windy day, you'd really see the Aerostat autopilot in action. In particular, you'd see that AI flight director layer that I mentioned. And what it would be doing if there were wind is reading all of that weather data, reading that wind data, and actively flying, actively responding to that. Again, it's a bit boring right now, but we can certainly show you some more exciting flights down the line. But that's really the whole point of Aerostat Autopilot, to be able to handle all of those extreme conditions, to be able to maintain a very stable platform up in the air to provide that platform for the payloads.
Ben, I'd also point out we've got the World Mobile ST Flex down in the field going through its commissioning process right now.
Yep. Yeah. So a lot of activity going on in New Hampshire right now.
So, Emmanuel, could you tell us about the system that provided by World Mobile?
Sure. Thank you, Abdurrahman. Salam alaikum. Hello. Before, I'd like to share why we're doing this, before we talked about the solution. There's a fundamental problem in the world of connectivity today. It's been years and decades, and no one has found yet a profitable economic business model to deploy and to connect the unconnected in a scalable way. To deploy assets to connect areas in hard-to-reach locations, or to deploy assets to reach areas that have low dense population. Today, half the world is still unconnected. Therefore, World Mobile has built a profitable economic business model to deploy to connect the unconnected. And this is using a two-pronged approach. The first prong is to reduce OpEx. The second prong is to reduce CapEx. On the OpEx side of things, we are deploying a sharing economy-based business model, allowing the very users of the network to own the network. Very similar to Airbnb and Careem here in Saudi Arabia. We are making a sharing economy model to deploy telecommunications. This will redistribute the wealth of telecommunications back to the hands of the people. This will help us roll out, which is one of our parts of our dynamic network, the terrestrial assets. We'll have people on the ground that are properly incentivized to roll out our air nodes. On the CapEx side of things, we are also connecting from the skies. We are deploying aerostats at 300 meters up, which will provide connectivity at 12 times cheaper versus your traditional towerco model. We'll also be in 12 to 24 months deploying high-altitude assisted balloons at 20 kilometers up in the stratosphere. And that will provide connectivity closer to 100 times cheaper than your classical towerco model. Now, to help visualize what I've been saying, I'd like to share with you a short video of an infrastructure rollout. So, as you see here, that's an aerostat. We call it the super air node. It's flying about 300 meters at elevation in the sky. This is a very similar super air node to what you guys have seen that's actually being launched right now in front of our eyes in New Hampshire. As you see here, it has 3 tethers to control the pitch, yaw, and roll. We need to provide very stable platforms for connectivity. Moving down, once we deploy our aerostats, we're also going to have supporting air nodes on the ground, which is rolled out by our community, by the people on the ground, to help with the capacity-related issues. Once this network has been built, people will have access to internet directly from the aerostat or indirectly through the air nodes. Connection, internet provides a lot of things, including digital identity. It provides internet, obviously. You could go on an e-commerce platform. You could go on Jumia just to simply buy a bottle of water. And this is something we want to provide to half the world that's not connected right now. Moving up in the sky, back to our aerostats. We are, as you can see here, the 3 tethers going back up. We are providing connectivity 12 times cheaper, as I mentioned. The radius, the radio horizon is about 70 kilometers, which is about 13,000 kilometers squared area, which, give or take 70 aerostats would help cover the landmass of Tanzania alone. Moving up, 12 to 24 months from now, we'll be deploying our high-altitude assisted balloons. As you can see here, you have 2 propellers. It's going to be stationary kept in the stratosphere with a payload system in that gray capsule, along with our solar panels, which we hold the patent for this vertical shape and the design. And this will cover a coverage area of 330,000 kilometers squared. Before I hand it over to my colleagues, Microsoft, Facebook, Google Loon, they've tried. Yet, we're still here today in this room talking about half the world being unconnected, 2.7 billion people being unconnected. This is a fundamental issue, and we need to work together to connect the unconnected. And together with Alteros, we will be connecting the unconnected, and of course, all of your support will be very good as well. Thank you very much. I'll hand it over to Charles.
Hello, everybody. Thank you for having us. Assalamu alaikum. So we're all quite lucky to be in a time where I think the problem of connecting the unconnected is easier than ever before. We've got huge advancements in the space and our industry. We've got access to radios that we've never had before, innovation in Open RAN software and hardware. We've got 5G standardization, and we've got things like new spectrum allocations being issued for commercialization. So we're lucky that we've been able to take a bit of everything and really build what we're calling a hybrid dynamic network. On one side of things, we're using customized, patented, long-range antennas that sit on aerostats. On the other side of things, we're using off-the-shelf equipment in a terrestrial manner. We're using licensed frequencies where possible to provide cellular signals, and we're using unlicensed frequencies to be able to provide village community connectivity that we've spoken about. We're also able to then offload Wi-Fi for heavy bandwidth services and low latency services. So we're not here to steal anyone's lunch. We're here to collaborate. We're here to integrate. We've seen a lot of talk over the last few days about satellite technology. It's fantastic. We're here to partner with you guys in areas where you can't propagate the signal to the last mile, in areas where the cost of one of your terminals is a little bit too expensive for your customer. We can help you to propagate that signal. We'll also be working with you to be able to provide backhaul in areas where we don't have access to fiber. So we are not only able to work with you guys, but we're able to work with the terrestrial networks also. These terrestrial networks who have dominated the space and done a fantastic job and paved the way, but they have allocation to spectrum that is just in abundance and not being used. We are proposing with our solutions that we can collaborate and we can help you to use that spectrum so you're not going to get hefty fines every year from the regulators. So beyond that, we are building the sharing economy model, which my colleague mentioned earlier. The sharing economy model allows anyone, anywhere, to be able to own a piece of hardware that they can now give to the network, and they can take part in it. They don't have to actually be in an area with coverage. If they're not, they can partner or match, like a dating app, with someone who is in coverage. And they can share the benefits, they can share the responsibility, and they can also provide connectivity to one another. So by using this model, we're able to build out a scalable approach and spread connectivity much further than before. Beyond this, we believe that what we're doing is more carbon efficient than a traditional telco tower model. So where are we now? Well, we've launched in Zanzibar. It's an island in East Africa. We've managed to deploy around 150 nodes, providing connectivity to 20,000 people at least. The impact has been remarkable. We've seen people that have never had access to the internet before now being able to start businesses online. They're able to access services which we take for granted every day, healthcare, education. And furthermore, with these nodes that we've deployed, because they're solar powered, some entrepreneurs and businessmen in the villages have used this solar power for other means, such as fishing villages being able to now use ice makers and make sure their fish is constantly fresh. So they can now simply send a message to a buyer in the port and not have to wait days for an agent to come, and they don't have to smoke their fish anymore. Languages have been learned, and opportunity and digital inclusion has been given. So beyond what we've already done on the island of Zanzibar, we're actually launching an aerostat. And this aerostat is going to provide blanket coverage to the whole island. Therefore, more people are going to be connected. Fantastic. We're also working with our partners here, Alteros, to roll out more aerostats in other markets. So back to you, George.
Thank you, Charles. Well, the aerostat has been at altitude for a bit, and now that we've reached altitude, I'd like to reconnect with our friends in New Hampshire. Gentlemen, Pete, James, how's everything? I see 2 different pictures of you. What's going on out there?
The more the merrier.
So I'm here in the field with James and our team, and we've deployed a temporary user site using a traditional CPE pointed at the payload on the aerostat. And you're seeing me now via that connection. So we're going from this computer through the CPE over the air a couple kilometers to an aerostat. That aerostat is then optically connected to the ground and to the backhaul, and then from there across the internet to Riyadh to you. And so from us here in New Hampshire, welcome.
Thanks, Pete. Are you able to see the aerostat from where you are?
Yes, we are. It's a bit far away. If you cut to our other mobile camera, you should be able to see it there in the distance. And you can also see our temporary CPE setup as you walk by. So I can't tell if you can see it well enough in that picture, but we're pretty far away, so I wouldn't be surprised if it looks just like a small white dot.
All right. Well, thank you, guys. Thanks very much for helping out with the demonstration. We appreciate it.
You're welcome. Enjoy the rest of the program.
All right. Thanks, guys.
Thank you.
Abdul Rahman.
Yes, George.
Could I invite you to help land the aerostat?
Yeah, sure. Why not?
Okay.
So unlike the manual aerostats, landing an autonomous aerostat is even easier than launching. It is a single button click. So whenever you're ready, hit Command Land.
Okay. Let's go.
Let's do it. Congratulations. You are also an aerostat pilot.
Thank you. Let's give them a great applause, please. Now we are coming to the fun part, which is the question and answers. I will start right now with Alteros. You mentioned a lot of things about super towers. I want to know, is the super towers need special equipment to provide the service?
So before I answer that, I'm wondering maybe we can actually get the, yeah, there we go. We can actually watch while we're answering the questions, the aerostat land. So it should take a couple minutes to come down from altitude. But yeah, no, so the question of what type of equipment we can deploy on our systems is a great one. And we take the approach of trying to design a system that is as flexible as possible to be able to deploy really any type of payload. And one of the advantages of an aerostat and the fact that it's tethered to the ground is, as George mentioned, we can carry tens to hundreds of kilograms of payload, and we can send a large amount of power from the ground up the tether. So that allows us to very easily and quickly integrate, whether it's 4G, 5G, different IoT protocols, we can really integrate any payload. We can work with a carrier to integrate the equipment provider that they already use in their network to make it as seamless of an integration as possible. So again, because we have that payload capacity, we really don't need to lightweight or to modify that off-the-shelf equipment at all.
So it opens opportunity for different type of communication technology, which sounds great. As you know, guys, right now we did the live demo with the very good, clear weather. What about if we have an event with the bad weather?
Yeah, I can take that one as well. So, yeah, I mean, that's obviously a very important question with aerostats, or really any aerial platform that's flying in the atmosphere. Again, a lot of the work that went into building the aerostat autopilot really was looking at what are those edge cases, what are those extreme weather events that we need to be able to either fly through or sense and be able to intelligently land to avoid risk to the system. And so, you know, wind is obviously the first one that comes to mind. And aerostats can actually fly in extremely, quite strong winds, you know, getting up to hurricane force winds. But between AI Flight Director and automated dispatch control, we're continuously monitoring the weather data, the state of the system, and if the winds are approaching the threshold for the system, AI Flight Director will land.
Speaking of landing.
Oh yeah, there you go.
There we go.
Wow. We didn't even plan the timing. But so it'll land just like that. Might be a little bit more exciting if you're in really strong winds. And it'll wait that weather event out. So as soon as the winds drop down again, it'll relaunch itself to resume service. So it really minimizes the downtime. And similar for other weather events, lightning, things like that, it's measuring the lightning field and can detect if a storm is coming, and it'll come down, you know, right in the nick of time, land, wait out the storm, and then relaunch.
Thank you, Ben. I will go to the World Mobile. I will not to go to sleep. I have a question right to me from the audience. The question is, how is the World Mobile model different than the classic telco model?
Sure, I'll take that one. So, as we demonstrated earlier, and as we demonstrate live to you guys from New Hampshire, we deploy aerostats. We deploy ground assets that complement each other to create the dynamic network that we're creating. This allows us to connect the unconnected, to go into areas which are harder to go to, in a cheaper way, not as expensive. Being 12 times cheaper to 100 times cheaper, this allows us to go into these areas, and utilizing the sharing economy, it allows us to scale as well.
Thank you, guys. Unfortunately, we have a short time, so we will go to the remark, starting with you, George.
As a final comment, I just wanted to touch on sort of risk levels and, you know, where technologies are. The super towers use a technology, aerostats, that have been used for decades. All we've done really is add to that modern automation, modern controls to eliminate the costly manpower needed to fly them so that they're economical for use for commercial purposes. But as a platform itself, it's already proven. We've been at the R&D, getting it to the point where it's fully commercialized now, ready for use today as a means of helping to connect the disconnected. So taking orders after this session.
So, Emmanuel?
The time is now. As responsible members of society, we need to make sure that we connect half the world that's not connected, especially in this digital age. The way we do it is by partnering up with great partners. Many of you sitting in the audience today, many of you listening in, and definitely the ones sitting on the stage with Alteros. It's a human right to have internet, like food, water, and electricity. Everyone needs to have internet, not just because I'm born in the US or my colleagues born in the UK that we're allowed to have internet. No, it's a human right. And together, everyone from the live stream, together people sitting here, We need to work together. This has been preached over the past couple of days, and it's the reality. Let's not wait. Let's not just talk about it. Let's actually do it. Let's connect the unconnected, and together we are stronger. Thank you.
Agree with you, Emmanuel. As you are right now, guys, your collaboration, you provided a tremendous live demo communication. We hope this collaboration will continue and provide the connect and unconnected. Bill.
Sure. So I'll build off of some of the themes from some of the discussions yesterday, which is collaboration. I think general recognition that the challenge ahead of us is just massive, and it's not a one-size-fits-all solution. I think what we're building is great for one part of the challenge, but it's going to take all of the solutions that we're hearing about during this incredible gathering of just a super focused set of leaders in this area. And we all have to be working together and marching in the same direction to solve a challenge this big. So we're here collaborating with World Mobile. We're collaborating with other folks that are here this week, and want to continue to grow those partnerships, because I think that's what it's going to take to solve this challenge.
So Charles?
Yep. So at World Mobile, we've been working quite some time now, probably a lot less than some of you, but some time on trying to solve this problem. It's very important to us. We have an entire ecosystem in this room of different solutions that can help to solve the problem. So we need to come together. We need to put our brains, the space experts in the crowd, the telecom experts in the crowd, government agencies, regulators. We must work together, and we must solve this issue. I think for us, we would like to be more open to collaboration. We'd like to be more open to spectrum sharing. And we'd like to see the people who are suffering without connectivity also benefit. And through our incentive scheme that we've created, we believe that we can help both opportunity and connectivity alike. So thank you so much for having us today.
Thank you, Charles. Now, Gregory.
I've been working with airships and aerostats pretty much consistently since 1990. And for me, it's a fantastic opportunity to come and join the World Mobile team to help them through their lighter-than-air vehicle experience, bringing aerostats and stratospheric airships into use in a way that will help people. And by the way, in a way that is consistent with the Saudi Vision 2030. Because improving connectivity, improving capacity is an important part of that vision. And so it's really appropriate that we're all here together with our partners, Alteros, today. Now, we are going to run out of time any second now, but after the keynote speech, we are hosting a reception on the mezzanine level, and we'll all be very happy to answer any questions you may have about either the aerostats, the stratospheric airships, the telecoms part of it, or the shared economy part of it. Please come and see us then. Thank you very much indeed.
Thank you, Gregory. Absolutely, we will participate in your reception. And finally, I would like to congratulate you for the successful of the live demo, and hope to continue to serve and connect and connecting. Thank you, guys. Back to you, Dan.
Fantastic. Look, yeah, thank you so much, guys, and a huge congratulations. I think that was an amazing way to show the technology, demonstrate technology, and very brave to be doing it live. And you've obviously got a lot of faith in your technology, which is great. So fantastic way to do that. So thank you all. Abdulrahman, thank you so much indeed as well. And really interesting panel, I think. First for me anyway, a live demonstration like that. So I think, again, a round of applause for the guys.
Dan, thanks to you and your team. I know that took a lot of coordination to get that all,
thank you, George.
Pull that off, so thank you.
Appreciate it. Thank you very much.
Thank you very much.
So if I could ask guys and our new aerostat pilot to leave the stage, and we're moving straight on to our next presentation. So we've got 2 keynote presentations left, and then following that, we will then be... I'll bring a laptop down for you now. Okay. Yeah. So following the two keynote presentations, we are then going to be having the reception that has been mentioned there, which will be up in the mezzanine area. But before that, I'd like to now introduce a video. Again, we have a pre-recorded video. So Lassina Kone, Director General and CEO of Smart Africa Alliance, unfortunately couldn't be with us, but we're delighted that he has recorded a short note for us, a short video for us, and we're going to show that now. So if we can play that video, Lassina Kone from Smart Africa Alliance. Thank you.
Good afternoon and good evening, wherever you may be joining us from. Distinguished ladies and gentlemen, all protocol observed. First and foremost, I extend my sincere gratitude to the International Telecommunication Union, ITU, the United Nations Office for Outer Space Affairs, the Communications and Information Technology Commissions of Saudi Arabia, the Saudi Space Commissions, and all of those who have supported this forum for inviting the Smart Africa Secretariat to this high-level forum on connecting the world from the sky. Distinguished ladies and gentlemen, Smart Africa's visions to transform Africa into a single digital market with a mission to drive Africa's digital transformations agenda through a bold and innovative multi-stakeholder approach, we cannot achieve the desired benefit of Africa and global digital transformation agenda and the fourth industrial revolutions if connectivity is only limited to the privileged few and places based on the traditional model of commercial viability. The connectivity is therefore not a sum-zero game. We need to create an equitable and a better world for our citizens, and this is one of the reasons why broadband and connectivity is stated as one of the key pillars in the Smart Africa Manifesto. The COVID-19 pandemic accelerated the uptake of digital goods and services across the globe, including Africa, and it has well served as an eye-opener for the need to strengthen the digital infrastructure in Africa. In our work on developing the Smart Africa Broadband 2025, which was championed by Republic of Senegal, a plan to double the internet penetration by 2025. We saw that a greater percentage of unconnected are mainly communities that are difficult to reach and not necessarily viable for the traditional service provider, namely the coverage gap. We also picked up issues related to the lack of affordability, skills, relevant content for the users. And then we also noted the issue of the usage gap where broadband and internet services are available in communities, but the citizens are not using the service due to high cost of services, lack of basic digital literacy, non-availability of and the high cost, of course, of smart devices, and finally, the lack of relevant content. To back this finding, the State of the Broadband report shows internet use grew to an estimated 66% of the world populations in 2021, with Africa recording a little above 40%. Distinguished ladies and gentlemen, as I always say, we cannot continue to do the same thing and expect a different result. There's therefore an urgent need for us to work together, to look for solutions and alternatives that can address both the usage gap and the coverage gap in a sustainable manner. We are at a very decisive moment of the global digital transformation agenda, where connecting the world from the sky is considered a key in addressing both the coverage and the usage gap in a sustainable manner. Non-terrestrial network solutions has been a tremendous evolution in recent years, making the deployment and operations of these solutions much easier compared to what we used to know in the past decade. Smart Africa engagement with some of our private sector members and partners such as SoftBank, MTN, and SpaceX to state few, who are considering the large deployment of a non-terrestrial network solutions for the provisions of the broadband for our member state. That initiative projects a significant reductions in the capital and the operational expenditure of these next generation connectivity solutions. In a more practical way, we instituted the bulk data marketplace, which seeks to federate terrestrial and non-terrestrial connectivity solutions to reduce the cost of the internet and hence solve the usage gap. Furthermore, we started the discussions with the partners in the deployment of a non-terrestrial connectivity solution in the Smart Community Connect initiative, which seeks to solve the coverage gap using the next generation satellite solution. The initial stage of this project is to target hard to reach and difficult area in some selected member state of Smart Africa and offer fast, reliable, and affordable internet solution. There is a need for further stakeholders engagement, capacity building, and increased awareness if we want to maximize the potentials of a non-terrestrial network solutions in connecting the unconnected in a meaningful way, which require a strong regulatory harmonization led by our Council of African Regulators, a consultative organ of Smart Africa Alliance. Ladies and gentlemen, let me acknowledge the contribution of a Smart Africa member state, our private sector members, and the private partner organizations, some of whom are participating in this forum, for their valuable support and contributions and our shared value. To conclude, I wish to invite all the stakeholders to join and collaborate with Smart Africa Alliance by taking advantage of the multi-stakeholder institutional framework to accelerate the digital transformation agenda of Africa to connect the unconnected through the adoption of a non-terrestrial network solution in Africa. Thank you for inviting me. Thank you for inviting Smart Africa to be part of this high-level international forum. Thank you.
So thank you very much to Lassina Kone, Director General and CEO of Smart Africa Alliance, for recording that message for us. So thank you very much to him. So finally for today, we're moving on to our last keynote presentation to close the day's proceedings. And we're delighted to have with us, I hope, joining virtually, Sarah Spangelos, Senior Director at SpaceX. So hopefully we have Sarah with us, and we can bring her up onto the screen now. I know we're a little bit early. We're a little bit early with her time, so hopefully she's ready and we can have Sarah with us very, very shortly. Just whilst we're waiting to get all that sorted, a reminder that after this, straight away, we do have the reception that's going to be hosted by Alteros and World Mobile. That's going to be happening in the mezzanine area. But I can see Sarah, welcome. Can you hear us okay?
Hello.
Perfect.
Yes, I can hear you. Can you?
And we can hear you loud and clear as well. So fantastic to have you with us. Thank you so much for joining us. And yeah, we're honored to have you closing day 2 of the conference with your keynote presentation. And I think you're going to be talking to us about collaborating with cell carriers to provide truly universal connectivity. So really looking forward to hearing your presentation. So I will pass the floor over to you.
Thank you so much. Excited to be here today with all of you. And I'm excited to chat a little bit about Starlink and then also our future and upcoming direct-to-cell program. So with that, I'll jump in. As many of you are probably aware, Starlink has been deployed for a while now. We have over 1 million terminals that have been built, many deployed across the globe, including in 51 markets. And if you go to our website today, we're selling in 18 languages as well. So this is really making a global impact and a really significant impact around the world that we're really proud of. And we're continuing to scale up as well. This is our Starlink terminal. I'm sure many of you have seen this very sleek design. It's actually the first commercially available phased array antenna and can be easily set up within literally minutes and provide broadband connectivity at extremely high speeds at an affordable price point as quickly as in a few minutes, and very easy to set up. I'm very excited. I've had personal experiences setting this up for my parents at their cottage in Canada, at a German castle, all sorts of places where we may not have traditional terrestrial connectivity. This is offering a service that allows us to connect and have really high speed to be able to work, to play, to do school and finances and all of the things. So we're very excited, and you can certainly check this out on our website right now. In terms of availability, it's very exciting to see us continue to scale up and scale around the world. That's a combination of deploying more satellites, deploying backhaul laser communication to be able to connect even where we may not have terrestrial ground stations and gateways, as well as regulatory approvals, which is obviously a big challenge around the globe, but the Starlink team has made incredible progress. As I mentioned, we're in, I think, 51 markets, many countries. And you can see from this map, the light blue is where it's available today. And as we go to darker blues, it's coming online due to additional cell capacity and also regulatory approvals. Pretty exciting. Last week, we turned on all of Australia. We also turned on the northern parts of Canada and the US, all the way up to the North Pole. So some really exciting progress, and we'll continue to see continued expansion as we get more regulatory approvals, as well as launch more and more satellites around the globe. In terms of use cases, many people are familiar that Starlink is obviously super appropriate for residential use cases. So for home internet, for people that may be in rural or remote locations or just have poor connectivity. There's also a lot of other use cases that we are starting to expand and explore, and you can see those on our websites. One is in the community Wi-Fi space, so trying to light up communities that may not have access today. This can also be applied in schools and hospitals and things like that. We have a maritime product that we released a few months ago, and that has been huge for lighting up boats and yachts and fishing vessels all around the globe. We obviously have a business product as well that's useful for businesses that may be operating in rural, remote locations. We've done a lot in the disaster response space. Many of you have probably seen our efforts in Ukraine and around the globe. We continue to scale that up, and we're really proud of the service we're able to offer those that really need it in these times of crisis and emergency. And then we've also rolled out a really exciting aviation product in the past few weeks here. And I think we'll see this more and more on commercial flights that we take. And then there's also a private aviation component of that that's super exciting that we're scaling up, and people want high-speed internet as they're taking flights. So we're able to offer that for kind of the first time ever, which is super exciting. There's a lot of other use cases that we'll be rolling out as well. So this is kind of a snapshot of where we are today, and stay tuned for kind of additional things that will come out. Wanted to highlight a few that we're particularly proud of. We've done a lot in connecting schools. This is obviously essential to make sure that students can continue learning. This was particularly relevant, obviously, through the COVID-19 pandemic. And we're really making a huge effort to connect underserved communities, looking to connect tens of thousands of schools and students around the globe over the next continued years. Another area we're very proud of is the disaster response. So this can be deployed in minutes. You can see it can be transported and plugged in with an aircraft or a vehicle or other sources of power, and can really be a critical piece of infrastructure when other sources of power or terrestrial communications may go down. And first responders are starting to use this around the globe, and very excited about the ways we've been able to have a huge impact in this space. And with that, I wanted to pivot over to direct to cell. So that's a little bit about Starlink. That's our broadband business where you can buy it today. It's up and operational. As we look to the future, we actually announced direct to cell program in August at Starbase and through our partnership with T-Mobile and SpaceX. And what we're essentially trying to do here is provide ubiquitous connectivity to existing cell phones. So the vision is that in about a year and a half, you'll be able to go outside with whatever phone you have in your pocket, no modifications to the cell phone required, and you'll be able to connect directly to future Starlink satellites. With this program, we'll connect almost globally, so plus and minus 58 degrees, and essentially eliminate cellular dead zones. So we're covering all the space in between and around where existing terrestrial coverage is today, including over oceans and lakes and crazy terrain that is traditionally very difficult to cover. We're hoping to offer this as early as 2024, pending, of course, regulatory approvals by country, and then have full global continuous coverage plus and minus 58 degrees in early 2025. And really wanted to emphasize the point I made earlier that no modifications are required to the cell phone. So no hardware, no firmware, no software, no special apps. Your phone will just work as you roam from a terrestrial zone out to a satellite covered region. The services that we will offer with this, we're starting first with outdoor text. So that'll look like SMS and MMS. And this is largely due to the latency we'll have when we first start deploying the constellation. Then as we launch more and more satellites, which SpaceX is very uniquely equipped to do with our Falcon 9 and upcoming Starship rockets, we'll be able to layer on voice and data services. This is really useful for remote connectivity for rural, emergency, and off-the-grid and backup comms. An example use cases, we've all been in that situation where we're out hiking or walking or biking or camping and we're out of coverage and it's getting dark and we're a little bit lost. We really want to prevent all of that and create kind of peace of mind regardless of where you might roam on the planet. So that's kind of the consumer use case. There's also a ton of use case in the enterprise space, particularly IoT, maritime, and logistics markets. So we'll be able to connect unmodified, cellular, off-the-shelf, or commercial off-the-shelf IoT components that have traditionally been connected to terrestrial towers can now connect to the satellites. And then, of course, the government and emergency use cases, firefighters, and disaster response is another huge use case that we'll enable with this capability. In terms of how this works, very similar to the announcement we made with T-Mobile, we're partnering with a telco partner, and we've had over 50 telco partners come inbound around the globe since that announcement. Very excited to partner with us. And we really partner with a telco to provide this service jointly to the telco and customers. We would use the telco's terrestrial spectrum, and we use it in a way that looks essentially the same as if it was a terrestrial system. So same power level, same interference, no changes to the hardware, the firmware, anything required. And we don't compete with terrestrial networks. If you're in range of a terrestrial network, your phone will always pick that up first because that's a better service that will provide you higher bandwidth, lower latencies, etc. This is really to be just a way to connect when you're outside of those terrestrial zones. The benefits to the customers are probably very obvious to this audience. You can connect wherever you may travel. We are also making sure that this is truly international. So if you have a plan here in the US and you travel to Canada, you can still stay connected, or wherever you may go, that also is offering the direct-to-cell services. And it really gives emergency comms and peace of mind to everyone and your entire family and anyone that might want to be tracking you and knowing that you're safe wherever you may go. The benefits to the telco, there's a few different angles here, and we find that telcos around the world see different types of value. The key one really is customer growth. So telcos want to be the first to market with this service like T-Mobile and be able to attract additional customers, be able to do marketing, and also to generate more revenue through this opportunity because of the value add that it provides to the customers. It's also a really unique and kind of the first time that many telcos can monetize spectrum that has traditionally not been economical to deploy cell phone towers or fiber before. So many telcos come to us and they say, like, I have spectrum over all of Northern Canada and I have no way to monetize that. How can we partner to make sure that we can provide a service that's super useful to the customer, but also bring some economic and revenue advantage to those Canadian telcos, for example. In many countries, we find that the telcos are really excited to partner with SpaceX because we enable them to fulfill their national coverage requirements. that may be set forward by their governments. And this is a beautiful way to do it with satellite coverage, that really covers the entire region from the sky. It's also beneficial because it's a potential backup emergency system if there's power or tower outages, which we've seen a lot of in recent years, especially with natural disasters and other things that have happened. So lots of benefits to the telcos and the customers. So we really think this is a win-win to bring to the world. And then I know I have a bit of a regulatory audience as well, so did want to just kind of provide a high-level view on how we approach that. We basically will work with the telco. SpaceX will apply to the regulator to use the conventional terrestrial spectrum, which is licensed usually by the telco, to use it for this direct-to-cell system. We make sure that we do not violate any of the in or out-of-band regulations. We are very careful to make sure that we don't create any additional interference. We follow all of the compliance requirements from the ITU that I list there. The LTE handsets are already certified to connect, so we don't require any additional type certification. So that really speeds up the time to be able to provide this. And we adhere to all of the same terrestrial regulations. When we work with a telco, we typically require exclusive use, meaning just SpaceX has access to 5 megahertz of the uplink and the downlink. And this needs to be in the range of 1600 to 2700 megahertz in 3 GPP defined FDD LTE bands. And ideally, this is nationwide or nearly nationwide. I list our ITU filings if anyone wants to look those up. Those were submitted in August. And in terms of our progress to date and where we're going in the future, a lot of regulators are very excited. Some have even come inbound to SpaceX to figure out how we can partner this to their populations and their geographies. We've had over 50 telcos come inbound, and we're working through figuring out who the best partners are and how we can onboard. Many of those we've obviously signed with T-Mobile. That was a very exciting deal and announcement. And if you're interested in learning more, if you're a telco or a regulator, feel free to email me and our team at direct2cell@spacex.com, and we'll figure out how we can potentially partner. And with that, I think we're on to questions.
Mic on, please. Thank you. Sarah, thank you so much for that. And I think before we go for questions, let's all give Sarah a round of applause if we can. So thank you very much, Sarah. No, and it's really interesting to hear more about your plans and obviously everything you're doing there at SpaceX. So, a few questions from my side. So, first of all, obviously the announcement now has been made in the US with the link up with T-Mobile. Can you give us any idea on time frame of when you're expecting kind of services to actually be available there?
Yeah, absolutely. So we're hoping to do beta testing at the end of 2023, so about a year from now, and then offering commercial services starting with text in early to mid 2024. And that'll be pretty similar around the globe. The higher latitudes are obviously easier to cover. And as we get closer to the equator, a little bit later, maybe late 2024 for that text service. And then layering on voice end of 2024, early 2025, depending on latitudes.
Mike again, guys, please, thank you. And you mentioned that you're talking to other MNOs and things in other regions around the world. Can we expect any kind of announcements on that in the coming months, years? Are you going to give us an exclusive? No, no exclusive now. But is any more kind of announcements expected soon on that?
I sure hope so. We've got a lot of excited telcos. I expect maybe we'll have 3 or 5 kind of end of year, beginning of year. There's several in the kind of later stages of negotiations, and we're trying to move as quickly as we can. We want to get everybody onboarded so that by the time we can offer this service, we have regulatory approvals and have done all of the technical and marketing work to make sure it's super successful.
Fantastic. And maybe one final question. So when we're looking at kind of direct-to-cell, when we're looking at kind of 5G, and maybe even looking beyond 5G, how do you see it fitting with that? And can it support those speeds as we maybe start to move beyond 5G as well?
Yeah, so we're starting with a 4G system, and that's largely due to some of the link budget limitations and spectrum limitations, but we still think it will be a really high quality experience for the customer. We can certainly extend to 5G. We have all the hooks in place. We just require more spectrum or a little bit more give in the link budget. So bigger satellites or bigger antenna or more power, one of those. And I see no reason why we can't expand to whatever the future looks like. I know there's about 6G and things like that. So our team is keeping really up to date on all of those changes, and we'll be folding those in as they make sense. But I think we'll continue to see evolution of this as well, just like we've already seen with the Starlink network. It's really incredible to see what the SpaceX engineers do kind of year after year. So it'll be an exciting future to watch.
Fantastic. And yeah, we all very much look forward to watching that evolution over the next few years. So Sarah, thank you so much for joining us. Really do appreciate that. So once again, round of applause for Sarah Spangengo from SpaceX. Sarah, thank you.
Thank you so much for having me.
Thank you. And a great way to finish off our second day. So thank you all again for sticking with us again. I realize it has been another long day, but there's been so much going on, and really do appreciate all of our speakers, all of our participants for their contributions, and I hope you've been finding this as interesting as I have. It's been fascinating to hear about everything that's going on, and obviously to see things in action with some of our technology demonstrations as well. So you're pleased to hear we're over for the sessions in here, but we do have a networking reception. So our friends at Alteros and World Mobile are kindly hosting a networking reception, which is going to be happening on the mezzanine area, so out the back of the auditorium and up the stairs, and there's going to be drinks, food, and we hope you're all able to join us for that. And we're going to be back here then again tomorrow morning at 11 o'clock. Again, we're going to be starting, and so we hope you're all able to join us then for that. But once again, thank you all so much, everyone here. Thanks to everyone who's watching us online. I know there's a huge number of you tuning in online as well, so thank you to all of you as well. Wishing everyone a very pleasant evening. For those of you here, enjoy the reception, and look forward to seeing everyone back here again tomorrow morning. Thank you.
guys.